The intensive agenda today as well. Thank you to everybody who are already here in room. Now it is rain a little bit, and maybe people only waiting for this situation. But anyway, we will start now, and I have some information first. About poster session, can you see that people place poster here in this room? It will be short presentations in the last part of the conference and discussion here about the posters. It is first. Second, we have now 4 sessions, and all your presentations should be delivered to sessions chair. The agenda is public. Now please look who is the chairs and if you have any questions, please ask me or organization team. We will navigate you who is responsible. And please give your presentations at least 5 minutes before beginning of the session. I forgot something about poster, about sessions. And we will start now. Now is the session 2, and I'm really happy to invite here on the screen our first speaker from Commission, from DG RTD, Martin Polika. Okay, but we cannot see the screen now. Martin is the policy officer in the Green Transition Unit of the DG Research and Innovation. As part of the circular economy team, he deals with programming of research and innovation topics for the Horizon Europe work program in Cluster 6 in the area of circular economy. Martin mainly focused on the transition of circularity on plastics, textiles, and construction sectors. Martin, thanks a lot that you are with us today. Unfortunately, not in presence, but okay, it happens, and we're happy to hear your input talk now. Floor is yours.
Thank you very much, Natalia. I hope you can hear me very well. If you can nod your head, I can see. That would be great. Good morning, everybody. It is my pleasure to be here with you, although online. Last year, I could be in presence in the first edition of the conference. This is the second one, as you know. And I'm very happy to be here and to welcome you to this big community of DPP stakeholders, because this is a very, very important group and an important ecosystem for the future of the digital product passport as such. So it's a pleasure for me to be here and happy to speak to you. My intervention is, let's say, going a little bit more higher up, because you're going to dive into specific aspects of each project and technicalities and architectures of IT and etc. But I wanted to first kind of set the scene today and to zoom out of the expertise that is in the room there, and to look into the broader perspective of a little bit what was discussed yesterday by my colleagues from DG Grow and DG Environment, from the policy view in terms of the eco-design and the DPP as a tool. But I wanted to also add another perspective to this, and that is the R&I, the research and innovation perspective, and the circular economy, which is the big framing of the whole story of the digital product passport, where it makes its it is an important piece of the big puzzle, so to say. So I will have a couple of things to share with you, and I'm gonna go through my my first slide. So just to set a bit of the policy context here for everyone. So what is circular economy, right? What is circular economy? What are we talking about? I mean, we're talking a lot about infrastructures and IT tools and everything, but what are we talking about here as circular economy? What is it? Well, it is a conceptual departure from a linear take, make, waste economy to a circular economy, and that is something that is sometimes being mixed up when people talk about, even sometimes experts, when they talk about circular economy. Circular economy is not a sector. It's a concept. It's a principle. It's a principle of how the economy works. It is a systemic approach to design of processes, design of products, of services, and of business models. And there, as you can see, in each and every part of this, digital infrastructure and sharing of data in a digital way, in a harmonized way, is absolutely necessary for it to succeed. In circular economy, resources are used in a restorative and regenerative way. So we're not looking into waste. Circular economy is not about waste, not about waste only, which is, again, a very often mentioned mistake. It's not about waste. It's about restoring and keeping resources in the loop as long as possible, and to prolong their value and maintain the value as they're embedded in the products. What circular economy is striving for in the long term is to slow down material loops, narrow them down, diversify, and in ideal case, close the material loops. So we really need to look not only at the end of life, not only at recycling, which is currently unfortunately the case mostly, but we need to look up as well, up to our strategies, as we call them. And we need to try to achieve material efficiency as much as possible to maximize it. In an ideal world of circular economy, material losses, such as waste and emissions, and their negative impacts are minimized. So this is to frame circular economy and to make ourselves realize that the way we're going to use the DPP and all the tools that are going to be enabled by DPP should contribute to all of these. The next thing is a huge a puzzle, or let's say a universe of regulations of the regulatory landscape that we have, and many of you have seen this many times before, I'm sure. But it is a really complex environment that we are navigating in as businesses, as public administration, as company citizens, everyone, stakeholders, and we need to really try to orient ourselves and to understand each and every piece. And every value chain has its own regulation that need to follow on top of that. So it is really a complex problem, and it's going to need time for everyone to understand what all is necessary to be done. So I mean, Waste Framework Directive, Waste Electronic and Electric Equipment Eco-Design Regulation, Construction Products Regulation, Batteries, Critical Raw Materials Act, Packaging, End of Life, etc., etc. And on top of that, we have the upcoming revision of Public Procurement Directive, European Product Act, Biotech Act 1, and the second one's coming up, Industrial Accelerator Act. I mean, you see them all there. Plus, on top of that, we are now working on the Circular Economy Act, which is going to again add some additional elements to this already complicated puzzle. And besides regulations, there are several plans and strategies, such as the Competitiveness Compass, Clean Industrial Deal, Circular Economy Action Plan, Bioeconomy Strategy, the new strategy which is coming up. So all of these things are contributing, are going to be part of this story. So we need to really try to navigate this very well. So to just speak a little bit about what are the challenges that we still have in the transition to circular economy, and you are probably very well aware of those, but I'm just going to pinpoint some of them, not all of them, and where we are also hoping that the digital product passport is going to contribute to helping to improve the situation and to unlock some of these problems, such as what we're facing today: lack of trust in quality of secondary raw materials, or lack of control over supply chain cooperation, or actually connecting different pieces of different supply chains, not only within supply chain but across as well, or lack of focus on circular design or material efficiency, lacking repair services, or lack of secondary markets, or insufficient information about the quality and the quantity and availability of material. So all these things are kind of barriers that Digital Product Passport, when when implemented well, and when the right information is included in the DPPs and implemented across and along the value chains, this can really help to unlock some of those, at least some of those, if not all of those. And transparency, of course, transparency and traceability, which is the key, obviously, key element. So we need to really look into all of those and to try to harvest the potential through the DPP, because the digital transformation is going to be absolutely crucial for circular economy to succeed. Because without a properly and rightly implemented DPP infrastructure, we're not going to be able to overcome these barriers as well. Now I would like to talk a little bit about the Circular Economy Act, because this is something that is being cooked within the Commission so far, and it is expected to be proposed in September this year. And we're involved in that as DG RTD, of course, with other DGs that are in charge. But we are providing our let's say, the experience from the projects such as yours and other projects from Horizon Europe in terms of what works and what doesn't work and what should be changed. But I wanted to here just to speak briefly about, not in very much detail, but what the Act is going to address. What is the objective of the Act? Well, originally, as you know, that Circular Economy Act was kind of framed to be the act to fix circular economy, but it turned out that it's going to be more focused and more let's say more limited in terms of scope. But it's going to tackle very specific 3 issues. The first issue is to reduce import dependency. So this is related to critical raw materials and e-waste, of course, and recovery of critical raw materials and strategic raw materials. Vis-a-vis especially the current crisis ongoing in terms of international trade. So this is even more urgent than before. And where circular economy obviously is the first thing to contribute and to help. Second is the second objective of the CE Act is to reduce single market fragmentation. So this is about harmonizing rules which are fragmented and not harmonized across member states for secondary raw materials and also for byproducts, because every member state has different rules. So this needs to change and to enable the flow of secondary raw materials. A third objective of the CE Act is to strengthen secondary raw material markets. And this is about really, about supply and demand. So this is about quality, this is about standards, this is about figuring out how we can increase the uptake of secondary raw materials and what are the tools that we can use for that. But so these are the 3 objectives, but what is important to say here is that, okay, this is very good, and this is going to help for sure with some of the barriers that we're seeing in the circular economy transition, but all of these must be supported by taking into account not only the end-of-life stage, as I said before, not only recycling, but also all the product life cycle stages, meaning the refuse, reuse, repair strategies, remanufacture, repurpose, before restoring to the last one, which is recycling. Well, recycling in terms of the hierarchy of our strategy. So this is going to be very important. And also we also need to look into value chain coordination and territorial deployment, which means deploying the technologies and solutions on the local and regional level. For example, in cities and regions, in local context, but also via transnational and trans-regional hubs, for example. Here I'm just going a little bit more detail into the 3 main objectives and what is the rationale there for everyone to understand. So the first objective, to reduce dependency on import of critical raw materials. We all know that Europe lacks domestic raw materials, and therefore we are very much dependent on imports from third countries. But we already have loads of material in-house, inside Europe, that needs to be recovered. So that is the main objective. Also, around 40% of product costs are material related. So the material is one of the key elements that creates the cost. So there's really a lot of value in there that is not harvested. So we need to scale not only recycling but also refining of CRMs and recovery of those. And there is lots to do still in R&I, in research and innovation, so that there still needs a lot of work needs to be done in there. And the reason, obviously, why this is one of the two objectives is that the current critical raw materials policy is not sufficiently addressing circularity, and that is important. So that needs to change. The second objective, in terms of strengthening the single market, as I said, the CE markets are fragmented because every member state has its own rules in many cases, and this an ideal case should be harmonized as much as possible. And this also this is about end of waste criteria for byproducts, mutual recognition of what becomes waste and when among member states. So the mutual recognition needs to be let's say strengthened and make use of more, so that secondary raw materials or products that become waste can travel across borders within the EU, so that they can actually be treated, for example, in another country and then come back, which is today not very easy because of this. And EPR schemes are another thing, another tool that should help in this, because EPR schemes are something that extended producer responsibility schemes, for those who are not familiar. So these schemes should be they are also operating on the national in the national context, because every member state has its own EPR schemes for different product groups, and this is not very much harmonized system, and harmonization of those would help very much in terms of moving the material, making the business case, helping the business case for stakeholders, and actually to scale it up as well. So, and in EPRs, DPP has a huge potential to play if it's taken into account and aligned with those changes. Third objective that I want to talk about is the improving access to feedstock, so secondary raw material markets. As we know, demand for secondary raw materials is low and still remains low in some sectors, especially, but still in the majority of sectors. There are some exceptions, of course, like PET in bottles, but that's another story. But most secondary raw materials demand is low, and it's more expensive to virgin materials, and that is very difficult, of course, for businesses to take it up if you don't have even if you have the same quality or comparable quality of the secondary raw materials. This is now changing a little bit with the crisis on the international trade scene, but so it will be actually a great opportunity to embark more on using secondary raw materials, because some of them are not coming into Europe because of obvious reasons. So we need to work on that, and the CE Act will likely address this issue. Okay, this is for the policy context, and I would like to speak a little bit about Horizon Europe. This is a little bit my home topic, because I work for DG RTD, of course, and our primary task is to write topics for calls for research calls in Horizon Europe. In my case, in Cluster 6 especially, but obviously there's much more. And as you know, the Horizon Europe now is in the period of 2021 to 27. It's in its final straits. So basically, this year we published our work program 2026, and next year will be the last work program published. And with that, Horizon Europe is over, so to say, or is finishing before the next Horizon Europe, whatever the name is going to be, will come into place. But I wanted to just give you a glimpse of what has been funded within Horizon Europe in these 7 years, and so that you have the big picture and the context. So if you look at this slide here, this is very interesting, because we tried to map actually how much funding from Horizon Europe as a whole went into projects that are that contribute to circular economy. So circular economy relevant projects, so to say. And you have, on the left side, you see the number of projects. So we have about, I mean, this is still a rough, this is not exact science, of course, because it's difficult to classify, but we have about, let's say, 600 projects over all those years. Well, this is actually between 2021 and 2024, I think. So there's still much more to come when we know more. at the end of Horizon Europe, but around 600 projects across the 6 clusters of Horizon Europe of Pillar 2 and Pillar 3, which is the European Innovation Council and the innovation ecosystems, is really a lot of projects. And you can see that in Cluster 4, which is the digital industry and space cluster, that's the biggest one. So there's the biggest number of projects that are dealing with circular economy topics. Then we have Cluster 6 on natural resources and environment, bioeconomy. That's the second one, and in the other, climate, energy, and mobility as well. So there's a lot of projects there, and it was about 3.8 billion euros invested into projects. So this is only R&I projects, most of which you are part of as consortia stakeholders or representing the individual projects. So this is really great. And so part of this segment of this big package are projects dealing with deployment, testing, and validating digital product passport infrastructures in specific cases, in specific value chains, or just testing new ways of how to do that. So this is important to know that you are part of this big picture here. I don't know how much time I have, so I might just accelerate a little bit maybe to save some time. Yes, okay. So I'm just going to jump over this. Here I have a little bit of a description of what we're in Horizon Europe, what are the big objectives, but I think I already mentioned them during my introductory speech. So we're not only trying to look into technologies and new business models and services, but also looking into larger societal transformation, right? So we're not just doing it for the sake of developing new technologies, which is great per se, but we're trying to also help the consumers to navigate in this and to give them tools in their hands so that they can actually make better decisions, right? And to decide for more circular products, more circular services, more sustainable ones, and to help them also explore the potential of not only wasted products and how to recycle them, but also, for example, how to make use of better reuse of clothes, reuse of discarded electronics devices, or I don't know, other different products. So this is very important to keep in mind, and in the context of the DPP. I think two or three last slides here, and this is, I think, the most important ones that I wanted to tell you today. Digital transition is vital in the context of the circular economy transition. So both of these transitions are super closely interlinked, because circular economy is not going to happen if we don't have proper and right digital transition done. And this is where the DPP really comes in place. Because, as I said, information and access to the information that the consumer needs steers the decisions of what people are going to decide and companies are going to decide to do, and also to increase value chain efficiency and the demand for sustainable solutions. So this is important to keep in mind. And what we also see more and more in conversations, which has not has been the case from the beginning, and my colleagues in the room might elaborate on that in the panel this afternoon or tomorrow, is that DPP is more and more seen as a game changer, as a game-changing enabler of exchange of the data that we need to be exchanged. So environmental data, business data, technical data, standards, quality specifications, all these kinds of things, and all this can be, all this is necessary. And what we need to do now, I mean, we all collectively, not we as Commission only, but we all collectively as community and as a let's say all the stakeholders involved in this transition, we need to accelerate the deployment of the DPP and the interoperability, so that we can actually ensure they can be deployed across value chains and taken up by consumers in their behavior. What is also important is that the deployment of the digital infrastructure for circularity needs to be in alignment with the architecture of the DPP. And that is something that we're trying to really hammer out every time we can, to do this in hand in hand. And of course, what we need is to support interoperable data systems across member states and see the DPP tool, DPP as a tool for data exchange within and across value chains. And whatever we're going to put into that for requirements, I mean, recycled content, eco-modulation, CRM component level information, etc., also needs to be supported by EU standards. I mean, but you already all know that because you're the experts working on those parts. So zooming out of this and to conclude, research and innovation is a key for the circular transition, because from an R&I perspective, the picture is much more complex than what is seen from the outside. And shifting to circular economy paradigm is an innovation process. It is really something that is basically innovation, and it is also, I mean, transition to circularity is more than just replacing primary materials with secondary raw materials one-to-one. This is really a change of mindset as well, and it requires novel, advanced materials such as bio-based, but also advanced materials, new product design, eco design, new technologies, new production processes, new business models, new governance, and new consumption models. And when you hear all these terms along, you can probably imagine where DPP in each of the stages should and can and should play a role. And this is my last contribution here. I mean, how can R&I contribute further in this? So, okay, DPP is one part of the puzzle, as I said, but there's many more puzzles as well, still to be filled. And research and innovation is something that, I mean, the actions, the instruments that we have, such as demonstrators, such as testing of new solutions, all these help implement circular economy in reality, right? Or test it and pilot it. And a couple of examples I put here. This is also coming back to the Circular Economy Act. I think here Horizon Europe projects can directly support, for example, EPR improvement. And in EPR, in terms of developing, testing, and deploying of innovative solutions, I see that DPP should also be considered into this story as well, because of the infrastructure behind it. It should totally support the right rollout of EPRs, as well as in public procurement. I mean, public procurement is going to play, hopefully, a big role in all this. And even in public procurement, the DPP should be taken into account even more. And in the last area here I listed is the trans-regional hubs or transnational hubs, and also industrial symbiosis, because there you have a lot of movement of materials among stakeholders, among different regions, among different areas of Europe, and among industrial hubs, etc. And there's plenty of data moving around, right? So that's another corner of the whole galaxy of circular economy. So I will stop here because I could continue talking, but I just hope I gave you a little bit of inspiration for the rest of the talk you will have today. And I will give back the word to Natalia. Thank you.
Thank you very much, Martin, for this great talk and these key points for this research community who are working together really in the focus research and innovation. Yesterday it was more the standardization community and standardization topic. We are starting now our research, and looking how we will develop and support, maybe policy, to implement all parts here in the research innovation community. Thanks a lot, and we are going now to session 2. Marvin, please take over for the session chair. Thank you.
So it's not just me, it's also my dear colleague Stefano. We will lead session 3, not session 2. Before we start, Vajira Kumari, we are still missing your presentations. At one point, unfortunately, we need a stick to put it here. Not now, maybe later, so you need to find a stick. So as an introduction, as it was said just a minute ago, we are talking about innovation, in particular about opportunities and hurdles, the barriers. So I always like to start my presentation with a little quote, and the one that I've found that I find very fitting is, when there is wind of change, when the wind of change blows, some people build barriers, others build windmills. So the first presentation is by our dear colleague Ricardo. He is from senior scientist from NILU, also the Norwegian Institute for Air Research, and he will talk about Shackle, the information models, and how they will be solving all our problems. Ricardo,
thanks, Marvin. Thanks, Stefano. Go ahead. And good morning to everybody. Yes, so what I'm going to present you is something related to a blocker and a challenge that we found working in our CRISE project. And it's all about semantic modeling. So what we realize is that our data models and all the data models related to DPP have been growing up, and from many different perspectives, both in terms of maturity, but also in terms of size and complexity. So we have seen this size increase, and we have seen a process of modularization so that we can group data points in groups and that makes some sense for their purpose. And this creates two kinds of problems. The first one is that once the size is limited to a few dozens, you can still, you as a human, you can still fully understand the overall data model. Once it gets to hundreds or thousands of data points, that is impossible. And the second one is that once its modular structure is adopted, you may have dependencies between modules, and so it's very hard to understand what will happen if you have a modification of one single data point. If this data point is referenced by other data models, you don't really know what is going to happen to the whole ecosystem. So this is the reason why we thought of trying to develop a tool to have a more quantitative assessment of data models. Something that could be that support the inspection and the understanding of data models. And what we are trying to do is something related to model assessment. It's not at all data validation, not only because we don't have enough data yet, but also because it's really a completely different activities. We want to understand if a model is explicit enough, if it is precise, if it is interoperable, and also if it may fit a specific use case that we have in mind. This is the kind of assessment that we want to do. Our contribution has been to develop a tool which we called, with not much fantasy, the Digital Passport Assessment Workbench. And it's something that starts from a Shackle representation of a data model and then computes some statistics, let's say, some indicators. They regard 5 main categories. It's about the model structure, about the interoperability, about how easy it is to maintain the data model, and also about if it fits a specific use case that we have to specify, and if it is enough constrained or specified. And all of this is aimed at, I will go into details about these 5 functionalities, but all it's to support both the data model monitoring and development and evaluation and use and integration, any decision related to that. That is the final purpose. I was saying we have these metrics in different groups and many metrics for each group. But so we are looking at something related to the model structure. So we want to understand how big it is, how complex it is. Then we have an issue related to to constrain readiness. So how specified and how constrained is the model is specified enough that there are no semantic possibility of semantic misunderstandings within the model. And how interoperable it is. Again, if all the details are provided to ensure interoperability between a data record formatted according to that model and some other data structure. How easy it is to maintain, and this is typically a matter of how many, do we have duplicates in the data model? Do we have dangling references, something that creates confusion, and so that will be a problem once we'll have to advance the data model. And finally, as I was saying before, if we have a specification of a use case, is the model fit for that specific use case? And the workflow of using our data model is quite simple. You need to, our tool, you need to specify a profile file. Only one input file is what is really compulsory, in which you say which data model are you assessing, essentially. And then you have optional files to specify a use case and to specify an alignment. This is something more sophisticated, and it is if you, for instance, you want to integrate two different data models, and then you want, this is supporting the idea of understanding how to integrate different data models. But then you run the tool and you get results. This is essentially the workflow. And the way how we distribute the tool is with two channels. One is just a Python package. You can install it, you can run it in your CI/CD automation to check, and this is how we use it, and we intended to use it since the beginning to have something automated. When we release a new version of one of our data model, we can compare it to the old version and assess and verify if we actually achieved what we wanted to achieve with the modifications. And another way to use it is through an MCP server. So you can load it into your AI agent, and the AI agent immediately knows all the features of this tool, how to use it, and can run it. And these are free, open source, whatever, you can use it. And so to conclude the presentation and get to the point better of understanding this tool, we developed a small demonstration, which is a comparison between a selection of some of the C-RISE data models and with a comparison of them with the battery pass data model version 1.2. These are all was done in April, so everything is up to the most recent data model available in April of this year. And the idea is to compare them for a use in a battery workflow, for battery DPP. And the only trick has been that the battery pass is not available in Shackle, so I had to manually convert it in Shackles to have it running, but it's nothing. I mean, it's just a demonstration. So if we look at the structure of the different data models, we find a numerical testimony of what we expected. So the battery pass is very specific to batteries, and the C-RISE data model is actually valid across any value chain and any product. So it's much broader and much more generic. No surprise there. And we have also information about how tight, how specified are the two data models or the two sets of the ecosystem of data models, because actually also the battery pass is modular. And the battery pass is very tightly bounded. The C-RISE can be a little bit better, but it's already very much bounded. And this is some information that is very valuable to understand and to drive future developments. And another aspect is we specified a use case of how a DPP of a battery could be used. And okay, it's completely abstract and it's valid only for the specific specification of a use case. But what we found is that in the case of if we go the way of the C-RISE data model, we have some data points that are not enough bounded and specified for that use case, while if we go to use the battery pass model, we lack some representation. So for instance, the battery pass model does not include diagnostics or use case data, which is actually allowed by the C-RISE model. And again, this is all deterministic. You can run it again and you get the same results always. And this leads to the idea of integrating the data models, and this is also supported by our tool. So we just manually, we went through and identified what are the overlaps of the two data models, which are only actually 14 data points, like the product identification or these kind of things, which are, of course, both in both data models. And we just verified if they are really overlapping, and then we know that that is something that needs to be deduplicated if you integrate the data models in a record. But also, you can check all the rest. You can check if it is worth adding, also related to the use case, adding all together, and if it is actually something positive to integrate these models. So overall, to conclude, the interpretation is that, for instance, of the use is that we have these two different models with two characteristics which we knew already. I mean, it's just a demonstration. So, but it's confirmed by the data and by the metrics that we developed. And overall, regarding the tool as a whole, we have a tool that supports the monitoring of how models evolve. Are they getting more tight and more specified? Are they larger? And so on and so forth in numbers. It's good to understand and to compare alternatives. If we think about alternative ways to express the same DPP, and it's good also to assess the fit of a data model for a specific purpose through a use case. And also it's useful for your internal development of the data model and semantic modeling to identify what are the critical points or where you can improve according to some specific targets. And also, I think it's also something that can help and support once we will have the data to have a better assessment of the data to separate what is in the data from what is in the data model. That's it.
So, thank you for the very interesting presentation. You're still entitled to 2 minutes of investigation. Are there any questions?
Thank you very much. I think Shackle is a very elegant approach, but I think unfortunately RDF mappings are not mandatory for DPPs. So how do you deal with non-RDF representation of DPPs, or is this already a niche problem, not so relevant?
I think it's. I mean, if we remain into the compulsory or minimum set of requirements for a DPP, we don't have to go to use any of these. Not for information content, not for semantic modeling, not for. I think this is only relevant if you think of supporting a more complex functionalities, which is, for instance, in our Horizon project, is something that is a clear demand from some actors which are actually willing to share some information, and they need ways to do it properly and to ensure interoperability and so on. So from my point of view, I think it's not a matter of elegance, it's a matter of selecting probably the most advanced, and then you can way to represent. I mean, could have been done also in other formats, giving up to some other representation. It didn't need to be in Shackle, but I think it made sense to have the support of the most sophisticated, when maybe you are not using all the features in the comparison. But
yeah, but I think you're completely right that at the end complexity will be greater than much more than expected. So picking an approach that also can deal with this level is I think a good design decision. Thank you.
Thanks.
So here was another question, and then we go to the next presentation.
Thanks. So this looks like very important development work, and it's also related to this challenge that we're having, where we look into knowledge graph transformation problems related to the DPP. If I want to better figure out everything about the DP AWB, I see there's an entry in Zenodo version 0.1. Is it this that we should look into, or any other material?
Yeah, there is, I think that from the references in Node, you can access the source code repo, where it should be a link, and there in the README, probably of the source code, there is more information. So for instance, if you want to install in your agent the MCP server, it's registered on the GitHub registry, but maybe there are instructions probably in the README. So, and also it's probably the best, the source code is always the best way to find the most recent version. So. Yeah, I would suggest that.
Okay, thank you. Please a round of applause for Ricardo. So our next speaker is Kiran Kumaraswamy. I hope I don't butcher your name. He's an executive officer and will have a presentation, his presentation on information exchange on critical materials.
Thank you.
Kiran, the floor is yours.
Thank you. Thank you, Ricardo, for the nice presentation and highlighting about the semantic technologies and Shackle. We also emphasize similar technologies in our use case. Yeah. Good morning, everyone. I am Kiran Kumaraswamy. I work at Fraunhofer IWM, which is Institute for Mechanics of Materials. I am by profession, I am a software developer. Today here I am representing our PMDX MapPro project consortium, a consortium of two Fraunhofer institutes and industrial partners from automotive supply chain industry. My topic is today, sorry, in the second slide. Yeah, my topic is critical materials information exchange, enabling digital product passports through semantic digital twins. By the end of this presentation, you will see exactly how we bridge the gap between the DPP mandate and industrial reality only using open standards, but no proprietary components. Imagine you are an engineer at a company that builds diesel engine. A quality issue is identified, like a camshaft is failing. Camshaft is an important part in internal combustion engines to run the internal combustion engines. You need to know now exactly which batch of steel was used, who produced the steel, like who is the supplier of the steel, what were its mechanical and chemical composition properties, and also maybe the carbon footprint of the steel. Then what you do is you call the steel supplier, they email you a PDF which is of like 400 pages, then you go through all the 400 pages, and then you retype this data into your system. Finally, after 3 days, you might have answer for what you needed. Now let's imagine this happening across thousands of parts through dozens of suppliers for every product in your portfolio. Now the question is, how do we manage it efficiently, considering the time and then the potential costs? Also, by now we are all familiar the concept of digital product passport and the visions of various regulatory bodies in EU. In short, the product must be machine readable, traceable, and carry material information like carbon footprint and so on. Now the mandate is clear. What is not clear is how to actually implement this at an industrial scale. This is exactly what we are going to address in PMDX MapPro project. For several decades now, the steel industry has already been using a product passport in the name of 3.1 inspection certificate. Every steel delivery from a supplier carries one such document. This document consists of chemical composition, mechanical properties, heat treatment details, and test standards, and other information. It travels with the material, certifying its identity and quality. However, this document currently it has shipped as PDF document, but not in a machine-readable way. This data neither be queryable nor validated by the computer. The goal of MapPro project is to bridge this gap from analog to digital. Here we are not inventing any new concept. What we are doing is we are digitalizing the one that already exists. A quick introduction of PMDX MapPro project. It stands for Platform Material Digital, extended for cross-company material data and material simulation in production. The project is part of the broader vision Material Digital Initiative. It is a joint project between two Fraunhofer institutes and industrial partners such as SHS, stands for Stahl Holding Saar, a steel producer from Germany, and Deutsch company, which is an IC engine manufacturer in Germany, and technology integration partners Siemens, Credative, and Tech4U. The project aims to solve a real-world use case from the automotive industry, how critical material data must travel from one company to another company reliably, automatically, and in a machine-readable way. Here is our real-world use case. It's SHS in Saarstahl, in Saarland, produces the steel. From that steel, a camshaft or a connecting rod is made that ends up in Deutsch diesel engine. 3 pieces of critical data must travel with this material. The first and the foremost is the inspection certificate itself, which consists of chemical composition, mechanical properties, and other test results. And the second one is the carbon footprint. How much CO2 equivalent was emitted producing this batch of steel. And finally, the product passport, the digital identity of the part itself. Today, all of this travels as PDFs in email attachments. Our goal from the project is to digitalize and automate the entire flow without any manual intervention. Our approach depends on 3 pillars, the first being the asset administration shell. Yesterday, one of the colleagues from IDTA presented in detail about the asset administration shell. I don't want to go in detail here. In short, AAS is an IEC standard that defines how to create a machine-readable digital representation of a physical asset. Think of it as the standard container for the product passport. The data structure, the API, the submodel templates, all are defined by open standards through IDTA. Second one being the semantic digital twin. To represent any industrial data as we use this to represent any industrial data as interconnected knowledge graphs. We use ontologies to provide semantic context, what the data means, how it was measured, who certified it, and which standard was used and when. All this information is queryable in seconds with using SparkQL queries. The third one is the MQTT-based event-driven pipeline, which triggers automatic updates when SHS delivers an AAS data to Deutsch. All 3 pillars are built entirely on open standards, and anyone can use these technologies. How it works end-to-end, SHS engineers record results in their knowledge management system using a semantic data space. Later, our knowledge graph to AAS pipeline, which uses SparkQL mapping, auto-converts this data into an AAS object, which is an equivalent representation of 3.1 certificate. Then later, this AAS is published to a BASIC server, which is an open AAS server, and then later an MQTT event fires. Finally, the consumer backend, which in our case Deutsch, receives this event and fetches this AAS object. Later, this AAS object is reconstructed into knowledge graph at Deutsch semantic data space with full provenance information. Then we can use this data, which is stored in an RDF format, through SparkQL queries to verify compliance checks. Like we can query, is carbon composition within this batch of steel is less than 0.2%, or is the batch of steel's yield strength is greater than or equal to 350 megapascal, and so on. Under 5 seconds, everything is available, no emails and no retry. Here's the quick demonstration of how our cross-company data exchange application looks like. We have developed a small, simple application with the React and Fast API to show how the data can be exchanged between one organization to another organization. So this application interacts with 2 data spaces. The first and the foremost is the BASICs, which is Open AAS server implemented by Fraunhofer IESE, and then the semantic data space, where we can model any kind of data as as semantic data models. And then here in this application, we can see two scenarios. One is the AAS producer and the AAS consumer. In this case, AAS producer is SHS, where the data is modeled as semantic data, and then which is going to be exchanged with the AAS consumer. In our case, it's Deutsch. So here we can see under the steel inspection documents in our semantic data space, we have tried to document the data from the steel batch in a semantic way using knowledge graph. All the data provenance information is interconnected with semantic relations. This is just a view from our semantic data space. And then these are the list of steel inspection documents that are available in the data space. Once we have the data in an RDF format, with this application, with a single click of a button, we can convert this RDF data into an AAS object through our knowledge graph to AAS pipeline, and then it is published into a BASIC server. Once it is published into the BASIC server, then the Deutsch gets notified about the change in inspection document, and then they can easily read this AAS document, convert it back into an RDF representation again using AAS to knowledge graph pipeline, a reverse pipeline, and these RDF data can be imported into their semantic data space. Once you have the data in an RDF format, you can use SparkQL queries, simple SparkQL queries, to check the composition, mechanical properties of this batch of steel according to the compliance you are expecting. And you can easily see if this batch of steel meets your compliances or not by looking into the fail or pass scenarios here. Similar to steel inspection documents, we also have like submodels in AAS for carbon footprint. You can create PCF data for individual components, and also you can create PCF for the entire product itself. Here, the components are actually linked to the product in AAS using the bill of material attribute, and in case of RDF, they are like linked with semantic relationships. So once you import the RDF data into your semantic data space, again, you can write a SparkQL query and you can get the CO2 equivalent of the entire component and entire product and the component itself. So here we can see in the semantic data space, when we navigate into the like the product information, so we can visualize how the components are connected to the actual product with semantic relations. So this is the product, and it is connected to 4 subcomponents with relations, and each node here is a knowledge graph. You can individually visualize the RDF representation of every node. When such RDF data is in the semantic data space, you can connect an LLM agent to interact with this data, and you can ask useful queries from the LLM agent, and you can see the results. So how Mapro delivers the DPP vision? So DPP requires unique product identity. We provide unique IRI for individual AAS and also for the knowledge graph within the semantic data space. Carbon footprint data can be like represented using IDTA carbon footprint submodel version 1.0 currently. And then every data is machine readable through AAS and RDF. We can verify the provenance since we represent all data using semantic representation. By default, it supports interoperability and fair data principles. So this is a live digital product passport for a camshaft created by Deutsch using AAS object. This was recently demonstrated in Hannover Messe. So if you scan the QR code, you can actually see the digital passport of a camshaft that is represented in Deutsch. Some key results, I don't want to go in details. In summary, certificate delivery, CO2 reporting, compliance check, traceability, supplier onboarding, audit, everything used to take several weeks, a lot of PDF emails, and now everything can happen within few seconds through SparkQL queries. This pattern is universal. We have demonstrated it only at the moment for automotive industry. You can also extend it for your domain as well, since everything is open standard. So finally, takeaways. The regulations are demanding machine-readable product data. We have demonstrated it end-to-end with real industrial partners on a live supply chain using only open standards. The architecture, as I said, it's domain agnostic. If your industry moves critical materials across company boundaries and needs machine-readable, verifiable data, this stack also works for you too. If you are interested in extending this to your domain, please feel free to reach out to us. Thank you.
So thank you, Kiran. So you are still entitled to one, maybe two questions, and I already see the first one there.
Thank you for a very nice presentation. Actually, one question about converting knowledge graph to AAS and again to knowledge graph.
Yes.
You do it because updating the AAS data, or you double conversion?
Yeah, the reason why we keep everything in semantic is because to achieve this traceability and provenance information. Yes, with AAS, we can easily digitalize the data and make sure that digital passport standards are met. But in order to have a real-time query, so we believe that semantic technology is the way to go. You can write SPARQL queries easily if everything is represented as triple data as knowledge graph. You can write a SPARQL queries and you can fetch this information. With AAS, I think you have to write Python code to parse these AAS objects and read the information.
And I didn't see ontology in your work.
I didn't want to go too much of detail. Yes, we use ontology called PMDX Macro. Here I have provided the link. I think they have removed it. So you can look into the ontology. Yeah.
One more question, yeah?
Yes, the EN 10204 in its latest revision, so the draft was published in January, it foresees that we can exchange directly data in the form of a JSON structure, including a cryptographic proof. So where do you see the advantage going via the asset administration shell?
Sorry, I completely didn't understand. Can you come again?
The EN 10204 standard that you have mentioned many times so far was a document or PDF only standard. But
Unfortunately, I'm afraid that I can't answer this question because I'm not from the domain, the actual domain. So I'm a software developer by role. So the AAS, the main reason AAS was chosen because of the consortium. So the Fraunhofer IESE, which works, they are developing this BASIX server, an open source software. So they are keen in using the AAS as the critical material exchange. So I think that's the reason why we are going this way. And yeah, the main goal is to use any open standards to exchange the data from one organization to another organization, right, to support DPP. We believe that the AAS supports it by default. So these AAS submodels are created by IDTA, not from any Fraunhofer institutes.
Okay, thank you.
And the other reason we are using is many of the automotive industries are already using, especially the Catena X, Manufacturing X, which they are using. Right now, they all use AAS objects to exchange the information from one industry to another industry.
Okay, thank you.
Okay, please a warm round of applause for our speaker, Kiran. So our next speaker is from the Norwegian University of Life Science, Vajira Kumari Samaratunga. I hope I pronounce it correctly. She will have a presentation also on information models, if I'm not mistaken, and the floor is yours.
Good morning, everybody. I'm Sudipika from NMBU, Norwegian Life Science of Norwegian University of Life Science. Today I'm talking about modeling framework for the DPP system behavior towards explainable compliance and interoperable digital product passport systems. So imagine a battery starting from a journey in a mine and moving through the manufacturing, and it is being used in electric cars. That means a battery or a product could pass its phase in several stages. So DPPs here, we created a capture in information and support transparency and the sustainability. So let us start by looking at why battery passport have become so important in first place. If we look at the battery industry today, it is no longer in a local story. So it is a global one. Yesterday we talked about more in standards, but it is the data should be accessed in real time. So materials may be mined in one country and processed in another, assembling in elsewhere. So finally we use it and we need to recycle of it. So because of this complexity, regulations are asking to gather the transparency and clear circular economy policies and responsible for the sourcing obligations, which can accelerate the data and requirement across the battery value chain. However, there is a challenge because we have intended outcomes with the battery passport should deliver transparency and accountability. On the other hand, most difficult discussions focus on the data standardized and the compliance. So we are looking how system behave once the data begin flowing in the real time. To understand that gap better, we look at the difference between regulatory requirements and how the actual system behave. So here, I try to find out the gaps and how can we map from the requirements to the behavior of the system. Thank you. Regulations do a very good job telling us what the information must exist, things like material compositions, carbon footprints, state of health, these kind of things. But the question comes, how should update the propagation? For example, a company can produce a battery or other products, but it could be vary to user to user. For example, think batteries manufacturing in Germany for an electric vehicle, then the usage of the car and its applicants of the product, the inner chemistry of a battery, for example, it could be vary, and it should be updated in the real time. So then how should risk alert be generated? How should change in battery health be represented? And how should the uncertainty be handled? And who is doing that? How should the stakeholders respond to the new information? So here we can find out there is a disconnect between regulatory layer and the operational layer. So we try to link between compliance rules and the system behavior, also with the reporting obligation together with the real-time decisions, also governance principle together with the automated actions, and data requirements with the dynamic responses. So then, first of all, we need to understand the modeling is important and how dynamic system is behave. First, the battery itself is constantly, I will talk about particularly in batteries. So think about batteries. So then inner chemistry of the battery could change consistently with its usage. So I can identify as, for example of the dynamic behavior, we can identify it as physical dynamics and supply chain dynamics. It's all over the supply chain, it's changed all the time, and also with the regulatory dynamics. So new compliance requirements come in all over the time and update the reporting and emerging sustainability materials. With the physical dynamics, especially with the batteries, so it could change capacity degradation and health of states. It could change with the thermal behavior, the temperature of the battery, so we want to identify those things in real time. We can understand that even though we have a statistic data set or the data regarding to the product, the statistic passport or the snapshot of data cannot adapt representatively by continuous in the involving system. So what is the requirement there? We need to model in approaches capable of capturing temporal behavior and tracking the state of changes, and we need to predict future conditions. It could be near future and quite long future, and supporting adaptive decision makings. This could be the ultimate goal. So what exactly does modeling frameworks look like, and how can it represent the change in the condition? Now we have established why battery systems are dynamic, and next question is how we do the model behavior. So the modeling framework provides a structural way to describe how a system operates. It starts from the current state of the system. It could capture battery health, compliance status, or the material inventory. So then every stage we can consider as an event occur. For example, manufacturing stage is another stage, and usage data or the ownership transfers could be the another stage. So system moves through the defined transitions. So these transitions then provide specific outcomes such as passport. We need the passport updates and status updates, compliance checks, or the alerts or the recommendations. In simple terms, the framework creates a clear chain from the system nodes, what happened, how it's happened, and so many necessary informations. So once structure is in a place, we can make even more powerful by the introducing machine learning or the deep learning to address predictive capabilities. So up to this point, we talk about modeling, what modeling is happening in the system. So now we are talking about how to address using with machine learning, deep learning models, or the lightweight models, or the generative models in the system. So it takes place a step further by helping us understand what's likely happen next. For example, instead of simply recording battery health, machine learning models can predict remaining useful life cycle, so, and the capacity of degradation, even the likelihood of failure. So they can also detect unusual patterns, anomalies, unexpected performance drops in the consistent supply chain data. Then think about a more traditional passport system, how it's answered the question. So traditional passport system try to answer what happened. It's based on the past data. But what we need actually, together with the real-time changes of the inner chemistry of battery, for example. So our models, together with the machine learning, deep learning, even either the lightweight models, we try to explain or give the information related to what is happening now, what could be happen now, or what should be done next. So these kind of insights try to give, and it has quite key capabilities like learn from historical and the real-time data, adapt into the changing conditions and the new patterns, handle complex and high-dimensional data with improving accuracy and reducing the uncertainty. It enables to proactive and automated response. So then we have a question with where data stores. So battery, for example, we can, the data come from battery sensors or the battery management system data, or even from the manufacturing data from the companies, or the supply chain and logistic data. And the result is, our goal is to transit from statistic documentation to the intelligent decision support system. Of course, these insights are only valuable if we can deliver when they are needed. That's where real-time digital infrastructure becomes so critical. So then, having intelligent models is important, but they only create value when they are connected to the right decision infrastructure. The process begins with the data sources as sensors, battery management systems, and manufacturing databases, supply chain systems. So then, top on that, we can use data platforms and analytical layers, for example, cloud infrastructure and digital twins, which can enable connected with the DPPs and take the real-time data to the passport repositories, and machine learning engineers and risk assessment algorithms. So then all data come to the user layer, which helps regulators and manufacturers, and also the recycles, especially we are talking about second life, third life of a battery. So it helps, and also not only that for the consumers. So they have a good understanding of their products, what is happening inside there. Okay, then we have seen technologies only one part of the solution. So the digital product passport to succeed, stakeholder must also take the system. So that raises several important questions. So there with the data ownership, so we can ask who controls the passport data. Not only that, with the quality of the data, how information verified. Then accountability, who is responsible for the model updates, and can decisions be explained? Can different systems communicate? So by looking at this, the key message here is successful DPP ecosystem at the intersection of three elements you can see here, with the strong governance, robust digital infrastructure, and the reliable modeling. Bringing all these pieces together leads us integrated framework proposed in this system. This is the summary of that I have discussed into a single integrated framework. So we can see the layers, how the valuable decision support comes and how it supports informed decision across the battery life cycle. Yes, these are the key takeaways and future directions. So first, data alone is not enough. Second, dynamic modeling is missing the link. Third, machine learning or the lightweight modeling enables passport to become proactive rather than reactive. Finally, none of this work without trust. So we need governance, transparency, and accountability. Interpretability must involve alongside the technical involvement. So to conclude, this work demonstrates how modeling frameworks can bridge the gap between the regulatory requirements and intelligent system behavior in the digital product passports. So we welcome any collaborations and discussions at your comfort level. So thank you so much.
Well, thank you, Ms. Vajarakumari. You're entitled to one question. So is there one question? No question? So I think you had a very clear presentation then. Then thank you, and yeah, second round of applause maybe, and
yeah.
Okay. With this one, I would like to invite Ayman Al-Masart to the floor. He is from the Università di Pavia, and in a double role also from the Committee of Electronic of Italy. He will have the presentation on digital product passport on a digital product passport, and yeah, the floor is yours.
Thanks.
It's a PDF.
Oh, yes, it's a PDF.
It's
Yes.
PDF.
Yeah.
Full screen PDF.
PDF, yeah. Thanks. Okay. Thanks for having us. As already mentioned, I'm a student at the University of Pavia. We're collaborating with the Comitato Elettrotecnico Italiano on the topic of AI and standards and applications of AI to standards. Just a quick word on the GTC 24. You already know from the excellent presentations of yesterday how the GTC 24 is structured. But basically, as a recap, we have these 4 WGs, and 3 of them are actually responsible for drafting the standards. So our role as members of the CLC STPP ASMEA call was to help in the GTC 24, especially in the dissemination phase, together with our partners AFNOR and DKE. So these are like the 8 different modules that were produced by the GTC 24. They're available as drafts right now. And they focus on the various aspects of the DPP system. So the unique identifiers, data carriers, handled by WG2, security aspects handled by WG3, and the various interoperability aspects handled by WG4. So these are very interconnected standards that rely on one another. So our goal basically was to try and figure out better ways of disseminating this work. Basically, we want to help the technical user of a standard, like the implementer, to navigate and understand these requirements expressed by the modules. We also wanted, in the process of doing this, to create a mapping of sections to cited works, and just to generally prepare the standards for automated processing. Our constraints are basically 3: traceability, modularity, and extensibility. We want any inferred piece of information to be traceable back to the source of truth, which is obviously the normative text. We want the system to be modular, to allow to add and remove documents easily. And we want the system to be extensible to work with future schemas, such as the ISO IEC standard information model. Current standards are basically natural language texts. So obviously LLMs are the go-to candidate for processing natural language text today. But LLMs are good at general purpose reasoning. They often lack domain-specific knowledge, though. And fine-tuning, which is basically retraining on domain-specific knowledge, can be slow and costly. So the general strategy that we adopt is RAG, Retrieval Augmented Generation, which is just retrieving relevant context and embedding it into a prompt to an LLM. Before it is fed to the LLM to improve accuracy. This has the added benefit of kind of mitigating the black box effect of LLMs, because we know, at least at a very basic level, where the information came from. We can go back and check it. So the main challenge with standards is that they're very cross-referential documents, so they cite each other a lot. And this brings us to the idea of graph-based indexing. So this is just an example of what I mean by it. This is like one of our initial attempts at displaying a graph from the 8 modules. You can see the big nodes represent each of the 8 modules of the GCC 24. They're connected to smaller nodes that represent sections, which are connected to even smaller nodes which represent external cited works. And there are edges between the section nodes and the external cited works extracted automatically that represent the motivation or reason why a certain standard was cited by a section. We did this just to get a broad idea of what kind of data we were dealing with. So we went further and we tried to refine this information model. So this is the current way this is how we think about the data that's in our index currently. So we have information units. Documents, top-level documents, sections, and parts of sections are all represented uniformly as information units, which can cite one another. An information unit can have one parent at most. This captures the hierarchical structure of standards. And information units can be derived from one or more parent or one or more source information units. This captures the idea, allows us to trace any automatically generated inferred piece of information back to the source that it was derived from. So, as already mentioned, maybe, we're dealing with natural language documents that are represented in non-semantic formats, such as PDF. And the problem is that they don't naturally encode the semantics of the document. This usually lives in the minds of the authors and hopefully also the readers. But if you want to infer it from a PDF, you have to use some heuristics. So we basically start with a pipeline that just takes the PDFs, processes the TOC, so the table of contents, and tries to split the PDF into a document tree. We then take all these documents trees from various PDFs and we integrate them together into a single graph by resolving the references, also using heuristics, so like regular expressions. Basically, the standard IDs all have some regular structure. We also use data from what we infer as bibliographic sections to figure out what standards are being cited. And we can infer what standards that are not present in our local corpus are being cited. And these are also treated as information units. They can be filled in later when we get to the document. The corpus of JC24 standards included about like 600 such information units processed this way. So then we go ahead and, as we mentioned, we're dealing with PDF documents that lack semantic structure. But even when they do have the semantic structure, it's usually not at a fine granularity level. It's usually coarser than the single atomic requirement. So what we do then is we process this thing using an LLM to extract atomic requirements from each section. We do this using a local LLM. And we basically obtain information units that are at a finer level, so the level of the atomic requirement. For instance, you shall do XYZ to system subsystem Y. And we basically we extract these from the normative sections, which we identify using other heuristics, such as the presence of normative keywords, modal verbs. We connect all of this by extracting the entities from the sections and the requirements, and these entities sort of work as a glue in our graph. So to test out the efficacy of these automatically extracted atomic requirements, we do this simple preliminary case study on regulatory alignment analysis. So as you know, the JC24 standards are supposed to be harmonized with the ESPR. Basically, we were able to do this because we already had the Annex ZAs from the JC24 standards, kindly provided to us by the JC24. As you already know, maybe the Annex ZAs are the ones that connect the standard to the regulation that it is basically fulfilling the essential requirements of. So we basically do this mapping by ourselves, and then we check against the golden data that we had from these annexes. We think of this tool basically, you shouldn't think of this as an automated, fully autonomous tool. It's more of a search engine for a human expert that is going to have to verify the mapping between regulation and standards. Or maybe even create it ex novo, the mapping. So they want to have sort of top search results for what sections are relevant, given an essential requirement of the regulation. So we set this K to 30, which is a reasonable number of sections that a human expert can read and check. And we compare these two approaches, a baseline approach where we just use the coarse-grained sections, And in this case, we found at least one relevant section 53% of the times for the essential requirements. And with fine-grained requirement extraction, as shown in the figure, this percentage goes up to 80%. So we find at least one relevant section for 80% of the essential requirements of the SPR. So this shows that this pre-processing step of extracting requirements can actually be useful. So we have this information, we have packaged it together. Now we want to figure out how to actually present it in an ergonomic way so that a standards implementer will benefit from it. So a very straightforward way is just to package it into a single-page application, which just works offline, that gives you a list of all the information units. You can query them, you can search for them by keywords, you can search for them by types. And then you can obviously read the detail view and read the normative text, and also you can jump around using the mutual links between these sections. And we think that this hypertext-oriented view is a useful complement to the more standard sort of case-by-case PDF view of standards, especially if the standards aren't isolated, if they're constantly citing one another. Another evolution that we're currently prototyping is we're trying to put this into a full-featured RAG pipeline where the standard user can ask a question and the system will retrieve these documents automatically, so without the user having to manually traverse the graph. But the user can still, the standard user can still traverse the graph and get and inspect the sections that were cited in the LLM's answer for traceability purposes, and of course read the standards text. So we think, in conclusion, that automated standards processing is coming, and we think that graph-based representations can be a useful complement to ground this thing into the normative text. We emphasize that these are experiments, and we're not trying to build a fully autonomous system. The goal is always to enable a person to make an informed decision based on the source of truth, which is the normative text. So that's it. Thank you, if there's time.
Thank you, Ayman. Right on time, even a little bit time left for one or two questions. There and in the background.
Thank you. It was very interesting work. Actually, we are working exactly on a similar project, but we are going to create a knowledge graph of material composition of different electronic equipments by reading 100 or 200 research papers, I mean PDF of the papers. So we got two problems. One was reading data from tables, which was really challenging. The another was double nodes in the graph. So there is a node in the graph that is repeated in multiple documents. So I was wondering if you have any comment on this.
Yeah, those are actually two challenging things. For table extraction, the first thing, probably we were considering to just serialize it as some markdown table or HTML table that an LLM agent can process and try and see if the LLM maybe can figure out on its own the structure, but we haven't done any experiments on this. And deduplication is also a pretty surprisingly difficult task because, I mean, you can do it at a certain threshold, but then obviously it's gonna have false positives, false negatives. We mostly we think that relying perhaps on lexical checks at the beginning or very shallow with a very high threshold can work. But then perhaps if you're doing it at a higher threshold, you need some human supervision to deduplicate. So it's more of an aid than fully autonomous thing.
Yeah, so in my knowledge, in particular the German DIN is very active in making standards and norms RDF native as a release format. So I was hoping that we will see this maybe for something like the DPP ENs already, but as we see, they are still plain PDFs. So do you expect that it's realistic that standardization bodies will actually work already on upcoming standards in a graph representation and releasing it in such a form instead of parsing the PDFs again afterwards and trying to interpret them?
Well, I'm not really an expert on standards. I think I've seen that something is being developed in terms of the information model by IC. I'm not sure if it's going to be used in the future for like native standards developed directly like this. But I mean, the hope is obviously that it's going to be a thing in the future, and we're not going to rely on non-semantic representations, e-paper like PDF.
We have a comment to this particular question.
I'm not 100% sure to have understood actually, but we are also national standardization body, and you know that we have an intermediate step, which is OSD, which is for ISO IEC, an enabled technology of what you are saying now to get machine readable or also native standards with embedded some kind of this automation and information model inside. Whether it will come faster, the evolution of AI, or faster these machine readable smart standard, we don't know at the moment, but I think it's the real topic right now. Thank you.
Okay, the very last question.
Okay, so it's not a direct question, it's a remark, because unfortunately I have now to leave for a meeting, but I think it is worth to think about a DRP, a Digital Research Passport, because we have heard about similar project here. There's a landscape in Germany which is so fragmented, and I think it's important to keep the links together. So we have a certain number of funded projects on same or similar topics from different ministries, and nobody knows about each other. So, and I think we can step up the whole results of research when we are linked together in a sort of digital research passport.
So, with that, Ayman, thank you. Please give him a round of applause.
Thanks.
And now for the next presenter, it comes from Berlin. He's doing a PhD in innovation economics and at the BAM of Berlin. And he will have a presentation on readiness of SME for the EPP.
Muss euch da hier dran. Ja. Die Zeit. Na. Wenn du noch eine Minute übrig hast. Alles klar. Der hier. Ne? Ja, ja, genau.
Okay, great. First of all, it's my pleasure to be here today. Thank you very much for the invitation. My name is Simon Jojo-Zink. I'm a doctoral student at the Federal Institute for Materials Research and Testing, or in short, you may know us as BAM or BAM, or however you would like to call us. Today, I have the pleasure to talk about SME readiness, a research project which is going on in our department, and we call it Building DPP Capabilities in SMEs. An empirical investigation. So an empirical investigation, to already give you a key hint what we're doing here, is a survey based on innovation economics theory. So this is much less technical, so you can take a breath, because there was lots of technical input, so here's much easier and more simple to understand. I also usually like to start with the quote, same as Marvin. So here from the proposal for the ESPR, it says that the DPP is the cornerstone of the Commission's approach to more environmentally sustainable and circular products. But then when we skip 3 years in the time and go to 2025, there was this very popular result of a study of the German Economics Institute in a future panel where the question was, how prepared are companies for DPPs actually? This is a very well-known result. I would say that the German colleagues here, they definitely know about this. And what is quite shocking is that only 4% last year have already taken steps regarding the DPP. And then around 65%, they're either unfamiliar with the concept of the DPP, or they don't even see the DPP as something relevant for the business, for business models, for the strategic use, and whatsoever. And this is something very crucial we have here. I think you have heard a lot about DPP, what the DPP is already, and about the challenges SMEs also face. So I would like to keep it here rather short. But what we can see is that there are disproportionate constraints when we talk about SMEs. And this is highly important since SMEs are 99% of non-financial enterprises in the European single market, and therefore also constitute up to 50% of our GDP and employment. Here we have a short overview of SMEs at a glance. The role, I think, is mostly clear for all of you. Structural challenges probably as well, because this is, was already covered a lot in webinars and in white papers and reportings from several institutes. But what we can see is that SMEs are facing limited resources, and that especially on a financial, on a technical, and on a human dimension. And when we talk about human dimension, then it's usually a specific lack of skill set, which we have here, which will make it much more difficult for the SMEs than to manage GPP data, to continuously track product lifecycle, and so on and so forth. And then, of course, as you could just see, there's a very low familiarity still ongoing, not only within SMEs, but also in our general economy in the EU. So this is definitely what we need to be careful about. The biggest risk of non-compliance, as you probably might think, is, of course, the market exclusion if companies are not able, who are mandatory to have a DPP, to come up with it. And this we definitely need to avoid. Our aims and objectives now for the survey which we are planning here, we know there are lots of surveys going on, but we take a theory-based innovation economics approach where we try to identify firstly main resources in a comprehensive manner, and then we would also like to identify factors, contextual factors or antecedents which are influencing a capability of a DPP to implement a DPP later properly. Here we also want to, of course, give something back to our sample, where we would like to also calculate a readiness score and kind of give a tool for companies to know where they still might need to focus on, where they can elaborate on, and where they're lacking still resources, and so on and so forth. Since I already mentioned, it's a theory-backed survey. We're at the chair of Innovation Economics, Professor Knut Blind at Technical University Berlin. And here we take an approach, we take one very popular theory of strategic management, which is the resource-based view. You've probably heard about it. It basically means that a sustained competitive advantage of a firm depends on the unique resources, internal resources a firm has, and not only on the external market conditions. And this we frame around the so-called TOE framework, which somehow kind of looks like that. It's not that important to know for you, but TOE, as the name already implies, we look at technological dimension, organizational dimension, and the environmental dimension here. This is mostly usually used for technical innovations about the adaptation process. So the DPP is kind of a special case since it will become mandatory, but we use this as it's feasible for our research. So now when we talk about factors which could influence such a DPP capability, I would like to introduce them to you very briefly on the 3 dimensions of the TOE framework. So firstly, on a technological dimension, what we identified here, we should definitely need to consider are expected benefits SMEs or firms in general see for DPP implementation when they take the technical aspects of a DPP. Then on the other side, when we talk about benefits, we of course also need to talk about barriers and hindrances for DPP implementation, where we identified the perceived complexity of how the DPP is perceived by the company to have an impact on later how the specific firm might develop its capability or readiness towards DPP implementation. Organizational, this kind of intersects also with the resource-based view. So we try to kind of distinguish between, okay, what is now actual contextual factor or antecedent, and what is the resource. And here, as we have heard a lot, we need to be careful about costs. Here we asked about also the perceived cost, because cost is a very sensitive topic, which probably many of the asked sample is not willing to give detailed numbers, but that's sufficient for the statistical analysis later. Then we also have a look at the organizational innovativeness, which means we look on more cultural aspects within the company culture. And then also, since the DPP comes from the ESPR regulation, which aims towards a circular economy, we ask about the environmental strategy and integration to new business models, or how they are trying to leverage a DPP. Environmental context. These 2 are what we definitely need to have a look at, is of course the regulatory side. Here we don't name it regulatory pressure, because as the DPP for most of the physical product groups becomes mandatory, name it regulatory clarity, because as we could see, a very low familiarity with DPPs. And then of course, with more and more sustainable consumer behaviors, we also take customer pressure into account here. This is a very, very simplified model of the conceptual framework. As you can see, it's usually here the paths are only direct relationships which we have, but later when we have the data, we can make more sophisticated analysis where we can also prove interaction effects and go towards moderated mediation and this kind of stuff. So now, what is our current state of the art? It's a cross-sectional survey. Of course, the longitudinal would also be interesting when we see after 2027 with the battery regulation, DPPs become mandatory. But that, I guess, still needs some time to become more feasible in economics research, strategic management research. Now we're in phase 2, at the end of phase 2. So we are currently validating our survey. For the survey itself, how we created the item, since it's theory-based, we used mostly pre-existing measurement scales, tried to adapt them towards the DPP scenario, and also added new items which are relevant for our use case. Then, of course, it goes to the pre-testing phase, sampling, data collection, and so on and so forth. We aim to have around a sample size in the end of at least 200 to 250 SMEs to be asked. We try to disseminate at the beginning, firstly in Germany, to see, okay, how is the response rate? Because we expect the response rate to kind of, not be very high. And then we would like to then later also spread across the European Union, especially the big players, France, Spain, Italy. Yes. We use mostly multipliers. We plan to use multipliers for the dissemination. And then also try to utilize our channels, social platforms, associations, business associations, and other stakeholders. Our survey structure has 3 main blocks, and it starts very basic. For all the surveys you have filled so far, you came across at the beginning always about general information, about multiple descriptors. We have a very comprehensive overview of multiple descriptors we can later use for comparison, but then we also ask about the current status of DPP activities, not only what is the current status itself, but also, hey, maybe as an SME, as another firm, are you also involved in research and development, in standardization? What is the leverage you would take out of the BPP? And then we go over to a readiness assessment, where we ask mainly about the resources, product data management, IT infrastructure, go over to employment skills, top management support, and all the culture, organizational culture variables, and then, typical adoption drivers and barriers to then finally lead to support needs for a successful implementation, to really get to know, okay, what is beneficial to have, not only for the SME itself, but also for policy recommendations. Then, lastly, as I said, we plan to calculate a readiness score. It's, in fact, not very sophisticated, but what we used here is that we have all the variables we identified in the previous steps. We take these as a benchmark, and all of those which are not within the barriers and the challenges challenges and opportunities. Yes, we calculate the readiness score with our variables we identified for product data, IT infrastructure, then organizational innovativeness, environmental strategy, and employment skills. If you're interested in how we calculate it, we also have some backup slides. You're welcome to go into discussion later. I think I would just skip the expected contributions, because I think that's very basic, and you probably can all expect what the results offer, and would like to thank you for your attention.
Thank you, Simon. Unfortunately, we are approaching the coffee break, so we have time only for one quick question.
Yeah, I mean, it's more a comment than a question, because I like very much your graph showing the score, and especially the environmental strategy and the product data, and giving a bit of heads up about the session 6, which is about the SSBD, and which is about this framework, safe and sustainable by design, from the European Commission, that is there to help companies to generate data, by design, where the product, being developed will be safer and more sustainable. So I think there's your score showing that there's certainly a lack maybe of methodology for this company to implement this type of framework. Then they can produce the data required for the digital product passport. Because one key thing about the impact of this digital product passport would be the transparency. There will be a culture of transparency. Then you can see for every product, how safe they are for human health, for the environment. Of course, there will be some some regulation that will say, okay, you need to do that. But there will be a lot of voluntary approach as well for company to show up in their product digital product passport. How much they look good in terms of safe and sustainability by design. So there's a lot of discussion there that will be very interesting in the coming years. Thank you.
Thank you.
Thank you. Thank you, Simon. If you have other questions, soon we will have the coffee break. So you can ask more to Simon. And now the next is Stefan Schäfer. He's a professor at HTW at the University of Applied Science in Berlin. So we remain in Berlin. And Stefan will talk about the barriers to DPP, how to reduce the barriers to DPP.
Okay, so thank you very much for the possibility for me to talk about our research project. And it's quite funny because the latest presentation was almost about the same thing I want to talk about, because I want to talk about the organizational excellence. So I would like to present our work here at DPP for EU 2026, and today I will talk about reducing barriers to adopt the DPP. And this presentation ranges across the topics of following new regulations, going digital in industry, and building the right skills within organization. This research was conducted in collaboration between HEW Berlin, my home, objective partner, and Salzburg Research, and is supported by the Passat project. I would like to take the opportunity to mention my dear colleague Andreas Herbst. Where is he? Andreas? Okay, he's preparing now because he will be giving a presentation shortly on the topic Digital Product Passport Research and Innovation in Austria, insights from the Passat at about 12:30. Okay, so let me briefly walk you through our today's agenda. We start with the motivation and problem statement. Why are we addressing this topic at all? And then I would like to take a look at the state of the art and identify the research gaps I hope our work can fill. The core of the presentation covers the governance concept with its 4 dimensions, the 5-level maturity model we designed, and the role lifecycle information metrics we developed. Herr Andreas. Sorry. We illustrate the approach using an industrial use case from switch cabinet manufacturing, analyzing the governance transformation, and then conclude with key contributions and a short outlook. So the starting point for this work is the growing regulation importance of digital product passports under the European Eco-Design for Sustainable Products Regulation, ESPR. And DPPs are designed to provide transparent, traceable, and machine-readable product information across the entire life cycle. That's what you heard about the other day, and from design to end of life, thereby reducing information asymmetries in value chains. The asset administration shell we learned yesterday, or shortly as AAS, has emerged as a dominant technical reference model for implementing DPPs in industrial settings. Its submodel concept allows mapping heterogeneous information across lifecycle phases. So, however, industrial practice reveals a critical problem. Simply providing a technical correct AAS structure does not guarantee reliable interpretation of the information it contains, and that's my point here. Our key finding is that problems don't just come from technological gaps. The system already has the tools we needed. The real issue is that nobody clearly owns responsibility across the whole product lifecycle, and teams don't coordinate their roles well enough. In short, we address here a governance gap, not only a data structure gap. So, looking at existing literature, 3 dominant research perspectives we found to be distinguished. The first one is regulatory normative works that define which information must be provided, for example, by ESPR and related EU initiatives like SURPASS, or actually, I believe, SURPASS 2. So, second, technical architectural works that describe how the information is structured and exchanged using AAS or other technologies, including submodel design, interoperability, and event-based extensions. That's what we heard about the whole day. And the third point, organizational implementation and governance perspectives that address the practical adoption of DPPs in companies, though these remain the least developed stream, and that's what my speech is today about. The problem, we already know well which information a digital product passport needs to contain and how to implement it technically. But what is missing, however, is a clear model for who maintains, approves, and interprets this information across all roles and lifecycle phases. This is currently just assumed to work out, but never systematically defined. The research question is follows. So here, just a moment. How can this organizational coordination capability be described and structured in a way that allows companies to anchor it permanently? Or in short, the technology the technology is there, but nobody has clearly defined who carries the responsibility and how that should be regulated across the entire product lifecycle. That is precisely what I try to address here. So, before presenting the maturity model let me define what we mean by DPP governance. Here, governance is understood as an organizational capability for the systematic coordination of the provision and use of information across roles and lifecycle phases. In other words, DPP governance describes an organization's ability to consistently generate, maintain, and provide context-appropriate AAS-based DPP information throughout the entire lifecycle. And I don't know any organization who is able to do that at the moment. In other words, this governance capability operates along 4 interdependent dimensions. The first one is the technical mastery you find here. We mean here the ability to provide DPP relevant information in a structured manner in the AAS and to integrate it across life cycles. The second point here is semantic coherence, the consistent role and phase spanning use of terms and data structure. The third one is organizational responsibility that is never before addressed here. That means the explicit assignment of accountability for the creation, maintenance, release, and use of DPP information. Who is responsible for the information we share? And the fourth one is the role-based usability. That means the access to contextualized, reliable information views without requiring implicit assumptions. And that is what we do. We work with implicit assumptions here. These 4 dimensions are tightly interdependent, so progress in one area only unfolds its full effect in conjunction with the other 3. So let's have a look at our governance-oriented maturity levels. So we're building these 4 governance dimensions. We propose a 5-level maturity logic. The maturity levels do not differ primarily in the scope of individual measures. What distinguishes them is the structural quality of governance and coordination. Not how much exists, but how well it is coordinated across roles and lifecycle phases. So the level first we address is the ad hoc level. DPP information is provided reactively, responsibilities are unclear, and cross-role interpretation is inconsistent. That is what we find mostly. The second level is initialized. Initial AAS structures are in place, but governance remains project or role-bound, and documentation is partially there. So, and the second level, defined, it becomes better and better. Roles, responsibilities, and basic semantic structures are explicitly defined across the organization. Cross-role accountability structures are formally documented. The fourth level, integrated, means that governance is embedded in a work process. Lifecycle spanning monitoring mechanisms and structured feedback integration are in place. And the best level you can reach in our concept is the adaptive level 5. That means that governance is fully institutionalized and adaptive with continuous cross-phase learning loops and lifecycle-wide feedback mechanisms. Importantly, our idea is not an analytical classification framework and is just an analytical classification framework and not a normative evaluation model or a certification standard, but we can work on it. So, to apply governance maturity logic, we introduce the role lifecycle information matrix to show where the weak links are. The matrix is built on 3 dimensions: the lifecycle phases of an asset, consisting of design, production, operation, maintenance, and the end of life, the roles involved throughout the life cycle, and the information objects and attributes in the DPP or AAS. For each combination of role and life cycle phase, the matrix captures which information objects are relevant, in which usage contexts they are interpreted, and what requirements exist regarding timelessness, completeness, and reliability, and which role is accountable for creation, maintenance, or release. The 3 codes we use here are C for accountable, meaning a role bears primary responsibility. The U for uses. We mean here, or interprets, meaning a role a role actively consumes for the information, and the V for ensures compliance, meaning a role verifies that the information meets defined standards. So, looking at the example, product engineering bears accountability during design, but uses information in all subsequent phases. If you have a look at the service and after-sales management, you find out that this only becomes accountable for the operation phases onwards. So, the key insight is the matrix is not a new data structure, it is an analytical lens that reveals where responsibilities, usage context, and update logic diverge. Here, it points to where governance coordination is most needed. To ground the framework in an industrial reality, because it was just at the moment we just talked theoretically, I would like to ground the framework now in industrial reality. So we developed a use case from switch cabinet manufacturing with frequency converters, because an SME is working with us in that use case. So in the design and engineering phase, key product-related information is generated, technical specifications, configuration data, and initial documentation is presented here. The challenge here is that since the information is reused across subsequent phases, explicit regulations for its maintenance and updating are critical. Without them, downstream inconsistencies are pre-programmed. That's the problem here. During production and commissioning, manufacturing specific data is added. Serial, that means, for example, serial and identification data, conforming certificates, and so on and so on. The handover from engineering to production creates new coordination requirements. Decisions made here significantly affect the later usability of the DPP. So who is in charge for the changing information? In the operation and maintenance phase, additional operational condition and service information is generated, often by service roles and sometimes maintained outside the initial DPP structures. Differing responsibilities and absent feedback mechanisms produce inconsistencies. At the end of life, sometimes new actors, for example, responsible for take-back or recycling companies, access and supplement existing DPP information. The quality of this information depends entirely on whether consistent responsibilities and update rules have been established or not throughout the entire preceding life cycle. The use case makes one thing very clear. The stability at the end of life is depending on governance structures established much earlier. So I would skip these two and come to the next one. So let me summarize the three contributions I've done before, because otherwise I would talk about more than half an hour. So I just skipped some of the slides here. So let me summarize the three key contributions. The first one, we reframe DPP governance as an organizational skill, not just legal or technical requirements. This means we focus less on data structures and more on how information is actually used within organizations. The second key contribution is that we build a maturity model focused on governance, bringing together four areas: the technical setup, the shared data meaning, clear responsibilities, and the usability for different roles into a clear 5-level framework. And our third and most important key contribution is the role lifecycle information matrix turns this governance skill into a practical tool, making hidden coordination gaps visible without telling organizations they must score a certain special way. They can't find their own way, but they know where they have to work on. That said, this work has some intentional limits. I want also to talk about the limits too, because it's a conceptual approach based on just one industrial use case at the moment, but we're working on other use cases too. So the maturity level haven't been statistically tested or proven to apply broadly. That is what we would like to do. And also, the last limitation I would like to address here is that it only covers the concept of governance capability, not technical implementation or IT systems. Okay, so Let's wrap it up. Let's wrap it up. For AAS-based digital product passports to work well, organizations need governance capabilities that keeps information consistent across roles and the full product lifecycle. The AAS already has the technical tool, is already the technical tool to support this. Problems don't come from technology. They come mostly, in our opinion, from unclear responsibilities across teams and lifecycle phases. The maturity model helps organizations understand and tackle these challenges in a structured way without forcing specific solutions. The role lifecycle metrics makes hidden assumptions visible and shows where coordination is breaking down. So for future research, several directions are worth exploring. Testing the framework in real industrial settings, applying it to other areas like battery or building product passports. We talked about yesterday about that possibility. And building IT systems that supports not only technology, but also governance-aware DPP management tools. And developing certification or audit approaches based on the maturity model. So, this paper lays the conceptual groundwork for future research on managing digital product passports across the full product lifecycle. Thank you very much for your attention. I hope this presentation has provided a clear picture of how governance capability, not just technical solution, is and really key, is a key factor for life-spanning effectiveness of AAS-based digital product passports. And thank you very much. And I'm happy to take any questions now. Thank you.
Thank you, Professor Schober. We were already supposed to have the coffee break, so unless we have really quick...
No questions now.
Quick question, otherwise we'll try to be really quick because otherwise there is not much time for the next presentation.
Thank you so much for your insightful presentation. I have a very quick question that you mentioned that there are 4 dimensions of this governance that we need to structure.
Absolutely.
But do you also see this governance to be structured around levels of levels across the value chain, starting from ecosystem, then coming down towards organizational, then technical, and then data governance? Or, yeah.
Sorry, I didn't get it at the moment completely. So, could we discuss it in the break? Because I don't know exactly how. So we developed this maturity model, but it's just one way to develop it. So you've got different possibilities to do that. It's just one because we developed other maturity models in other cases, and that is just what we discussed with the company. So it's not statistically researched at the moment, if you mean that. But you can work on it, and you can broaden it, or you can use it, transforming it to the life cycle, or whatever you want to. It's just an idea, just a concept to show, okay, what could be the phases of the companies here we want to talk about. Okay. The rest we can discuss in the break if you want to.
Okay, thank you. An applause for Stefan.
Thank you. Thank you very much.
And the next presenter, we don't need to introduce her. We all know her. Is Natalia Konchakova from Irhon Centrum. She's the coordinator of project DigiPass, and she will have presentation on regulatory compliance, always related to SMEs.
Thank you very much. Now it is a coffee break, I know, and we have a delay. And I was really in the thinking to cancel presentation, and it was in the corridor the question that said, what are you doing? General, your project. And we are not really organizer conferences, we are researcher. And I decided to do this presentation very short and really to extract what we are doing. From DigiPass, you will receive 2 additional presentations with more details. And as coordinator, I will give only overview. We are coordination and support project. We are not research project, but all of us are researcher and industry together, and we try to support this community and cover this gap that nobody know each other. Our goal is bridging the different materials development communities, and we are going for harmonization of data for materials. And yes, we are working more concentrated of material side and develop materials passport, and it is part of a digital product passport. It is, of course, driven by regulations, and we consider eco-design for sustainable product regulations, and we are following your standardization work and try to adapt ourselves as well. But we started not from scratch. We started from other projects, mainly from VIPCode. It is open innovation platform for materials modeling, and based on this development, we develop our platform as well. And focus of DigiPass, it is advanced materials data along the whole value chain. Well, here is the main objectives of the project. It is fostering of digitalization of innovative materials and co-innovation process, considering co-innovation process in the circular economy, strength the digital maturity, especially for SMEs. We have two big associations as the partner of the project. It is Composite United and European Coal Coatings Associations. It is multi-faced partner, which are responsible not only one company, it is more as 100 companies in each of them, and they address this development of passport for their particular materials. And additionally, from industrial side, we have the associations for photovoltaics and the nanomaterials hub. It is industrial representatives in the consortium. This aspect about interoperability of data and standardization of data, it is the topic from project as well. Harmonization of data sources and digital product passport, and as the partially digital materials passport. We are really prompt to see that our work is very good aligned with competitive compass for EU, and all policy documents we are considering, and it is in our work integrated, especially this digitalization aspect, advanced materials aspect, and aspect of this cross-border interoperability and other standardization things as well. We have, as I already taught, 4 demonstration cases, and it is beyond of the focused now digital passport from policy, where develop this passport for advanced composite materials, for nanomaterials, for advanced materials for energy sources, and pre-painted metals. How we try to support as much as possible small companies with focus to driving these digital maturities. We are thinking how we can accelerate the uptake of new materials, the advanced materials, and we built our platform with our approach. The platform, you can see here the address, it is open, you can register, you can play and look our approach, how it is implemented. Now we are 2 years after development and can say, you can try and give us feedback, we will implement it, but we are focusing on our 4 demonstration cases. And all aspects, here it's the homepage of the platform. The whole aspects of the interoperability will be explained and addressed by talk of Martin Horsch in session 5. And we develop the business model for digital platforms, and our approach will be discussed by Franz Picker at session 9 of this conference. Well, about challenges, some of them was already discussed yesterday. It is digital passport as standardization concept is lacking, but we have now very good progress. And yesterday we learned a lot about standardization of data approaches and GTC 24, great work. And we're in the beginning, it will be the next step. And next, it is a huge area, very important and very progressive area. Next, it is the standardization and data formats. This interoperability aspects, and the questions about data exchange between different stakeholders, especially along the whole value chain. When you start from raw materials and you would like to finalize by a recycler, and it is not in the frame of one country, it will be more and more complex. Yeah, this question. And next question about infrastructure. Who is responsible for this data, where this data will be stored, and I'm very glad to say that yesterday started one big project from EU. It is Materials Commons project, and we have a special session here about infrastructure, and one talk will be from Materials Commons, and it is idea from Commission-driven idea how to establish this infrastructure for data. And I hope some input from this project we will have here at this conference. The challenge about mechanism to ensure data quality, data accessibility and reliability, and the question about training for workforces who can after our development, after our research, implement and use all our results. All these challenges are considering in the project how to solve it, how quick we will solve of this, and which way is the best one. I think there's nobody answer it. The right answer, it is 42, but what we can do and when it will be. We collect these challenges. We are coordination support project. We collect these gaps and try to support Commission to prepare the actions to solve all these gaps. Good. About Materials Commons, I already told you it is the next project. We investigate our program and call topics. We do not investigate the proposal, call topics, and published end of last year the white paper about possible collaboration with Materials Commons or possible interrelations between DigiPass achievements and Materials Commons future development. You can look at Synodo. It is open, this paper, and it is our ideas how to do it. But we need to communicate more with this project, and we will do it. What we mean about value chain development? The DigiPass is concentrated on materials. It is more or less intermediately product, but it is a part of each product. And we're looking for these different regulations and different requirements from raw materials until the product in the service life, and consider this part which is more relevant for SMEs, to deliver parts of the materials. And we're looking for this innovation landscape for our materials part, and first of all, it is the advanced materials development when we're looking from TERL 3 until TERL 5 for our research development. And next aspect, how to support SME and researcher as well to go to this adoption and upscale. From TERL 6 until TERL 7 with digitalization aspect. And yesterday we learned from panel, it is not easy to not only support to implement all this digitalization from TERL 3 until TERL 6. It is the very big gap, innovation gap, and we try to find the position of project and for development of our platform, our approaches to cover these gaps and to support in the way for advanced materials in market integration until till 8 and 9, but it is not really a research topic. It is an innovation topic, and it is more for marketing. All this aspect for DPP implementation. It is in the topic on the project. And next steps in the development. Conclusion from this digital passport perspective and DigiPass perspective. As I already told that we are focusing on innovative advanced materials and core innovation process. We try to connect DPP and SSBD aspects. It is digital passport and safe and sustainable by design. And to address both these topics, we designed this program with technical aspect for implementation of digital passport infrastructure, and the next section will be safe and sustainable by design aspects. Integration, this concept together in innovation, it is possible, and we try to demonstrate it through our platform and through collecting the specific data for materials we are investigating. Standardization and this semantic collection, semantic development, it is a big topic, very important topic. We learned yesterday and today as well, how we can connect all data for machine-readable form and easy to translation, this form from in form of vocabularies, taxonomy, ontologies. It is discussed, but we all together trying to find the solution for it. We develop the platform, which will be demonstrated in next presentations to support this simplification for SME to go to this digitalization aspect. And we try to support these companies to bridge this innovation gap between TRL 5, 4 till 7, 8. It is all from my side. I'm happy to answer all your questions during the coffee break, and enjoy next session, next presentations. Thank you. Martin, please.
So we're delayed by 15 minutes. We'll have a break until 11:45.
One additional, I say now, Francesco, please, information from cost action. Okay, Yes, please.
Yeah, so very quickly, please don't forget to sign the attendance list just in the desk here. Yeah, sorry for okay, have a good coffee break. Thank you.
Those presenting in the next session need to make sure that their presentations are here on this machine. Correct? It's Salim's machine, right?
No, it is a machine from hotel.
Okay, yeah.
We can use it.
Ja, dann, das wird spannend.
Funktioniert normalerweise.
Ja, wieso? Ach so, ja. Gut. Very well, so we're now getting ready for session number 4. DPP in practice, platforms. We're a bit delayed, but I think all is good. We have 4 presentations in this session. And the first one will be given by Andreas Herbst from Platform Industrie 4.0, Austria. He's an innovation manager and working as a project manager. We have been involved with DigiPass 2, but also with Austrian projects, Passat, of which we heard before, and PACE DPP. And that's, I guess, what we're going to hear about a bit more as soon as we can get the slides somehow onto the screen. Then, please start. Thank you.
Thank you very much. Good morning, everybody. The digital product passport turns products into data, and hopefully in the future data into a value. Let's look how Austrian projects are approaching this. One of the Austrian projects is the Passat. It's together with the PACE DPP, one of the 2 Austrian flagship projects focusing on the development of the DPP. The project, both started in February 2025, runs for 3 years, and in the Passat projects are involved 21 partners, and is led by the Austrian Institute of Technology. In terms of scope, Passat addresses 3 main use cases. The first is the textile, the second one is the electronics use case, and a special use case for Austria, a transferable use case focusing on the ski industry. The project pursues several key objectives. First, it analyzes both functional and non-functional requirements, as well as the relevant regulatory framework for implementing data product passports. Second, it develops generic concepts and components for data and service ecosystems. Third, it demonstrates practical implementation in 2 concrete product groups, while also exploring transferability to another sector. In addition, Passat provides information, support, and training for companies to help them to implement and use DPPs effectively. Finally, the project contributes to international and national standards and legislation, and delivers policy recommendations, including support for a strategic adoption plan for Austria. Before looking to the solution, let's look first at what is missing today. Everybody in the room knows it. A key issue is the semantic interoperability. Data is stored in different formats, PDF in the best case, without a shared meaning, so machines cannot easily process it. There is also no real trust layer. It is often unclear who published the data and whether it can be trusted. Policy and identity management are still weak, with no standard way to control access. Discovery is another problem, as finding a product passport without a QR code, is very difficult. This is where Passat comes in. Passat solves these issues with clear architecture. It enables shared understanding of data using linked data to JSON LD. Trust is added through digital identities and verifiable credentials. Access rules are enforced in a standardized way. And data can be found via structured identifiers, and the system supports long-term availability and future integration with European identity solutions. Our first use case. In the textile product group, a first minimal DPP has already been implemented, containing approximately 40 data points collected from 7 different stakeholders across the value chain, using, among others, the retraced platform as data source. Beyond the initial implementation, several advanced extensions have already been prepared. These include adaptive granularity levels based on the GS1 resolver and digital link standards, enabling different stakeholders to access different levels of information depending on their specific needs. In addition, a demo for zero knowledge proof for chemicals, allowing compliance verification without disclosing sensitive chemical formulation data, has been implemented. Current work focuses on a decentralized DPP architecture integrated into a data space environment to strengthen interoperability, data sovereignty, and scalable cross-company data exchange. Now a special thing. Seam coding as an alternative integrated data carrier directly embedded into textile products is also being tested, shown on the right on the slide. Looking ahead, planned activities include certification mechanisms as well as systematic technology comparisons, for example, evaluating decentralized ledger technologies against data space-based approaches regarding scalability, interoperability, governance, industrial applicability, and sustainability. The second example illustrates how DPP creates real value, as mentioned at the beginning, in a ski service scenario by connecting previous isolated data sources. The process data starts with the ski itself. By the way, our partner works with a QR code since 1 decade and more to identify each ski. Each ski has a unique identifier, as mentioned, with a QR code. When the ski is processed by a maintenance machine, relevant product data, such as grinding recommendations, can be retrieved from the manufacturer in real time. This allows the machine to adjust the service precisely to the specific ski, improving service quality, extending product lifetime, and enhancing performance and safety. At the same time, a complete digital service history is built over the product's life cycle. Now the best thing, maintenance data is also written back into the passport, providing valuable insights for manufacturers and potential second-use consumers and customers. The current prototype has already been showcased at the Hannover Messe and will be tested in real conditions with a larger number of skis in the upcoming winter season. By the way, this is an advertisement to go ski in Austria. As part of the Passat flagship project, my colleague Stefan presented his project half an hour before. The research group in work package electronics is developing a software environment in which electronic products can be linked to the DPPs via ID links. The DPP accompanies the products throughout their entire life cycle. The AAS serves as the core technology for data management. The goal of the work package is to develop a demonstrator for DPPs that serves a platform for the management and exchange of DPPs. Within the scope of this project, topics such as seamless and secure exchange of information across organizational boundaries are particularly addressed. Let's go to the PACE DPP project, the second Austrian Lighthouse project. The core motivation is to provide the vital guardrails and technical solution bricks necessary to tackle the core technological and regulatory challenges for DPP-based data service ecosystem. To build a truly sustainable ecosystem, PACE DPP simultaneously balancing two fundamental perspectives: the regulatory demands of compliance and the practical, value-driven needs of businesses. The ultimate vision is to enable lightweight, accessible DPP services. By doing so, they aim to unlock the hidden potentials of innovative circular economy business model, smoothly transitioning our industry within the context of the European Green Deal. While the technical solution bricks are designed to be entirely generic and transferable across all future DPP applications, the development grounds in two heavily regulated evaluation contexts: the wood and paper industry and the e-devices. The first is the electronic and electrical devices. In this sector, the product lifecycle spans complex phases from design and manufacturing to long-term lifecycle management. The approach explores how a DPP system can be securely handle device refurbishments, track state of health, and enable green configuration. By utilizing embedded hardware security chips and connecting to a shared DPP data space, it demonstrates how transparent data can accelerate compliance checks and support the repairability, reuse, and high-quality recycling of electronics. The second evaluation context shifts focus to a completely different material stream: wood, pulp, and paper. This provides a starkly contrasting supply chain to test the adaptability of the generic DPP architecture. Here, the life cycle begins directly at the source with the geo-referenced forest data and raw wood tagging. And this is not as easy. The material is traced through pre-processing, industrial production, distribution, and eventual recycling. The primary objective is, in this context, is utilizing the DPP to satisfy strict regulatory requirements, such as the EU deforestation regulation. Through specialized DPP services like sourcing, visualization, and automated compliance checks, data continuity is established from the physical forest to the customer, providing that a unified DPP framework can adapt to biological circular systems. Translating real-world use cases from wood and electronic sectors into concrete technical requirements is a highly complex process. To do this systematically and in full compliance with the DigiPass methodology, a strict breakdown path is followed. Evaluation contexts are analyzed to identify general use case patterns, which are translated into detailed user stories. This allows to map out the exact data flows and identify the necessary generic building blocks. These blocks are developed as modular microservices, which are then aggregated into broader macroservices and integrated applications capable of fulfilling the use case. Crucially, throughout this development, custom DPP business model canvas is utilized to rigorously evaluate whether the use case actually requires a DPP system for its implementation. It is widely observed that ideating and assessing DPP use cases is challenging. A DPP use case ideally fulfills two conditions. It is enabled by the ESPR, technically enabled by the DPP systems, or legally enabled by information requirements. It has substantial impact on the ESPR's policy targets, increasing sustainability. Business model canvases are used to handle the complexity of business models. The DPP use case assessment framework was developed to support the ideation and assessment of DPP use cases. In alignment with DigiPass 2 and other projects, a cross-project working group on DPP use cases was created in electronics. The group started to collect and assess use cases in interviews based on the canvas. Last slide. We and the projects like DigiPass 2 are inviting more people to collaborate. I think this is clear, and further steps and to co-author on publications. Please visit my colleague Viola Galina, and as mentioned, Stefan Schäfer, and last but not least, Bernhard Bergmeier, when they are presenting the posters in the poster session in the evening today. Thank you very much.
One question.
About implicit scalable discovery. First question is, why do we need a scalable discovery, and how you address this?
This specific question I have to forward to my colleagues. I have to be honest, I got a lot of input for this presentation, and the technicians or the professionals are behind me, but we can talk in the break.
Good. Shall we then continue, or?
I think we'll go for the next presentation.
Yeah, we'll go for the next. Okay, many thanks.
Thank you very much.
So the next presentation will be given by a representative of the textile and fashion sector, Sophie Preissig, from Monsoon Accessories Limited from London. And she is a sustainability manager at that company with degrees in business and media and sustainable finance. And the talk is titled Consumer Demand and Regulatory Pressure. Now we can see if we can get it open.
Yeah, it's already there, I hope.
Okay.
There.
Hello, good afternoon. Thank you for the introduction. It's been really great to see all this amazing work that's happening around DPP. And I don't come specifically from the DPP sector, but I do work in fashion. And in specific, I kind of head up our 3 brands. We've got 3 brands at the moment in London. Monsoon, Accessorize, and East. And I kind of head up our group sustainability approach across these 3 brands that we own. You may recognize Accessorize, I don't know, we were quite a lot in airports and that kind of stuff, quite international. And then Monsoon is quite clothing based. And yeah, that's our oldest brand, and that's over 50 years old. So at the moment, we are in 23 countries. We have 306 stores across the world. And we turn over about 210 million per annum, which is a lot smaller than what we used to be, but COVID kind of was a bit tough for us. A brief background to our brand. So we are still privately owned by our founder, Peter Simon, and he founded the company back in 1974. Before that, the roaring hippie 60s, 70s, he did an overland trip across the Silk Road, fell in love with the Indian, Afghanistan, and all the other places he went, Turkey as well. He fell in love with their fabrics and then decided to put a UK high street design on it and then sell them back in the UK. So I say this because that heritage on how we operate is still very much part of the brand. So we very much still make sure we integrate quite a lot of handwork, quite a lot of Indian ethnic traditional skills of making fabrics and bringing those to the high street. However, since I've joined, which is maybe about 7 years ago, we had started thinking about sustainability in a bit more of a holistic way. And part of that has been a big journey about circularity. So this is our kind of model of how we start thinking of circularity, and we've been thinking about it also in terms of DPP. So we very much look at our raw materials input, how we do production.
It's okay.
It's okay? Lovely. How we bring that to market, to our customers, how we encourage more sustainable consumption, but also how to use it better, so how to care for your garments, how to repair them, especially these very intricate fabrics that we use. And then we've also worked now for about 7-8 years with the end-of-life sector as well. So in the UK, this is very heavily around the charity sector. I don't know if it's the same here, but all our kind of vintage or resale shops are often like Oxfam or New Life or like charity shops essentially, and that is their way of getting income. So we work with them quite heavily as well. So what we have noticed is that we can't think of anything when it comes to sustainability in a very linear way. Everything you push here causes an effect over there. So we've had to kind of make our lens quite wide, where we look at our product sustainability as well as how that's impacting our people, both in our company and down our value chain, how that also then impacts our planet, and then also we have a little pillar of philanthropy. We have a trust fund, but I'll skip on that. That one's not so important for you. And across all of these areas, we also always need to be continually thinking about how we're communicating and sharing that value that we're creating. So for my presentation today, I'm going to split DPP, this is how we've split in our heads, into 2 major parts and then 1 little middle bit. So the first bit is all about that value creation piece. So our supply chain, how we create value all the way until the clothes are with us. Then we have a little middle bit, which is very much around how we're communicating with the customer, how they're understanding what we're trying to tell them. And then the last piece is that whole end of life and what we do in terms of circularity. And that's how we've started thinking about DP, because we know it's going to cover that whole circle. Okay, so step 1, creation. So, I don't know if you guys know, but textile supply chains are exceptionally complex. We have lots and lots and lots of different stages. They're in lots of different places of the world. And so when you create a little map of what a normal textile supply chain looks like, you get this, which is crazy complex. And I don't know if you've ever noticed, but all the diagrams that show what a supply chain look like, they're always very nice and linear. However, the problem is when you go into practice and you notice actually they're not linear, they are super dynamic and they are continuously changing. And even one order might be made half this way and half that way. And then that's completely different actors in your supply chain. And it might change week by week as well. So I can give you a little bit of an overview. We've done quite a lot of mapping. As I said, we've been thinking of sustainability in a holistic approach, but one of the key focuses is on our hand workers. So we specialize in ethnic, traditional skills of fabric making. So up here I've got just 2 examples. The one on your left is called block print. That does 2 things. They carve out of wood the pattern, and then they print it by hand across these massive fabric sheets. And the second one on the right is screen printing. So this is where they've got a design, and then they've got these, I don't know if you can see in this small one, they've got really, really, really long strips of fabric, and then they're just with one big screen putting on the dye, and they'll do each color bit by bit. If you want, I've got a little video. I'm going to try and do this slickly. I've got it open. But this is a little bit of what working in India is like. So this is our brand. You have this incredible contrast in India as well, of these magical places, but also the hustle and bustle. And this is an example of one of our dresses and how it gets processed. And this is soft organic cotton, how it gets dried, how the wood blocks are then carved. And then how the dye comes in. And they're huge sheets of fabrics. And then they literally get hand stamped. And each color is a different stamp, if that makes sense. I can try and speed it up. But yeah, this all then creates just one piece of fabric for the garment. I've got some music. They've made it very nice. Lovely. Then once the fabric is made, it then goes to a factory. And the factory is really important because the factory for us is our exporter. In India, everything below an exporter is an informal economy. It's cash in hand, it's handwritten notes of how many items, etc. Our exporter is the person, they're our translator in terms of like setting up an order, understanding the costs of the materials, etc. Working with those homework communities. Oh, I think that's it.
It's okay.
Little bug. There we go. And so we've had to learn how to map supply chains from two different ways. Number one, when we were trying from top down, it wasn't working. We would say, okay, who did you buy this from? Now, this week they bought it from this guy, but 3 weeks ago, they bought it from a different guy somewhere else. And so we were actually trying to keep up with, once we know what we're ordering, trying to find out who all the participants were. Stuff had already gone, and no one knew where it came from. So what we had to do is we had to also flip it on its head as well. And so we had to say, okay, if we're getting this type of handwork technique, where would that most likely come from? And then say, oh, that comes from this region or whatever, and probably this town, they've got lots of things there. And so then we also had to start mapping from the bottom upwards as well, and go ask, okay, if I do the sari thing, who gets these beads, who gets these orders, and then try and find the home workers. And it's worked really well, but it has taken us, I'm not gonna lie, probably about 10 years to kind of get it really feasibly working where we know and we can visit regularly to those different participants. So in terms of DPP, because we've been thinking a lot about mapping, etc., we've been thinking about, okay, so if we do this, how is this going to work? How are we going to map continuously, as throughout the whole year, which garment and which components are coming from which participant in the supply chain? And we found we're going to have to, because this is like a nice add-on for them, we're going to have to integrate it into any kind of existing things. So, for example, into our purchase order, into our shipping documents, into our approvals before stuff goes to production, all that kind of stuff. So we've been kind of doing a lot of thinking around that. We also know we need to minimize the administrative burden as much as possible. So I'm going to do a little exercise with you guys. So if you have any jacket or anything, what I'd encourage is you, if you haven't already cut it out, is you probably have inside your jacket something called a care label. Yeah? So this is our most legal, and do you know what? Sometimes they're like little booklets. You've got like 5-10 pages of like what's in it, how to care for it, etc. This is quite a legal piece of information for a garment. This is underpinned by test reports, which have tested the fabric, made sure that there's no chemicals in there that shouldn't be, have confirmed the composition, etc. And so when we're thinking of DPP, we're thinking not only about asking, we're looking also about what information is already being verified and how can we integrate the two together. Just to minimize the administrative burden, especially for the suppliers, they have to pay for every single test report, for every single item, which adds up. We also know that it needs to be really user-friendly. People are going to be learning by doing, so there's going to be lots of errors, and we're going to have to find ways to be able to ask, to go back to them and say, oh, please can you correct this error and leave this correct, etc. And we're also looking quite heavily at what information do we already have that we just need to link together. Okay, so part 2, this will be a quick one, is the consumer. So we have noticed over time is that, there's increasing legislative requirements around sustainability, both in terms of technical as well as in terms of sustainable claims. And what we've noticed that we need to do is we need to kind of translate these, these certifications that kind of say, oh yes, this is recycled, or oh yes, this is made with organic cotton. We actually need to translate to a customer what these mean. And so we'll kind of have the certification in the background, but then the label on the actual product, we're making super, super simple. So this is made with recycled fabric. And we've changed this now a little bit because it needs to be more specific. Or the second one is, this is handmade. And we do have a more sustainable collection where more than 50% of the item is made with a more sustainable material. So when we come to DPP, we need to be able, it needs to be super user-friendly as well for a customer. They often don't know what they're buying and what the environmental impact is of what they're buying. And we also want to demonstrate the value and the skill and the effort that's gone into the garment, especially when it comes to handwork. And last but not least, my marketing team, they love to have it super sexy and appealing, and it's a nice story, and it's beautiful. But the main thing also that we need to think about, we as a retailer, is we have a responsibility to encourage sustainable consumption. I don't know if anyone's heard of slow fashion before. Yeah, that's a big thing for us as well in terms of how we're communicating. Okay, now part 3, the end of life piece. 2 minutes. Okay, I'll be very quick. So in terms of the end of life, we look at these kind of 4 areas: durability, reuse and repair, how to make things made again, how to recycle as much as possible, and transparency and traceability. So we already do a number of things. We have a number of partners. We partner with people to be able to do this. This is not our bread and butter. We don't have the infrastructure to do this, so we'll partner with various different end-of-life organizations to do different pieces. So AECS do repairs for us and then resell it on eBay. Thrift, they take our take-back scheme and do consumer returns. And then we also we work, as I said, with the charity sector quite heavily. Our partner is New Life, and they will try and resell, and where they can't, it will go to recyclers. So you know what, we've also been talking quite a lot with that part of the supply chain as well, and they are doing a huge amount of work on DPP as well. eBay's super focused on how can I track a garment coming to me and being resold on my platform, and I can add that to my DPP item, for example. So where we've gotten to so far is these are the things that we can already do quite easily with the information we have. We have location of production, we have materials, we have sustainability certification, we have a basic carbon and water footprint for each item, and then we have a bit of a tracker on what gets resold and what gets recycled. And then these are just some thoughts that I kind of want to pose to the room, is we also did an exercise where we mapped one garment down, but it needed a whole team to go get all the data. So we're thinking of scalability, how we make things really simple and effective, and how we can get support from different verification schemes like GRS, etc., and also how to work with informal economies. And that's kind of it.
Many thanks. Great.
Thank you. Any questions? David?
You have questions?
Yeah,
Yeah.
just one little question.
Sure, tell me.
So thank you for the very interesting presentation. I was wondering, you just mentioned that you had a tracker that was enabling you to know what gets recycled, and I was wondering how does it work operationally on the field? How do you receive the data that a shirt has been recycled?
Yeah, so to be honest, each of our partners here, they will give us the data in slightly different ways. But with ACS, actually we partner, we give them clothes that have like a minor fault, they will repair it, and then actually they'll sell it on eBay, but we will get like a little bit of money from that. It goes to our charity, it doesn't go back to the business. So we count very much, like these are all the items we've given you, this is what you have sold, what hasn't been sold, and then we then also, whatever doesn't get sold goes on to New Life. So New Life then has a record of, these are the things I've collected as well. And they give us information back. We already have the composition with the style number, and then, yeah, they give it to us in various formats, but we can push it together kind of clunkily, but we get there, yeah.
I think we should go for
Many
the
thanks,
next
many
talk.
thanks.
Yeah. Thank you, Sophie.
Thank you.
The next presentation will be given by Abdelrahman Abdallah. Let's see if we can get presentation up. You all need to understand, this is a special meeting where we can celebrate. And yesterday, for example, we celebrate the start of Materials Commons.
Thank you.
This whole conference is also in honor of Professor Heinz Preissig, whom we can celebrate. And in addition, today we can celebrate a round birthday, namely the birthday of the Republic of Italy, which is 80 years old. And thank you so much for coming here to celebrate this with us.
It's a holiday. Also, yesterday was the bridge.
Yeah, so we can almost get started. I want to say Abdelrahman Abdallah, he has done his PhD at Politecnico di Milano, where he's now a postdoc, and this is in smart and sustainable engineering, where, among other things, he has worked on SIRPAS.
Yes. Thank you so much, and I think it's afternoon now, so good afternoon to everyone, and I'm very happy to be here. And my talk will be sharing the perspective of remanufacturing, which I think hasn't been the focus really of the discussion when it comes to the DPP, and I think it's a missed opportunity. So hopefully I can poke some discussions in that direction. And the reasoning is twofolded. So the title of the presentation is the Reman-Oriented DPP under the ESPR. So the first reasoning is remanufacturing is one of the highest value retaining strategies in circular economy because it retains the functionality. You do not need to waste the energy, the water, all of the materials, the precision into how the components were fit together to make a very complex product. So remanufacturing gives it a new service life. It's not just repairing. On the other side, the ESPR has singled out remanufacturers as the only circular economy operators that will issue new digital product passports. So from that reasoning, I want to achieve mainly two things from this talk. First is to discuss a little bit the challenges that remanufacturers face and give you a little bit of a perspective that not all remanufacturers are the same. There is, of course, different actors within that ecosystem. And then I want to show you the human perspective and how data can be also generated within the reman processes that can be helpful into conceptualizing the use cases and future use cases of a DPP as a decision support. So let's start with the problem statement, the challenge. The challenge is in linear economy, as you all know, you have the raw material, production, extraction, the production of components, their supply, and that goes into manufacturing, and from there you have the use service. Now, until we reach the use part, the quality of the product is pretty controllable. It's defined, right? Once we enter the use or service life, the first life, then we start having variability. And variability in both quantities and quality. So in order to have this loop of a post-use product, which we call core, by the way, in order to collect it and introduce it for remanufacturing, have a new service life, you would need to control this variability in the quantity of cores that are being collected and the different quality classes, we call them, in order to have an efficient remanufacturing workflow. So what's the end goal? The end goal is to reduce this variability and have a reman product which performs as good as new product with a warranty to match. And this is the definition that was also missing from the ESPR. So with that in mind, we try to take you through a journey a little bit going from to reduce this variability. So one of the objectives is to stabilize, as I mentioned, the volume and quality of the cores. And then you would need to increase something called the regeneration rate of reman products. So basically how many cores you need to have a fully functional reman product. And then, and this is of course very important for the digital product passport, is to achieve traceability of the reman process chain. So a little bit of a background about the project. The project is digitally enhanced multi-level solution for smart human-centric remanufacturing. So in its core, of course, there is the enabling of the human operator. So human in the loop is very much part of this project. We are almost midway through it, but I will try to share with you today the approaches that we are taking. Okay, so this is just an expanded view of my intro at the beginning, just to worth highlighting here that we are addressing this solution across different layers. So you have the value chain layer, because as I mentioned, you need a remanufacturer, need a stable supply of post-use products that are predictable. So that's the value chain level, where the design, the planning is very much, there is a lot of interaction between, let's say, manufacturers and remanufacturers as well. And on the lower half, we have the operational side of remanufacturing, where on the factory level, you want to empower the workers. That's on one side by giving them tools to help them with challenging operations, because you have to remember remanufacturing is very much still reliant on manual operations. So this is something also to take into consideration. And of course, having this data management platform where all the different tools and solutions we are developing will be able to communicate together in a product-centric way. And this is where the DPP comes in. Just to give you a bit of a flavor of the factory-level tools, let's say the story begins with the inspection, knowing exactly which product we are dealing with, because as I mentioned, cores can arrive in different shapes, and you know, you can have a missing component, you can have tear and wear, so you have to have some sort of a system to classify them and to inspect, to derive the necessary data points to decide your reman flow. Then the next aspect is the human-centric disassembly. And as I mentioned, mostly manual operations require some innovative solutions. So we're exploring things from exoskeletons to VR-assisted disassembly and so forth. And then we go into the automation, which is a key barrier, but also an opportunity for remanufacturing. And here we are exploring some collaborative robotic solutions, mainly for the disassembly, but later on also for the reassembly. And then we give a bit of focus onto the regeneration, which makes remanufacturing special, that you, of course, you compensate if in case of a mechanical failure, you compensate this failure. I show maybe on the bottom right the cold spray, which is an innovative technology that is being utilized in the project for mechanical failures, and of course the test rigs that are being developed for the electronics. Okay, we are talking about DPP, let's talk about the products. we have 3 pilot cases. The first is an already established business in Europe, which is the aftermarket of automotive, so the reman of, in particular, e-drives, e-turbos, e-motors, and the second use case is the reman of electronics in commercial vehicles. Now here I want to highlight one key about the differentiation of how this ecosystem works. We have here 2 actors. The first is an independent remanufacturer, meaning Borg, they need to buy post-use products from the market. They have their assessment criteria for what can work within their workflow, and there is a market for as well. While the other is Knorr-Bremse is an original equipment supplier. So they are kinda in control of the take-back of their post-use products. So already this is an interesting distinction because the ESPR does not differentiate between these 2 actors, right? So you are treating independent remanufacturers as an agent that's able to create DPPs. So we have to take that perspective in mind as well. The second use case, the second pilot is the white goods, and here it's an emerging business case. Of course, we have different products here, the washing machine from Beko and the heat pumps from Olympia Splendid. And then the last pilot is a novel business case. It's on the optoelectronics industry. We are collaborating with Lumibird Photonics on the remanufacturing of high-power multi-emitter laser modules. So I will not spend too much time telling you why these products are important within the scope of European competitiveness or, circularity in general, or the materials inside. They pretty much all contain critical and rare earth materials. But the highlight here is that now we have to develop a data model that is able to deal with these very different product categories, right? But all of them share something in common. They have electronics, and we want to focus on electronics for now. So let me go through very quickly a generic reman process chain. You have multiple inspection points. So at the beginning, you have a pre-inspection where you decide, okay, this is a core, a post-use product that I will allow to enter my reman facility. And then it goes into disassembly, the cleaning, the inspection of components. And this is also an important element to highlight, that remanufacturing does not work on a product level. It works on a component level. So the granularity of the discussion should address that. We are talking about sub-assemblies, components. And then the regeneration of these components. So for example, the pictures I showed about the cold spray, the electronics, and the final testing to make sure 100% of the products to become a reman has to be tested and certified as such. So our approach, we did for the different pilots a formal representation of the flows, of the reman flows, using this IDEF0 formalization, basically input-output mechanism, resource, and control. So the point that we're using this tool to highlight is that every remanufacturing step consumes but also generates information that may be needed to be persisted in this new DPP. And this is an example of how these packaged as DPP for the data management platform interaction can look like. Of course, you can consume data sets as input. Your output will be the next stage in your process chain. Your control gives you the decision rules. And this is the point that maybe also appeared in the SIRPAS user stories. In the SIRPAS user stories about the decision points, whether a product enters remanufacturing or go, for example, to repair or to recycling. But my argument is it's not just one decision point. Within the shop floor, you have many of these decision points about component level suitability, replacement, regeneration, economic efforts, and so forth. Okay, so I will not spend too much time here, but just to let you know that if you have the perspective of the electronics remanufacturing, and I just show the flow here from the pre-inspection of an e-motor, the disassembly using also collaborative robotics and so forth, the cleaning, and until that point we don't really know the quality of each individual component, right? Whether it will perform in the product as intended or not. But then we go into the further inspection and the regeneration activities until, of course, it's finally requalified again. So I see I'm running out of time, so I will go a little bit more quickly because this is not for everyone for sure, but get in touch with me and I can give you the report. This is just to show you that the main element of the data model is what I call the OTSI framework. So we start from observation, we take a decision, and then this drives a strategy, and this strategy is supported by evidence. So that's the common structure we are using for to point towards the different granularity of the products we're talking about. And then we can go to the last slide because it has some interesting videos. I just wanted to highlight here, because these are from different use cases, it can be a lot to follow, that this is the examples of the O in the OTSI framework. So the observation, how inspection drives these kind of intelligent decisions, right? So whether I go forward, whether I use an automated solution, a collaborative solution, whether at the end I can give an automatic certification of this reman product based on the log of activities within the factory floor. So I will not give you more details than that. I'm happy to discuss later, but for now, I just leave you. If anyone has a question, I can quickly answer.
Thanks a lot for mentioning the warranty in the beginning. Could you elaborate on this? So is this really missing in the ESPR?
Yes.
Because a plethora of business models is exactly connected to what's the legal backing of each information in the digital product passport.
Yeah, so unfortunately I do not have the ESPR on hand now, the text, but the issue is, first of all, you have associations in Europe that work in remanufacturing, and not just in Europe, but like this is the one that we are tackling for now. And together they agreed upon a definition. And that's really an important thing because they are not representing themselves, they are representing hundreds of companies that work in that domain. So in order to say this is a reman product, not a refurbished product, or there are many synonyms for it, it has to be a standardized process. So what we are discussing now, we started with the IDIV 0 because we abstract this standardized process into functions that will help us control the information flow, right? So this is the first element. Reman has to be a standardized process. The second element is to offer the warranty, is to prove that this is a new service life. This is not an extension of the service life. This is not a repair, right? You can say it's an extended form of repair. That's fine by me. But at the end of the day, you offer it as a new product with a new DPP. So there should be a warranty to match. That's the consensus of the reman associations in Europe. I hope that answers.
You can discuss more after
of
the
course.
lunch.
Yeah, thank you so much.
Yeah, next talk. Thank you so much. Thank God.
You have heard in this presentation, for example, about interaction DPP, DMP. And if I'm not mistaken, DMP here stood for Data Management Platform. But in the next talk, this will be about the DMP in the meaning Digital Material Passport, which is also very much of interest to our project, the DigiPass CSA project.
But we might have a problem with the presentation.
Yeah, first we need to get a presentation.
Yeah, because actually it's not running. Adrian, come. Yeah, but we have the key.
The key's here.
We have a problem with the presentation, not with the key. Yeah.
Yeah, something is wrong.
Yeah. Something is wrong
So
actually.
he's doing something, but probably not the right thing.
Actually, we cannot get access to the presentation.
Interesting. Well, I can also speak about
Yeah,
the
you can
thing
work with this
without
board.
slides.
I think, let's try. Speak without slides. I will try to manage.
It might be when you stored the file that it was not for public storage.
No, we have a problem to access to the file.
Okay, so I can start without slides. Happy to be here. My name is Adrian. I'm from BAS Intertrade. It's the trading company of BASF. And today's speak is about the digital material passport and how we can build ontologies with experts without doing this kind of, yes, cool. So you are the master. Thank you so much.
Computer is the master. But it's not there yet.
Well, it will come. So it's about how we can do those ontologies with the business expert. Whom of you have been there last year? Because I will just have 2 slides to re-talk about. Okay, not so many. So, excellent. Digital product passport, the proof of concept. And what we propose is to go and orchestrate the way we talk about material. But then the question will be, in my talk, what is material? Because we will have many different definitions. And we can orchestrate this information on materials through a chemical data space. So that's the recap slide from last year. Imagine a world without chemicals. We would be somewhere in the Stone Age, to be literally honest with you. Everything around us, 95% of the built environment has started somewhere with a chemical product. That has been refined, it had been converted in a good, a consumer good that we use. And now the big question is, how can I close the loop? And that's where this chemistry comes into the game. It's the life cycle of material. So many products start with chemicals, and if you have to collect and retreat the waste stream, it ends with chemicals. What do we do? So we are a project with 15 partners running 2 years. We have a budget of roughly 11 million. And the thing is that we want to do 3-layer steak cake. So the first thing, I don't want to talk about it, but I'm happy to answer any questions up in the coffee break. It's the foundational layer with the data space technology, which is based on manufacturing X. That brings the trust and the interaction. The second layer, that's what I want to talk about today, is the content layer, where we take the brains of the expert and bring it and boil it down in a way that we can start to interact with value chain actors in an automated way. And the last layer, there will be a proof of concept that showcases that this interaction may work, is then how to publish this information, consume it, and make it available via web apps. What do you need to know to get a flavor of your DPP readiness? Now you can think, what will be your choices on that chart? I have 2 choices. The first choice is my product. I need to know very, very well what is my product about and what properties or attributes I want to glue to that product. And I need to know the source and the metadata of that very product. And the other thing I'm just interested in, and I just stated metadata, is how and what method did I apply to get to those data so that I have a reference which I can cite that we start to speak the same language. The problem is, in my industry, we are very much in love with documents. So how we communicate through the value chain, which is currently very much linear in our world, is we have labels, because we have to tell you what are the potential problems with this product, and the safety data sheet, which tells you what kind of safety protection measures if something spills over, or what you have to do if you want to deposit the material, what are the waste treatments that you can do. The thing is, this is a turntable error-producing interface. Why do I say that? I get a sheet, I turn myself, typewrite it in my system, and it goes to the next system. The next system prints it out, turntable error-producing system. And this has to stop, and that's why we say to orchestrate this kind of communication in our world on materials, it must become semantically enriched so that we speak the same language, and it should go, if possible, if we talk about that chemical core, it should go to this entire supply chain. And that's why we say we would like to do this communication upfront, upstreams, the economic operator from the EU DPP perspectives with a so-called digital material passport. Unlike the DPP, it's not a regulatory passport. It's a passport that focuses on the description of the material properties. And if you have, so to say, remember the slide of the three-layer cake, there are three pillars we are extremely interested in. First of all, the right to operate. What are the hazard statements? What do I need to know to handle safely that material? That's the right to sell as well, because without having those artifacts, we cannot bring that product from our manufacturing plant to a customer's plant. Second, it's already right to win. What is the economic impact? What are the emissions or the footprint related to that very product? And third, it's all those are strategies. What can I do if I have that product? Is there any kind of substance of concern, definition D, that impedes recycling? If yes, then we should know that. And to illustrate that a bit better, let's take a product that we all know. It's a tape, it's an adhesive tape. I'm simplifying. I just say there are three ingredients: the substrate, the adhesive layer, and the supporting roll. So what we say, what we would like to do, no, not we would like to do, we do it. We boil it down into so-called digital twin that we represent as part describing the material properties of each and every compound. So if I have my cardboard roll, I will generate for that cardboard roll a digital material passport, giving me the identity of the material, where it has been manufactured, what's its hazard statement, what's its environment impact, and what can I do for any kind of our strategy. I take that DMP, I put on top of it my substrate, that will have some process information, and that I need to do the LCA assessment. I process, I roll it up, I coat it with my adhesive, and at the end of the day I have my full-fledged product, which has then a DPP. So the DPP is at the end of the day the sum of the DMPs plus the information from the different process steps. And then we have a full end-to-end transparency that we can understand. And that's for us the way to go, because then it helps us to get rid of that turn error-producing interface. Cool. Now that's the road we want to go. So what was our first deliverable? The first deliverables that we did was really describing, boiling down the expectations from our business expert on those three fields. So the right to operate, anything that is related to material declaration. Then the right to win, what are the specifics, how we assess sustainability, and what are the factors that go into circularity. So on the sustainability, it's important to understand that we cannot go cradle to grave. Because if I sell you my polymer, how should I know what kind of transformation with the polymer you're going to do? So our reporting method will be cradle to gate. But you get from us primary data, if possible. And we give you the methodology according to which we did the LCA. We are fully transparent, and you can understand exactly what we did to get to those values. It's based on ISO 1400, the details you can read. Circularity, it's a similar game. We are in the area of the mass balancing. So that's what we want to do, because that's what fits our way of handling process chemical streams. And on the material declaration, SPOD, that means single point of definition. So we want to have one repertory where we say that's how we identify a material, and that are the definitions we serve to tell you what are the hazard statements, what is the granularity, and we also provide you some of the SDS information. So I asked that question at the very beginning. What is for you a material? Is it the fabric? Is it a textile? Is it a wood panel? Is it concrete? We have a very simple view in the chemical industry. In our world, everything starts with a substance. And now, what I already do with you, I start to do this modeling of an ontology. This is my core entity, a substance. because everything in my world, in my business, is built around a substance. So what attributes will I go and give to my substance? So I would like to have an identifier, and there are many. There can be a CAS number, there can be an easy registration number, there can be an INCI code, there can be a UFI number. No, UFI doesn't work because that's for mixture. So there are given sets of attributes that I say that I would like to go with a substance. So do you believe me that that is the right way to go? That's why we say, where do I pull the definitions from? So what are the legal texts that help me to define the entity and those attributes? And as we are in the European economic space, I refer to the REACH definition. You can read it yourself in the REACH definition, but it says it's a substance defined. It means it's a chemical element and it's a component in a natural state or obtained by a manufacturing process, including any additive necessary to preserve its stability and any impurity deriving from the process. So it's as it falls out of the reactor or as you dig it out of the earth shelf. So it's not a pure substance. That's important to understand. So we know, and now we start to model. Sorry, for those who are database specialists, don't crucify me. I now take the Crow's notation and I put some names on it. It's forbidden in that language, but for us to talk to business expert, it helps to explicit things. So the Crow's notation tells you if you have this kind of triangle, that's a cardinality multiple, one or many. If we have a straight line, the cardinality is 1. If we have the 2 horizontal bars, it's a role and the thing below it inherits all the things that comes from the adjacent entity. So let's go for it. We have learned from the REACH regulation that the substance is as manufactured containing the impurities and the additives to keep it stable. That means the substance itself is a compound. So I need another compound substance. That's why we have this constituent substance. So we see if I follow the line, it tells me is in. So I have a constituent substance, triangle, one or many constituent substance that is in the substance. And we see the constituent substances, if there are any, they are by default a role of substance. It inherits everything that is described in the substance. So with this concept, I just can tell in a very easy way, which I can read once understood the notation of the crow's feet notation, I have a substance which have some impurities, and the total of it is my full substance as generated in my process or as I dig it out of the earth shelf. 2 minutes, excellent. So we already know substance is a material, but not only a material can be a substance. We do the exactly same story. If I pull multiple substances with a purpose, a function, and a concentration together, I get a mixture. And so we have the 2 entities that define, from the chemical industry viewpoint, what is a material. It's a substance and a mixture. We have the lineage from where did I pull the definition, and I have the relationships. Doing this kind of methodology with expert, I get to a representation of the knowledge which I can easily transfer into an ontology. From that, I can do a TTL file. And that's something which really represents the business needs that we have in our industry, and that helps to engage discussion. If I showcase the TTL file to my experts, they look at me and say, oh, hey, Adrian, sorry, I can follow you. So what we did, we used this kind of definitions in a very, very aggregated form to go with 3 different suppliers to showcase that the principle of the digital material passport works to represent products that you can sell on the market. So that were 3 partners from our network. We pushed the data into an adjacent network, Aerospace X, and we delivered this proof of concept in a demonstrator at the Hanover Fair. And I just repeat myself from what I told you yesterday in the other room, DPP is not a tech problem. DPP is an organizational and a change management problem. It's about teaching people how to take care of data, do assumption if you don't have data, and empower those people to get the data in a quality that you can use. Having said that, we do 4 things. We build this semantic representation of what we build our world of with the semantic interoperability. The Catena X infrastructure, manufacturing X infrastructure brings us the trust infrastructure the proof of concept we delivered, and if we do it right, we stop the turntable error-producing interface, and we get a better competitiveness. And if we work together, then we can build a sustainability data ecosystem. Thank you very much.
Thank you so much.
Thank you very much. Great insight about the material passport. But Adrian, I think, in my mind, I think we need harmonization system for framework and names. And I ask, because I followed the ChemX from beginning, and I ask myself why we need the material passport. You know, when we try different names, different frameworks, these fragmented frameworks, it's not mean scalability. And why we need it actually? It's every materials also is type of the products.
Absolutely.
Thank you.
So the answer is the following system. We agree that we build on always the same kind of product information. And now I really speak from a material manufacturer perspectives. If we talk about SVHCs, SVHCs follow the same definition from CLP and the candidate list from ECHA, whether you work in textile, automotive, tires, or furniture. And what we just do, we say, okay, let's take those definitions from CLP and REACH and pull that into the digital material passport. Because SVHCs will be one of the things we have to report. It's actually the only thing that I understood from the ESPR that needs to be completely transparently pulled throughout the entire supply chain, the substance of concern. And the substance of concern has 4 definitions. So first, it's Article 57 and 59 from REACH. It's Article 32 from CLP. It's persistent organic pollutants. And it's what I just said, anything that impedes recycling. What we have there is more or less the chemical legislation, and we will use it in all segments. And what we propose is that we harmonize that representation for those reportings that you have to feed through all product categories with one single definition, the one from the chemical legislation.
I think we should stop here. The kitchen actually is waiting for us. We are half an hour, and probably we not got lunch. I think it's important that you go now. Okay, enjoy.
Thanks to all presenters.
Good afternoon, everybody. Welcome back to the session 5 of the DPP4EU conference. This session is about digital infrastructure and the materials commons, a concept which is really in the spotlight of the European Commission. And our first speaker in this session is going to be Javier San Felix. He is replacing Guido Hugenhout, who could not make it for today. Javier has an engineering background, so he worked in the field of economic and environmental impact of batteries, mainly for automotive applications, if I'm not mistaken. And currently is the team leader for advanced materials in the industrial transformation unit of DGRTD. And Javier is going to introduce the policy context around the materials commons. So Javier, the floor is yours, and thank you for having you here, and a warm welcome.
Hello, good afternoon. First of all, thanks for the invitation to be here today. A pleasure to introduce this topic on advanced materials, and apologies for interrupting your nice chat after the lunch break and your coffee. So this presentation I will be giving today will give you an overview of the different activities that we do on advanced materials in the European Commission, and then also a bit of introduction of the Materials Commons, Horizon Europe project that started yesterday, actually, and is one of the priorities that we have also under this initiative. So, as an introduction here, just to show you some of the key milestones that we achieved since adoption of the strategy of 2024 on advanced materials for industrial leadership, which is the one that set up this framework and strengthened the ecosystem of advanced materials in Europe. We had important actions put in place, like, for example, the Technology Council for Advanced Materials that had its first meeting on the 15th of November 2024. This is an expert group with high-level representatives from member states, industry, and academia, with the objective to coordinate and align on common priorities for advanced materials in Europe and put together joint actions to support this ecosystem. Another important action that was announced in this strategy and that we have accomplished is the setting up of the co-program partnership, public-private partnership, Innovative Advanced Materials for EU, that kicked off in June 2025 with the first topics under the Horizon Europe Work Programme on the same year. We have also launched recently, in October last year, the Advanced Materials Academy. I will give a bit more details afterwards on this. We're having collaborations also with Japan, with an enhanced dialogue of advanced materials for industrial leadership. There was also the revision, even more recently, on March this year, of the Safe and Sustainable by Design framework for advanced materials, which I suppose in this room you are all quite familiar with this, but that's a methodology that we are endorsing from the Commission side to make sure that the chemicals and materials that we develop with our research and innovation projects take into account the highest ambition level of safety and sustainability and make use of methods and data to support this safe and sustainable innovation. Another important aspect in terms of coordination with member states and mobilizing investments is the ongoing works of the IPCEI on circular advanced materials, important projects of common European interest. This is still a work in progress, but already 2 member states, Slovenia and Belgium, have launched the call for expressions of interest at national level, and other countries will follow, and we expect towards next year to have the formal notification to the Commission. Again, this is still work in progress, but it's already a sign of the relevance of advanced materials in the EU, and also that it is a high priority in the agenda of some of the member states. So all this timeline that I presented started with this communication that we adopted in February on 2024. This communication is structured around 5 pillars, starting with the setting up of priorities for research and innovation that are common across the EU for all the member states. The second pillar was about accelerating the time to market. And here we were looking at the role of digitalization on this regard and how a common platform at EU level to support design and development of advanced materials digitally can be beneficial for this shorten of the time. And this is one of the main parts of my presentation later on. There was also, of course, the need to mobilize capital and investments for advanced materials, and under this pillar 3, we placed the partnership that I just mentioned, also the work of the IPSE, important projects of common European interest, and also dedicated challenges under the European Innovation Council in order to support startups in their growth and scale-up of their innovation related to advanced materials. There were also a fourth pillar, very important, that we not only need to support the innovation, but also the production and the use of these advanced materials. This was the kind of the industry part of the strategy that has been implemented together with the colleagues of the Directorate General for Growth, which covers enterprise and companies. And here was also the need to understand the capacity that we have in Europe to produce advanced materials and to use them. And there was a study that has finalized recently, has been running for the past year and a half, that has collected evidence of the capacities that we have. There was also a number of workshops organized around this study. Well, perhaps you have participated in them, and we will soon publish the results and make them available. Here there was also the need to understand the standardization needs. Standards, as you know, are super important to bring confidence in industry for the uptake of advanced materials, and also the element of skills, that we need to have a workforce that is ready, not only in terms of material sciences, but also on integrating the digitalization aspect, the modeling tools for the design and development of advanced materials, and also the integrating of safety and sustainability elements and requirements of the life cycle approach when designing innovation in the field of advanced materials. And the last pillar addresses the overall governance to coordinate the implementation of all these actions, and that is the Technology Council for Advanced Materials, as I mentioned earlier, that has an important role in steering these actions, but most importantly on agreeing and having joint coordinated actions with member states and key representatives from industry and academia. So, yeah, just to show again, these are some of these actions that I have already mentioned to you, and that are those that have created major advancements in putting the ecosystem of advanced materials together and mobilizing all the stakeholders. For example, under the Advanced Materials for EU partnership, there is a private association with more than 300 members and keeps growing. And I'm assuming that most of you in this room are also part of this association. We have the Materials Commons. That was one of the key initiatives, and that has been now officially started under Horizon Europe, but for which we need to continue looking for the long-term sustainability of this infrastructure, and also the Advanced Materials Academy that has just recently started and has very ambitious targets to create upskill and reskilling more than 200,000 learners across the EU. They are already in the process of developing this learning courses, which they aim to develop at least 30 of them. And an important element is that they don't only focus on training the students, but also training the trainers, so that they have the skills and can communicate and express and disseminate what is and teach what is needed on this field of advanced materials. Here you have a bit more details and information of some of the actions that I have already highlighted. As for example, you can see that under the Innovation Council we had these accelerator challenges in the work programs of 2025 and 2026, both related to advanced materials and with 50 million of investments under each of them. And there will be another one that we are in the preparation of the 2027 work program of the Innovation Council, but this is to be confirmed. We are just preparing the proposal, but that have to be discussed with the forum and member states. An important action also perhaps to highlight here is the role of innovation procurement in order to create the market to uptake and use the innovation that we have in advanced materials. And here public authorities have an important role with the demand and the amount of volume of investments that are done in the public procurement sector. For this reason, we have a CSA project that started also officially yesterday that is going to work on public procurement activities in the field of construction. The project is called Ambient, Advanced Materials for New EU Bauhaus Environment Public Procurement, and will create guidelines and the support to make the process of procuring advanced materials for public authorities. In terms of studies, the strategy announced a number of them that you have them all listed in the strategy, and this is part because as you saw in the timeline, we have, and it was announced under this new commission, that at the end of this year we will have an Advanced Materials Act. This is a new way to support the ecosystem of advanced materials, and in order to understand and have evidence to support these new measures that we are going to put forward, there was a need to create evidence and knowledge generated. And for that, there was the study on production and use that I mentioned, but also on mapping all the research and technology infrastructures that we have in Europe supporting advanced materials, understanding which are the innovations in the field of advanced materials that can help us reduce dependencies on critical resources. That's work done together with the Joint Research Center. Also a mapping of the patent landscape on advanced materials to understand better the EU positioning and what is needed to support knowledge valorization and protection of intellectual property in this area. And also other complementarity analyses like that were developed by the JRC on economic complexity, which is also based on patent analysis and identifies strengths of different regions across the EU on certain materials types. A very interesting reading. This is already publicly available. And another one dedicated to the construction sector. If you are interested on all these actions that I just mentioned and want to follow more closely the progress that we do with them, in the link of these slides, which you can share after my presentation, there is a dedicated section. You have the full strategy, but also the progress that we are doing in the implementation. And as I said, all these studies were going to support the upcoming Advanced Materials Act, for which the Commission is tasked to gather evidence to identify well the challenges and the evidence that justify them. For that, I think it was November last year, we launched the Call for Evidence and Public Consultation that was running for 3 months, and we are very happy with the participation, given that it is quite a technical file compared to other policies that the Commission do that gather a broader audience. We got almost 200 contributions for the call for evidence and very similar for the public consultation, with a good representation balance of the different stakeholder groups that are active in the field of advanced materials, mainly from academic stakeholders, but also companies, SMEs, and public authorities. The main findings of this, and I hope you can read it on the screen, show us that for our stakeholders, strategic dependence is one of the key challenges where the Commission should put forward and should put action. And this is also linked because most of, or a lot of advanced materials have use of critical raw materials, and that creates bottlenecks and difficulties for the companies that develop them. Regulatory burden and lengthy validation procedures was also highlighted as one of the main challenges where the EU should act, and indeed the Advanced Materials Act is announced in the Commission Work Programme for 2026 for this year as a simplification act, meaning that all the actions that we are going to put in this act should contribute and have a big impact on facilitating simplification. An important aspect also that caught our attention is the missing links between academic research and industry needs. This is something that we already identify in the strategy of 2024, but that seems to be a persistent challenge that we need to continue. The partnership is going to help on this, but it is true that it's a new partnership and it still requires more time to work on this aspect. Lack of production capacity was also highlighted as one of the main challenges. And the lack of testing and experimenting facilities on advanced materials. Just for interpretation of the results, we also looked at how this differs if we only look at the needs identified by companies, including the SMEs. And here you can see that regulatory burden, lengthy validation procedures, and strategic dependencies remain the same, but then other priorities and needs challenges that we need to address change a little bit, and insufficient private sector demand appear as in the top, together with high energy costs. So taking all these main challenges identified by our stakeholders, we are now working together on this Advanced Materials Act. And here, just to give you a bit of flavor of the main pillars around which we are developing this act. As I said, it will have an overarching objective of contributing to simplification and facilitate the life of business and companies in the field of advanced materials to grow in Europe. Strategic autonomy is, of course, super important, and here we will continue with already activities that we are doing under the economic security strategy for the EU, and identifying vulnerabilities in the value chain of advanced materials for strategic sectors. Another important aspect also is this time to market, to shorten it. Here we will continue looking at digitalization, and the Materials Commons will also have a central role on this regard, but we also want to address the lengthy validation procedures and the regulation complexity, and develop guidelines and how we can facilitate all this process, especially in the last stages at the high TRL, to support uptake and deployment. And last but not least, reduce fragmentation, which was also one of the main challenges of our 2024 strategy, but this remains a challenging aspect, and that was also highlighted by stakeholders in the consultation. And here we want to strengthen the role of this Technology Council for Advanced Materials to really put together with the member state the joint, not only identifying the priorities, but also putting together a roadmap of investments to support strategic sectors and concrete areas like cross-cutting elements, like could be digitalization or the circular economy. So overall, this Advanced Materials Act aims to support the whole life cycle of advanced materials, from the design and development to production and deployment, with a particular focus to SMEs and startups. And now I enter into the Materials Commons that was announced as the main topic for the session that you are going to have this afternoon. Again, that was one of the key actions in our 2024 strategy, and it comes to address the proliferation of different platforms in member states and the need to put them all together, working together, and have a central one at EU level that not only helps in the harmonization, but also provides the services to other member states that do not have the capacity to set up such infrastructure, and that's something very important for the Commission. So with this objective, we added a topic in the work program of 2025, the Materials Commons for Europe, with a number of elements that need to be addressed that you can see here on the screen. It asks for a proposal that is structured in 3 main phases. The first one regarding the planning and framework establishment of what we could be the Materials Commons, and that links to the fair data access to interoperable heterogeneous fair data resources and the computational tools. There is a second phase on the initial build-up of the digital infrastructure with these experimental workflows and the framework also that should allow the use or support self-driving labs. And then the third phase that is about the demonstration with use cases and also develop a long-term sustainability for the Materials Commons. This is also a very important aspect for the Commission, that we want to ensure that this digital infrastructure for advanced materials exists and continues after the financing of this first project that we are putting forward. And as I said, that will be something that we will continue exploring under the upcoming Advanced Materials Act. The project started yesterday, and here you have the list of the 27 partners that are part of it. I suppose also some of you are here in this room today, or perhaps connected online. We are very much looking forward for the kickoff meeting of this project, and the Commission will be following it closely. And the mission of this Materials Commons is to drive forward innovation and cross-sector collaboration in material sciences. That element of cross-sector collaboration is also very important for us. This is something that we want to promote a lot, that innovation in a concrete application in a particular sector can also help other applications and have this spillover effect. And then the second mission or objective for the Materials Commons is this overcoming this fragmentation, as I mentioned earlier, of the different infrastructures that are being developed in Europe, but also address data inconsistency, which is a major challenge, I understand. I suppose that this has been or will be extensively discussed in this forum here today, because this data not only important for the digital design, but also for the circular economy and the exchange between the different actors at the end of life treatment. So yeah, we're very much looking forward to it. I think this data governance and data needs have an important link with what is required under digital product passports. So what we use in the design of advanced materials, this data needs to be compliant and be interoperable of what will be requested afterwards for market access for a circular economy. So I think here having collaboration among both initiatives is crucial, because data is key priority, and we need to ensure that when we talk about fair data, it really means fair data in practice, and that it is interoperable. And I think this is everything from my side. Unfortunately, my colleague, who is the expert on the Materials Commons, is not here today. I'm replacing him. happy to address any question, but if it is very difficult, you might get the answer in written afterwards. But I hope I can manage.
So thank you very much, Javier. And I think we have time for, let's say, 2 questions.
Thank you so much. Very informative talk. I have the question about upscaling of advanced materials. All of us, or many of us, are working in discovery and after the development, and this step to bring to market, it is really difficult. From your opinion, or experience, which possible tool or maybe way can help really short this step from lab to real industry? Thank you.
Yeah, I was waiting for the mic, but I actually have a mic here. Very important question also, because this is what we know, that we are very good in Europe in the design and development and doing the research and very high-performing materials in the lab, but then there are way too many challenges to bring this to the market. Structural challenges that need to be addressed, but also financial support. Right? And on this regard, that's one of the key objectives of the new mandate of this commission. And one element is that they are going to put forward this competitiveness fund to support production and deployment of advanced materials, of innovation in Europe. And within the upcoming Advanced Materials Act, we want to make use of these new provisions that will be available. One element as well is facilitating the access conditions and also fair conditions for research and technology infrastructures, particularly technology infrastructures to support the testing and prototyping of innovation and advanced materials. This is also something that we will explore under the Advanced Materials Act to improve these access conditions. And then there is need of investors and high investments, because the upscaling of advanced materials requires a lot of money. And here we are exploring, together with the partnership, IAM4EU, and also with the Innovation Council, to organize matchmaking events, where small companies, researchers, startups that are developing innovation and advanced materials have the opportunity to present it to a group of investors and big companies that can have an interest and create agreements and projects to support them in the testing in real industrial conditions, or perhaps already in the integration in their production line or the final products. So this is work in progress, a big challenge ahead, but will be one of the priorities that we'll be targeting under the Advanced Materials Act.
Thank you. Are there any other questions? Doesn't seem to be the case. So let's thank Javier once again for this excellent overview of the policy landscape.
Thank you very much, and wish you a good continuation of the event.
As Javier told me in the beginning of the session, he has to leave quickly, so I would like to thank him.
Thanks for coming.
Okay, our next speaker is going to be
Jesper Friis.
No. It's going to be Simon Stier.
Okay.
No, Simon Stier, and he is going to introduce now the Materials Commons project. To us, a project which had been started yesterday officially, but the kickoff meeting had not been held yet. It's going to be in 2 weeks' time, if I'm not mistaken.
Exactly.
So, Simon, the floor is yours, and a warm welcome.
Yeah, thanks for having me here, and I'm very happy to now give some more details about the project. As already said, it's not started, but we have, of course, many visions. So slides will...
I'm sorry.
Maybe, my personal background, so I'm a computer scientist and material scientist, and in this double role, of course, very happy to drive such projects. And in my home institute, Fraunhofer IC in Würzburg, I'm leading the digital transformation, and in Materials Commons, I'm in particular active in the implementation of the semantic framework and the infrastructure set up. So it's the first one. Yeah. Sorry. So the title of my talk is then to lay out how this federated infrastructure in Materials Commons will support, of course, R&D in materials of advanced materials, but also support DMPs and DPPs by using a unified approach. Luckily, I do not have to repeat much of the background, but of course, there's a long history that shaped the Materials Commons as we have it now. And of course, one of the main motivations is to unify the separate landscape of innovation platforms and digitalization platforms across Europe. If you're interested in particular how, for example, the German initiative PMD scales up into the European level, there's also a poster from my colleague Jörg. And also mentioned is the consortium, which is academically centered but has a lot of industry associated, which is of course important to really battle-proof our results here. But now to the actual mission. So on the left, you see what we see is the current situation. So you have different types of assets, infrastructure. You have, of course, lab infrastructure, physical infrastructure. You have computational infrastructure, and you have data infrastructure for materials research in Europe. But if you want to do research, you need to connect them to actual workflow that drives your particular research question. And this connecting fabric is a challenge. So it's not easy to run multiple experiments in a consistent way across different labs, or maybe feed this data into a computational approach, or reuse existing data that is somewhere on the node. So that's our mission, to make this blue core, the semantic glue layer in between, happen, and realize this in a federated system, as you see on the other side. So every stakeholder in Europe has different capabilities, different assets he could provide. So we want to take the idea of a federated ecosystem as the industrial data spaces do, in order to share such assets and resources together. Yeah, also this slide was mainly already shown. So our mission is to create this pioneer data digital infrastructure. To go more into the details, what are the challenges about semantic interoperability? I mean, this was a topic, I guess, very often discussed yesterday and today. But to summarize quickly, there is no coherent practice in annotating data if this is done at all. And if metadata is maintained, then a lot of different community standards. And in particular, also the R&D community in academic is somewhat disconnected from the industrial approaches, so they need to be integrated as well. And if you want to build an application that really drives new data-driven research, you are merely trying to puzzle something from many different applications that just have a very focused use case and do not really cover the full research life cycle. So our idea is that we want to provide solutions for that, and that has, of course, they need to have a semantic foundation. That doesn't mean by creating just another ontology, but translating existing ontologies in reusable patterns, because we believe those patterns are now what everybody is actually looking for. So it's not so much which ontology is the best to store this information, but what is the best pattern to document a process of material synthesis, or to document the characterization of a material. And I just want to have a pattern that is established, battle-proofed, and I want to reuse it and share it. And that's what we want to have at the end, a repository of such assets founded on ontologies, but made actionable by translating them to schemas, mappings, patterns, and so on. And this is not just an information asset, but also a lot of software components can be built on such patterns, because at the end we all do some visualization and user interface, and we also can share, not apps, but app components that drive humans really to interact with the data, meaning entering data, validating data, consuming data, analyzing data. So this is also part of the mission. yeah, and at the end, this federated approach has the vision, of course, to be connected to every other relevant initiatives. For example, industrial database connectors, the AES. Yeah, also the ontology modeling world, and other approaches like, of course, capabilities to query complex data, to validate data with shackle shapes. We already heard this today, and be connected to any data-driven ecosystem out there. Yeah, what is now the technical detail on this? So, in particular, we are very carefully reusing and combining standards and not creating new ones, not to try to create new ones, but in particular importance is this JSON standard family for us. I mean, JSON is a very flexible format, but there are two things you need to take care of. One is the syntactical shape of a JSON document. There's the JSON schema for, which provides you validation, but also rendering of UI elements or generation of program code and API interfaces based on a declarative contract. And the other dimension is the linked data dimension, RDF. There's JSON-LD, which is a lightweight annotation of any JSON document to make it RDF. And this unlocks, of course, the power of knowledge graphs. And we already heard what power a knowledge graph can have if you're able to build it. And finally, LLMs are very important, and of course they support also structured JSON documents. And if you want to force them into a particular pattern, then JSON schema is again the language to use. So the final idea is that this stack also enables LLM to interact natively with your data and indirectly also with knowledge graphs, even if they are not really have this core capability. And yeah, now embedded into a larger stack. So now this is a list of standards that are relevant, centered around this core of object-oriented linked data, but also connecting the different semantic web technologies and also the actual application layer you can build on the right. And also important to mention, there is more to see here. So we have the AES is of course a very important industrial concept in data modeling, and we see here particular similarity with JSON schema, nested object modeling, plus semantic annotation. So we are optimistic that there is a way to translate easily, not easily, but between the worlds. Also, we already heard about verifiable credentials, which natively apply on JSON as well, so you can then use this approach easily. And there are many, many more domain standards that are driven by JSON or JSON-LD. Just to give an important example is OpenLCA for the SSPD community, a format to model processes to get lifecycle assessment. Yeah, so at the end, the vision is to have, so we have this excellent labs across Europe, but we miss some important connection. And by using the federated approach to having connectors following the industrial data spaces, by exposing in a controlled way your resources, your assets to a larger ecosystem. It could be other projects, other nodes, other communities. I think we think this is the way to go here. And this is just the overview graphic of the data space protocol, where different participants can expose via the connectors, for example, a catalog that a machine readable describes what they have. And that's exactly what we need as a first step, a material-specific catalog to describe relevant data sets, relevant workflows, computational tools, etc., to make them available in the community. Yeah, and to give us a final a concrete example, the battery value chain is always a beautiful example of complexity. We already hear that the textile value chain is not really a chain. Also, battery manufacturing is often a network if you consider all options, how you could make something like energy storage. And if you're research-driven, it's important to model a process also with options that could be switched, interchanged, like having a toxic and a non-toxic material in your input stream, or having a more or less energy-intensive process step. So this is important for process engineers, materials engineers, but also life cycle assessment or SSPD people. And also, if you are a material scientist and you want to describe what is a battery made of, you will may use ontology to do so. But at the end, this information is, of course, also something you want to project in a product path, in a battery path, to have this information in a well-defined container available. But this is really an important connection, that the information modeling between research and an industrial perspective or regulatory perspective, like a product path, could have the same foundation. So if you think this in an industrial scale where you actually manufacture something, then you would, of course, collect all this information in a knowledge graph, and you may have digital twins to validate, to predict properties, and you may end up with such a data, a data knowledge graph that connects really every process step in the value chain, every data point in the value chain. And this is important for, I would say, for every stakeholder, no matter if you're doing research or doing production of a product, that he has a proper data management internally to know everything about his processes and his materials. So this means that we have every single measurement, every image that was taken of a surface, every physical quantity, every process condition is somewhere in this connected data set and can be explored. And now, to make the step back to the industry value chain, just assume that this production line is actually distributed among different institutions, different economic apparatus. You would then hand over at the borders of this information spaces in a controlled way information by projecting particular data points to a product path or materials path. So this is exactly where we need on the digital product path to hand over this data across the different players. And you may also call this multi-handover between harmonized different information spaces, also daisy chaining of DMPs and DPPs, as also mentioned in the white paper of the DigiPass project. Finally, if you want to find more about the project, so we're just launching all our dissemination. Website is already running, so you can go there and it will populate more and more with content. And if you want to reach out to me personally, this is the way to go. Thank you very much.
Thank you so much for this introduction to the Materials Commons project, and we are looking forward to next year's presentation of the initial results of this. So the presentation is open for questions. No questions? Okay, everything seems to be clear. Okay, thank you, Simon. Thank you again.
Okay, now it's Jesper. Jesper is with SINTEF in Trondheim in the material section, right? Material nano. Background is physics, crystals, if I remember right. And he has been very much involved in the EMO project. I still call it the European Material Model Ontology, I'm sorry. And he has been also involved into semantic-driven pipeline, data transfer pipelines at SINTEF. Floor is yours.
Thank you, Heinz. Can we bring up the presentation? My background, as Heinz said, I am a physicist and not been working very much with digital product passports. but I've been very much engaged in.
Should come.
Thank you. Within digital representation of materials, and I think here we have a role to play when it comes to digital product passports. I should try to stay in front of this one. I'm working together with a group of people. They have all been involved in the development of the EMMO ontology. So, I think a useful way to view a digital product passport is as a life cycle knowledge graph, where you really can, it has it has been mentioned many times today already, the importance of semantics, but it's a way to provide, enrich the data sharing, reusability, of course, provide provenance. Graph structure is really excellent for that. Interoperability, consistency. We have data discovery, and ontologies is also perfect for providing and allow reasoning, logical reasoning. In the field of DPP, so we have the EU DPP core ontologies developed by the DigiPass project. Yesterday, when you presented this ontology network for DPPs, or DPPO, should it be, from Linköping University, which at least conceptually should be aligned with EU DPP ontologies. So what exists there already provide, even though they are quite new, they already provide a fairly mature horizontal layer for DPP, so product, actors, life cycle, and so on is well described. What is lacking is really the description of materials, microstructures, compositions, and so on. Everything is properties, performance, and for that, I think this elementary multi-perspective materials ontology, EMMO ontology, is really can really help and provide. So it really allows going from the real world to a use case, describing the material in form of have all these mathematics, properties, databases, all this context around the importance around the material, and to represent it in a knowledge graph. So EMMO, you can say it has a backbone based on materials, starting really at the top. It's really generic. It's based on a theory from meteorology, which is about the parts, the whole and the parts, and causality, causation. And from that, there is a physical description where we start. This is, EMO tries really to be an ontology for all applied sciences. That means that it should really include everything. This really starts with the standard model. It then goes down. So we have a physicalistic, thanks. Then I can move around. Where at this level here, it describes more chemistry and what you would, molecular structures and so on. And then you can go down to materials and bulk structures. This is probably where we are most of the time when we're speaking about products. EMO also has a lot of perspectives. So you can describe say a product, or say something from many different perspectives. So for instance, contrast. That is the basis for data. You can see if you have a hard drive, you have the magnetic field, that is variation. So you have a contrast in the magnetic domains, which is really form the data. Semantics is an important perspective where you can link an object to an interpreter and that can produce a sign that stands for instance, a property of it. So this is kind of the basis for measurements. It's based on a theory by CS from last century, middle of 1800, and so on. I think holistic is again whole and parts. Reductionistic allow us to go across scales. So this is kind of a fundamental backbone. And I think something that's interesting to point out. Now we go up here. What is really a little part of up here at the myocausal top level? EMU allow us to describe standard particles like a chain of quantum. This is simply you could think about just something that existed before space and time. It's a point. And then between interactions you can view, for instance, an elementary particle, so they can start to interact with each other. Okay, so this is really at a fundamental level, and then you can start to combine such quantum in a network, which then form macro objects, and that is everything we see in real world. From this basic theory, you can then get spatial interactions, which simply would be, if you look at this, like two electrons that scatter. So then you can see these two electrons as two macro objects that interact with each other. That would be a spatial interaction. You could also think about your system before the interaction, your system after the interaction. These two systems are in causal contact with each other. So then you have a temporal relation. So, and this way of building up these spatial and causal relations, they are very important when we can be very useful when we want to describe a complicated process where a process is combined, you cut it up, and so on. Everything what is happening during manufacturing. Okay, so the EMO ontology. No, maybe one thing I could mention related here. So the name, elementary multi-perspective material ontology. Elementary because it really starts elementary. Multi-perspective because of all these perspectives. That's the reason for it. If you look at the structure, so it has the core of EMU has a foundational level is really small, just 8 classes. Then we have the perspectives that comes, and that is kind of the top level. And then down here at the middle level, we have a reference level that provides us with informations and so on, workflows, data, and down there again a lot of disciplines where we can go into materials, units, manufacturing, math, and so on. So all of this top level is managed in a small core group, actually the co-authors, maintained by EMMC. It's quite open, so people that are interested, it's always welcome to join. Then there is a community around, a lot of EU projects providing domain ontologies. This is just a very few of those that exist. So here we have electrochemistry, chemical substances, and so on. And down here we have more applied, application-oriented, also domain ontologies, where we find, for instance, batteries, which is very important. We have for different types of solid oxide fuel cells and so on. Concrete, nuclear energy. And we try within the EMMC is the European Materials Modeling Council, within the framework that we try to coordinate, not dictate in any way, but coordinate these groups such that we get a ontological framework for materials that is quite homogeneous and can be applied. One thing I could point out is this SSBD core ontology. It's actually independent of the EMU frameworks developed in the PINK project, but it is fully aligned with EMU, which makes it really also a resource. That's very important for digital product passports. So let's now look at a real work example. You might have it's manufacturing of an aluminium product. You go from bauxite and so on. So what this diagram shows is different process steps. The gray here are material that flows in the state of material. So we have the bauxite that goes to the electrolysis cell, and so it becomes to metal. Within this, here you then cast it. You need some alloying elements. You might get some scrap back, and so on, and many homogenization, extrusion, and so on. So we have many different processes. We have agents that takes part of these processes. This is just an example of different agents. There's of course many more. And what I think is interesting to point out here is, for instance, after we cast material, it is the same material, but it changes, of course, its properties between each processing step. So that means that we can look at a temporal part of the casted material, which is as cast state. It has a microstructure, it has a set of properties. After we do the homogenization, which is a process where you heat the cast structure to 500 degrees in some hours. You really change the microstructure, get rid of some particles that are quite detrimental for the properties. And you get a new structure, of course, a new microstructure, new properties. That can easily be represented this way, because these temporal parts are really represented by themselves in the knowledge graph. But we always know that which the material they are a part of, temporal part of. And then we go down here. You can, after you joined several products or components into a product, you can even see, okay, here we have a spatial temporal part of that product, which actually comes from this part here. So it's possible to follow everything the whole way. I think that should not spend too much time. So we can also, again, add a mapping layer. So all of this first here is described with EMO and its domain ontologies. Then we can do a semantic alignment to dedicated DPP ontologies, for instance, EU DPP, where you simply find the relations in the concepts in EU DPP, map them, and then you have a description now that is really accessible seen from the standards point of view, where you now have all the physics and all the material knowledge available. A little more about connecting to other ontologies. For instance, when you can connect to the SSBD core ontology, you would then describe SSBD assessments with safety, economical sustainability, social sustainability, and so environmentally sustainability, functionality, and so on. So we have these dimensions here. We also have this microstructure domain ontology to representing the microstructure. And then we have a set of more standard ontologies, vocabularies that can actually be mapped to quite automatically by a mapping layer. So you don't need to manually, by hand, ensure that we have this alignment. That can be done once for all and just generated. I think it's fine. So this figure here shows how the microstructures can be represented. So these classes up here comes from the EMO core, and then this domain ontology represents the microstructure. This is quite an important part of EMO actually, that the microstructure is not an object. You don't describe it as a description of how the the microstructure of the object. It is the material. So it is actually, it is a composite material microstructure. It's also a holistic arrangement, and it's size dependent. You can see the definition of a microstructure. It's a composite material whose components are in general so small that they require a microscope to be observed. It's taken from, I think it was Oxford language. Which is really aligned with how it's defined. A microstructure has some components. These components here can, for instance, be the particles, grains, clusters, subgrains, and so on. The matrix, of course, is very important, and so on. These, and of course, these particles, which is really important for the behavior of an aluminium alloy. Especially these precipitates here, they determine more than 50% of the strength, for instance, whether you have them or not. Actually, probably much more. Anyway, so this is just how microstructures can be represented in this framework. So, as a summary, I think there is a lot of benefits of representing DPP as a knowledge graph. I think many have pointed that out already today. We have these EU DPP and DPPO ontologies already for the standard DPP layer, but this is quite mature horizontally, but it lacks material perspective. For that, we have EMMO, plus its domain ontologies, SFBD, core ontology. And one more point that also is worth to mention is that EMO is, as a top-level ontology, can even, as a possibility to serve as a top-level ontology, even for the DPP. You would then get all the access to the whole theoretical framework, which would improve interoperability. It would really give you a much more ontological scalability in the sense that you can go between scales, dig into really the nature of the material. Thank you.
Thank you, Jasper. In the name of time, we do not have time for questions, I'm sorry. But I'm quite sure that Jasper is open for, in the coffee break, for any kind of questions you might have when it comes to the EMO. So our next speaker is going to be Raoul Karlsson from the Research Institute of Sweden. And he's going to present us an approach how to make the digitalization of ABS fit for a circular economy. Raoul, floor is yours. So I need to start your presentation, I guess.
Do that, otherwise we don't know what happens.
Come on. So where is it? Yeah. Is it this one?
It
yes.
like it,
yes,
yeah.
yes. I renamed it so that I.
Yeah. Misspelled it though, but okay, it's fine.
Misspelled?
It was an O instead of U, but who cares? This is a file. It's digital.
Okay, thank you.
Okay, so I should talk with this.
You can use
okay.
this one.
So I'm going to report basically what we have done in the project Absoleu, ABS plastic. I will soon give you some short words about what ABS is, for those of you who are not plastics experts. And I'll show you this slide basically to say something what the overall project was. It ended this Sunday. That was the last day. So it was 4 years up to this Sunday. And last Friday, last week, this Monday, we also had, yesterday morning, we had a final review meeting. So it was very, very close to end now. And the companies, you can see the OEMs, you recognize the names, the Lego, and you know who those are, and you know who Volvo is, Volvo Cars and BIC. These were the end users of ABS plastic, so now you know something about that. You actually have met ABS plastic in your life. We had Trinseo, who is a ABS plastic provider. We have Galoo, that you can see in the bottom there. It's a recycler, really big recycling company. I understand it's on the border between Belgium and France. Actually in both countries, I understand. And we have Research Institute TNO RISE, which I am at. I never remember what CNRS is. And we had Trinseo Plastic also, and then the PI is a Policy Research Institute. So we had, and SIS, Swedish Institute of Standards. So we knew that we were going to make standards. We knew that we're not going to make only digital standards, but also plastic standards at the same time as the project was running. Jotne, by the way, very important. They are down by the corner there. They are the experts on STEP standards. We have used STEP. We haven't used any of the other shackle or whatever they might mean, but they are really stable for oil platforms and spaceships and Boeing planes and even cars. So that was us, and the whole idea was to revolutionize the current state of ABS recycling. Recycling is important. We understand that we are in a circular domain, so we understand recycling is very important. And ABS plastic is a nightmare to recycle. And the reason it's a nightmare, let's see if I can, did it happen there? No, it didn't happen there. Let's see, where there? Maybe. Yeah, no. I cannot be heard when I stand there, right? Okay, I'll take that one. So ABS plastic, A is acrylonitrile, B is butadiene, and S is styrene. And they have really different properties. They have different chemical properties, mechanical properties, and temperature properties, so they really behave differently, and that makes them tricky to take care of, to separate once you mix them together. But they also are fantastic because you can make almost steel quality or rubber quality or really different things out from them, and that makes it very hard to stop industry from using them. Us consumers, we also really like them because they are cheap and they solve a lot of problems that we wouldn't have dreamed of buying in just polystyrene or anything like that. We want to have them almost behave like metals. So the market is of course drowned with them. We have them everywhere and no one can recycle them in a way that make them preserve the value. So it's a fantastic thing to put on the market. It's an awful thing to take back. My speak is trustworthiness for secondary markets, and you understand that there is not so many secondary markets. It's something that becomes worse and worse every time you take it back and try to recycle it. So what we have tried to achieve is a model for traceable, requalifiable circular material DPP. And requalifiable means that every time you have such a product somewhere, it might have been contaminated, it might have been deteriorated, it might have been exposed to whatever that happens out there when you use these plastics that are very sturdy. At the same time, we know that there is coming a Circular Economy Act. Not everybody, but those who are in the vicinity of politics, and that seems like maybe 75% of you are around there. And that one will definitely address increased use of secondary materials. And that means that not only ABS is like this, but lots of other materials. Textile is really like this also. It's really tricky to get that back on track once you have had it out there. Everybody who have this DPP on textile know that. We know that constructions are really wonderful to set up. You can make BIM models and you can make everything. And then one of those days, you're in a hurry, you have to bring them down, or you happen to burn up half of them, and it's a mess everywhere. So it's really tricky to get things back. So one have to know what one have. So using secondary materials introduces always a risk for the next cycle. But we have I just mentioned the worst ones, and all the other ones are in the boundary of this domain. I heard before that everything starts with a substance. Yes, and a substance that are slightly contaminated, because very seldom you have only a substance. You have substance with acceptable contamination. And when you go over to unacceptable contamination, you are aware of it. But before that, you just have, a substance with an acceptable contamination. It's good to know. So we don't start with substance. In a way, we start with materials that after a while they'll be mixed with other materials. So what we were about to do, this basically, you can see that on the left side there comes an arrow in. That's from an oil well, let's say, or 3 different oil wells, so what it might be, which is of course not a substance, it's a mess of substances that also. You make material of it, which might be plastic raw materials, A, B, and S, and then you put it on the truck, so whatever you do, you make the ABS component, truck again, and you manufacturing somewhere, you make a pen, or you make a Lego brick, or you make a car, and then again you use it, and usually people just throw them away if they are hard. I mean, at some point, if it's really worthless, you throw them away. But if you want to really make that curve, you do the dismantling, recycling, sorting, and everything goes back again. So this is what we want to achieve. The challenges we have is that we need to, since we know that material change between every time we look at them, we know precisely what they are, and then they might be exposed to something, but they might be mixed with something else, and then they are not exactly what they are before. So we have to keep track of them all the time if you really want to know what we're going to recycle. For example, I can say already now that Lego did not accept our results because it was not high quality enough. So that means that they can use virgin materials still, but they cannot use recycled materials because the reality is a lot of risks, shadows going around, putting dirt into the system that makes it not as pure as it was before. And that makes everything you have on the table is of course like that also. You have used it, we don't know exactly how exactly you used it or whatever happened. So recycling is trickier than just perfect things. And we, of course, knowing this, we went out and to look at the reality. This is a car to be recycled, and it has crashed before, and it doesn't, parts doesn't fit together exactly as they did before when they did not crash. So you cannot really purely take everything apart. There is a mess. They are already mixed with oil and other chemicals when you're at this stage. One had to fix that, and what we did there was to ask them, can you even identify ABS plastic, and how, if you can do that, would you do it? What would it cost you? Yes, we can. And we would like to if anyone requires us to. Today there is no law on doing that, but if anyone want it and pay for it, they can do it, which is a good starting point. So we are not dreaming. It's actually possible. It's just a matter of will and do it. So we also had a lot of workshops. I mean, we can see what models looks like before you're fancy. And here is, we met in different places, drawing up. There's a backcasting supply chain, distinguish between open and closed loop, which is a very important thing. Open loop is when you don't know what you have in there. Closed is what we want to have when we think that we have pure materials. Feedbacking supply chain, because when we have a supply chain, we might want to tell them, you didn't do so well, could you improve, please? Things like that. And quality of material input and output, because as recycling method really need clean, understandable material in to give something understandable out. And when it's not understandable in, when you don't know what you get in, you get the mixture of stuff out. Gallo is super good, the one I mentioned. They are really good at basically put your entire society in a big cruncher, and eventually it sorts it up in a lot of different piles of materials. Really, actually a place everybody should go visit. It's really it's a good education, a really big funnel. You just put everything in and it grinds it, and eventually there's a lot of big piles of raw material of different kinds. And of course we mailed each other a lot of different models in between, and this is just one showing how a company today work with designing the product, specifying the materials, sending material specification to the supplier so that the supplier can do that material. And so that is actually where materials are starting their lives. They start their lives as a requirement. They don't start their life as a chemical mix. they start their lives as a requirement of properties, purities, acceptable contamination and so. So that's where they start their life. So if you want to start tracing material from industry, start when they actually specify them. That's where our model starts, at the designation. Yeah. And the designation, or any aspect of a material, its properties, always has a standard. So the fat text here is the number of a standard. And it's just some, I made it because that is what people talked about when I said our lab experts in different organizations say the melting temperature, heat conduction, transparent to light frequency, directional strength, all these things they talk about, but in reality it's about standard methods for standardized methods. That's the only thing you can really communicate. So when they say what they want to have, they give a list of standard measurements and the span which they're going to have the data from in. Which is very important also, because this is not really difficult, because if no one have made a standard of it or can specify it very, very well, you cannot measure it at all, of course. You cannot agree. So having understood all these things, we started drawing the model that you can see here. Now I will do kind of the same thing that Jesper did here. I do that. I will just tell you that we start here with some product design, and then you understand that you have a material requirement that need to fulfill that. For example, the dashboard of a car should withstand really high temperatures for 40 years, or low temperatures in the winters of 40 years, etc., or 20 or 50. And they tell that to the material supplier. And so the whole idea is that they can use the same format and the same specification. They can use, sorry, thank you, very, very thankful. Okay, so they can use the same format when they specify the material as they can have when they give it to the chemists. And then the chemists can use that to put together a material recipe, and eventually up here, they can test, do we comply with the requirement? Because that is, of course, important. The one who ordered it must check whether they can actually comply. And if it does, they can produce it. Otherwise, they have some work still to do. And that's how industry works. It's very simple. So DPP should, of course, start here somewhere, knowing things about stuff. Okay, I show, by the way. And of course, of it here, when they say okay, they start producing it. But since everybody expects them to know a lot and they report a lot in the Digital Product Passport, then they can start filling their material declarations for the Digital Product Passport. That is when they start, after having known that for a very long time, what they will actually want to do. And use phase, service, and repair. Sometimes you want to replace something, you might throw it away, want to know what it is, end of life, dismantling, and the dismantling ends up in the recycling. Some of the recycling actually can be close to recycling if one is very happy, at least very, very good, and then one can send that back. Or slightly contaminated, they can send it back also. So these things is what we want to achieve by traceability. Yeah, so basically what I just said. Material requirement to deliver quality control, and product life cycle to circular path. So we want that to happen. Everybody have already shown their pictures of the same thing all the days. But what also happens when you can do this is that when you notice that you actually cannot recycle it, and everybody promised that to begin with, and they thought they had really smart ideas, but something unexpected happened over the years when the product was on the market, then you can actually learn from that and send that information back if you have made contacts traceable. So you can actually go back and trace back the root causes, you can change specifications, redesign material product, and so you can build up basically a continuous improvement system based on what we call today Digital Product Passports. But basically it's a way to improve societal control. So now I jump to our conclusion, because of course you see this is the way, the line of thought we've done here, or line of learning, and this is where we concentrated our learnings. It's entity relationship model or concept model, depending on which school you come from, and it starts with a sample. It starts with something that is nameless. It's just a number. And the number in itself can, be taken a sample out. You take a sample of something. To begin with, you can just have a batch. That could be the biggest sample we have. And then we can take a sample out of that and make tests on that. Or we can just want to take a test. And if we only want to take a test, then we specify, we make the material designation, the one that, for example, Volvo or Lego or BIC want to have. As again, that should be made in the same model, because otherwise we will have to translate that in different ways. And we know that a plastic should live through a number of process steps. It could be as a dashboard. You put out the car on the market and you expect it to live for a long time. It's just process specifications, the lifetime of the material. And that has to be specified before, so we know that it can fulfill its own lifetime. Otherwise, we have made a wrong purchased the wrong material. So that is on the designation side. Then we come to the actual sample that has been made by someone. We can analyze it. We can analyze it with methods, and we know that methods have different specifications, could be different parameter settings, different temperatures, different pressures. And when we know exactly what we've done according to the specifications, we get an analysis results with the physical and chemical properties, of course, or the other properties also. And that one we want should be the same as the one designated to begin with. And also just withstand the same processing. So what we want to achieve here is that the designation, the one that someone want to have from the production, and the thing that we actually got is the same. We want that to happen. And it's the same after the full product life cycle. If we want to have a raw material for recycling, then we must specify the entire chain up to that point to provide us with recyclable materials. And having that as a model, and this only transfers chemical or ABS or industry information into a concept model. The next step, of course, is to make it into some kind of don't wake him up, no, please. Shh. Kidding. No. So what we have then is just a translation of the concepts, and what we wrong arrow again. What we wanted to achieve in the end of this was to get that model into a already standardized model, and that is the step model that we have here. So the step model has taken all the different concepts and relations and restrictions into the application protocol, so the step ISO 10303 standard. And that means that from this, anyone can actually access precisely the same understanding. So this is what we are also putting as the result of the project out there. Maybe not. We don't need to drown in this. I would say the same things, but in that term. So it does exactly the same thing. How much time? Am I over?
Over time.
Overtime.
A little bit.
Okay. So I had one if I was not on overtime. So okay. But that's it. What we have is therefore something that actually works for the total recycling requirement system. So basically it. And this one, if I would have been talking quicker, you would have seen me do a little 30-second show. But now I just end here. And what you see here on the QR code, this is an order document of the SQL script for doing that database that we saw.
Okay. Thank you, Raoul. Thank you very much. If I'm not mistaken, this had been the first presentation which really had the topic of recycling in its core, which is, of course, an important element when it comes to circular economy. So, but I think we are a little bit over time, so I think Raoul is happy to answer any questions during the break. Thank you.
Okay, and it's my pleasure to introduce Martin. Martin Horsch is from NMBU, the Norwegian University of Science, Life Science, is it now?
That's right, that's right.
You got that? Okay, super.
Oh, okay. Screen gone again. Everything is gone. What I will say now will really not surprise anybody here, and that is that interoperability is a complicated phenomenon. Naturally, it's complicated to achieve. We know this. And very many people emphasize, it's also not wrong, the side of semantics and that we need ontologies and a common language so that we know what we're talking about. We can represent our knowledge. And here is an example that I like to bring. Obviously, it's not wrong, right? The work on the ontologies is a perfectly legitimate and necessary work. Now let's imagine there's a guy called Peter and another Paul. And Peter sits at a restaurant. No, Peter's the waiter at a restaurant. Paul sits at a restaurant. Peter asks, what do you want to order? Right, and then comes, and this is in a language that they both understand. Imagine they're writing it up in RDF triples. It's possible, right? This is a query, some kind of query, and then you can answer. And he answers, there's this other restaurant, and it's owned by Patrick, and there's an item on the list, and it contains this and that, and so on. So obviously this makes no sense, and then Peter will say, you're stupid, you're crazy, you should someone should take care of you, despite having the common language. So obviously we know from practice it's not enough, and often not the main development task to have a new ontology. It's to have the communication and the exchange information that match, right? This should match. And therefore, also quite a few of the previous presentations said it's important to specify, for example, to specify the protocol, what is being said where, and to specify the interfaces. For example, for the data ingest, I want to communicate information that should become one digital product passport. How should I specify this information? For example, using Shackle. Shackle can be used to validate a knowledge graph that is coming as ingested information. And it can also be used, as has been done in our project DigiPass CSA as well, to automatically generate a form for manual data ingest, for example. So this is all part of the platform. I assume Franz Pirker will show in his talk how this looks, and so I don't have to present it. You know that this is possible. And obviously the manual data ingest is not necessarily something that scales up, but then even for other communication schemes, then you can use the Shackle for validation. That's that. But if you look into how interoperability has been discussed recently, it becomes more and more complicated. So, for example, there's the EOSC interoperability framework, the European interoperability framework, distinguishing different kinds of interoperability. Then there has been the project OntoCommons, already now quite some time ago. This had a focus on ontologies. And despite that, it found that the interoperability is really very complicated and many artifacts and tools are required beyond just the ontologies. So, for example, you can distinguish as it is done here, syntactic, semantic, pragmatic. That's one way of distinguishing. Like the syntax is the file format and the pragmatics is everything you do. And then we can also ask what is being made interoperable. There from Onto Commons, this document, the review of domain interoperability, introduces the so-called DOS formalism, DHOS, data human organization software. Different things you can try to combine with each other and make them work together. And actually all of those are meaningful, and different kinds of artifacts, tools, methodologies can assist them. Ontologies can play a role there, but yeah, clearly enough, it's not just those. It's a lot that needs to be developed. We know that. So I already said you would not be surprised. Another way of looking at interoperability is through the lens of the DIKW pyramid. So here you see the Knowledge Graph Alliance. The Knowledge Graph Alliance is, in a way, the successor organization to the Onto Commons project. Unfortunately, now the Knowledge Graph Alliance has not been functioning very well. We have to admit that. But you can see it has here, it's part of, it's a slogan, data to wisdom. This is a quote from this formalism that you see here, the DIKW pyramid. Each of those can also, or this whole hierarchy can represent the depth at which we have understood something, if we can characterize it in that way, right? So for example, we can define the syntax of something, we can define the semantics. Now we can make an assertion, a proposition. We can formulate a proposition. We can say what its semantics are in terms of whatever logic, no problem. But in this way, we still have not established, for example, the status that this proposition has. Is it true, yes or no? More than that. In what way, for example, is it a scientific claim? What status as knowledge does it have? So this is the next level, epistemic. And then how do we deal with it? How do we exchange it? So in this representation, we have one level more. We have the syntax, semantics, then epistemic characterization, and the pragmatic level as wisdom. So we know interoperability is complicated. And now we need to get the interoperability sorted for the digital product passport. It becomes more and more complicated. I'm also here not the first person, so people have said this again and again. Obviously, the companies, the projects, the people who have the data that should go into the digital product passport, they have their own pre-existing data architecture and schema, which is not the same as the one for the DPP. So somehow you need to map them, you need to transform them. So it becomes a problem of, for example, ontology alignment. Here you see one diagram that I took from the Ontology Alignment Evaluation Initiative. You can align at a schema level, at the level of the ontology. You can align at the level of the individuals and relationships, instances. And sometimes you can get one-to-one mapping or alignments that are simple, but in reality it becomes very complicated very easily. We did this exercise some time ago. Actually, you see Peter is the first author of this. We were looking at two popular ways of working on materials information. And one of them is the dreaded MODA. When you do a simulation workflow, of course it has been very endorsed and some people like to use it. The model data specification tables and graphs for the workflows is very complicated to fill in a MODA. But yes, okay, so this is one standard that is established. And then there has been the long work on the EMMO, which then has these different perspectives. In this case, we were working with one of the perspectives that Jesper just mentioned, which is the semiotics. The Persian semiotics to describe how information is really processed throughout when you do something, for example, a scientific workflow. And you should be able to represent the same scientific workflow, for example, a simulation workflow, that you have in MODA, also using the EMMO or that particular perspective. but it looks very different. And it's not just a one-to-one mapping. And the same happens when you compare other ontologies or metadata schemas that are well established, that are thoroughly and deeply thought through, then they're also deeply different. And the mapping becomes, therefore, very complicated. So you can do that using graph transformation. The graph transformation is very complicated. It might be possible to do within Sparkle. And this is something we want to attempt to formulate within DigiPass CSA. And this is one of the challenges. So now I have to say we're all over time. It is terrible. I hope I'm not going over time. I will just stop. When I'm at the 15 minutes and when I'm 14 minutes, I just stop. You don't get to ask me any questions, but I get to ask you questions. And I'm not going to tell you what they are. Now you just go there. These are the questions. Here we try to figure out what is the interoperability challenge that we have within DigiPass CSA. Budcut info, it says here only because it's easy for me to upload something to Budcut info. It's really from DigiPass CSA. One thing that we want to figure out is what platforms do we have to interoperate with? And you know, the European Commission has been saying for a long time, architecture of the future is data spaces. The data spaces, and we have the IDSA, the International Data Spaces Association, the DSSC, the Data Spaces Support Center, and data spaces, common European data spaces. And we have heard from ChemX. We have heard from ConstructionX. They build data spaces. So, yeah, when we wrote the description of action, when we wrote the proposal, we thought it will be very important for this reason to interoperate with data spaces. And this is therefore also part of our description of action. But then we did this same exercise that I'm still asking you to also contribute to. 2 months ago, when we were meeting, when we were doing a datathon at Esch-sur-Alzette, and we were asking the people, where would the information from what platforms would the information that we're supposed to use, that you are using, for the LCA, for the DPP, where would it come from? Because that's what we actually need to interoperate with in reality, right? And nobody mentioned one data space. Not one. Nobody mentioned the ChemX, nobody mentioned the ConstructionX, or the people mentioned these things that are there that are not data spaces. Maybe it's a question of development. In a few years may look different. I just want to report. I was surprised, actually. Good. So that's a bit one part of what we're doing. Another part, if we speak about the interoperability challenge, I should also mention that we did rather deep exercise in gathering such requirements in the form of competency questions. This is a very established technique. I assume a few of you will know it well. If you want to gather requirements for example, developing an ontology, then you can do that by asking representative questions that you want a digital infrastructure to be able to answer competently. That's why they're called competency questions. It's an established technique. They are questions in human language. And what you do then is, for example, you take this question here, and you try to translate it into Sparkle, into a formal query, where all the human words are replaced, the verbs are replaced by relations, the nouns, they are replaced by concepts. And if you can do this completely, then you know you have a knowledge representation formalism that satisfies all these requirements. And here our aim was, we don't want to develop another DPP ontology. We really just wanted to look what is covered in the existing ontologies. For example, Onto Decide from Linköping, the people there, they're developing ontologies can cover a lot, and others. We actually found 10 pre-existing ontologies at the domain level that can be reused to a substantial extent. And it's not our aim to do a lot of ontology development ourselves. Now I've used 14 minutes, and therefore I will stop now.
Thank you, Martin. Thank you for discussing the rule of ontologies, taxonomies, and how they are going to be set up and how they are going to support, or how they are supposed to support all these systems, including the DPP system. It's now my pleasure to close session 5. I'm not sure, do we have a a break now, no break, so we immediately start with session 6.
I realized this was a pretty tough program, but unfortunately one of the presenters in this session cannot come, so it's 3 presentations until the coffee break. My name is Cristina Guerreiro. I work at NILU, which is a research institute in Norway focused on climate and environment. And I'm the coordinator of the project Sea Rise that we have been presenting to you yesterday, this morning. There's another poster back there. So I hope to see you around these days. For those of you that don't know who I am, I don't know if my co-chair is here. Franz Pirker. Yes, okay. Yeah, and I think without further ado, we can start inviting the first speaker to the podium. It's Dr. Steffi Friedrich, founder and director of Acumentist. Yes. Dr. Steffi Friedrich has been a leading expert, policy advisor and business representative for emerging technological innovation for nearly 20 years. And she will be presenting characterizing transformations. I don't know if I forgot to say, but the topic of this session is SSBD, so Safe and Sustainable by Design and DPP challenges, which is a topic very close to my heart and our institute's work. So I hope you find a presentation there. It's this one. And do you want this one or?
It's working. Okay. Cool. Thank you. Please. Good. Thank you. Is there something we have to do regarding the magic, or is it going to be automatic?
Anyone has? Oh, it's coming.
Yes. Okay. It's just a little bit delayed. It probably had to go via Silicon Valley. Hello, everybody. This is going to be completely different, not only in color, but also in content. I'm not speaking a lot about SSBD. I leave that to my colleagues who know a lot more about that, the 2 speakers after me. But what I would like to talk about is a little bit the background of why we're talking so much about having to make the digital data passport, the data passport work for other things and not only the processes that are the most obvious to be digitalized. So we are working, and when I'm saying we, that includes the speakers after me as well, because this project that you can see up here finished on Sunday, 31st of May, after 3.5 years. And we were mainly looking at materials in their specific products. And we were interested in the safety and sustainability of these materials. And in order to work on the safety and sustainability of these materials, so this is not the materials that we are trying to keep safe, but we try to keep the human users, manufacturers, and the environment safe when these materials are integrated into their product. Sorry, that's what I should say when I say safety and sustainability of materials. The thing we are trying to do is we're trying to work on new methodologies on how to better assess the safety for the regulatory context. So we're talking about standardization of test methods here, the methods that any material user, manufacturer, intermediate supplier needs to fulfill in order to bring a new material in a product onto the market in Europe. It's all going to become a little bit clearer, but I just wanted to tell you that don't expect me to speak an awful lot about digitalization. In fact, what I would like to demonstrate here is that there is a need for your digitalization, for your expertise, to work for other areas as well. And while we have started doing that for our little microcosm here that I'm about to explain to you, there is a lot more that we need from this community in order to meet us in the middle. We can do an awful lot more to make the DPP work for our material safety, our chemical safety processes, but there is a lot more that we need you to allow us to integrate as well. So, to start off on this journey of having complex slides here, what you can see here is the overall layout of our project. And yes, pink was a theme. That was the one wish that I had when we wrote this project about 4 years ago. It was all about having a memorable picture on page number 1 in order to be different from the rest of the proposals to be handed in, and it worked. What can I tell you? It did work. So we are starting off on the left-hand side, as you are reading. We have 5 different specific use cases, and these are real materials on the market, real products on the market, in which we have a specific material, and we decided our material was going to be everything to do with graphene. We have 5 different cases in which carbon is present. So the first one is graphene-related material. That's what GRM stands for in water filters. Graphene-related material in battery management systems. Graphene-related material in car wax sprays, or so we thought. CNTs, carbon nanotubes, which are essentially a rolled up sheet of graphene, but this time a long aspect ratio with a comparison, an unfortunate comparison to asbestos, and that is something that needs to be established. And then that last part is a polylactic glycolic acid. And that is not graphene, for the simple reason that we knew that graphene may pose a problem by inhaling it in the lung tissue. And what we wanted to show is what can we do to detect the graphene. We are talking about detecting carbon in our environment full of carbon. So we wanted to work on characterization and detection methodologies, but for that we needed a compound that was based on carbon, but that we knew would be okay to get into the lung fluid, to go through the lung into the bloodstream, and then we can detect it further. And that is why we were using this polylactic glycolic acid, which is used as a carrier in inhalers, and we doped it with gold in order to follow it a little bit further in the bloodstream and in the human. So this was in order to have essentially a control material. We looked, and that is the top of that hourglass there, at a number of different quantitative imaging characterization methodologies, looking at this one carbon nanotube. In your microscopists amongst you will recognize that the typical micrograph that you show in your presentation is anything but typical, but this is essentially what we needed to do. We needed to work on better quantified imaging techniques and a number of other phys-chem techniques. And then the bottom part of that hourglass in the middle is all sorts of tests that we were working on to make them better, make them more applicable to these materials. So we were looking at how to test the toxicity that these materials would have in the lung. We were looking at general toxicity testing as a larger, complex decision tree, and we were looking at ecotoxicity. And then moving on to the right, you can see a whole list of different, what we call our macrame outcomes, and these are all things that we would hand on to a standardization body or onto a policy informing body such as the OECD, because the OECD is the one that is globally agreeing and harmonizing test guidelines, those that our regulators, our colleagues at ECHA and anywhere else in the world in market access regulation would look at and would allow to be conducted and standardized to be conducted as the one reliable test. So if you want to bring a material to the market, a new innovative material to the market, you must do a number of different tests that your regulators tell you to do. The good thing is you don't have to do it again every time you bring it into a market somewhere else, because the OECD has the beauty of being part of MAT, which stands for Mutual Access, Acceptance of data, thank you, sorry. Mutual acceptance of data, meaning that you do it once and you don't have to do the same experiments again at the other end of the world. If you want to bring the same material or product into Brazil, you just show your data, and the subscribers to this mutual acceptance of data coordination at the OECD need to accept that data that you've created somewhere else. It's one of these great things that harmonization, globalization has brought as to not to having to repeat the animal testing specifically, because animal testing is one of the things that we have to go back to. There is a QR code for those who haven't realized now, but you get this slideshow afterwards. This is where you find the entire report of what our project was about. And now I'm in danger of being delayed with my little presentation as well. Here, just a very quick reminder as to how different these materials can look. So we have our graphene oxide in water filters. The graphene oxide looks very different. In the middle, you actually have a cross-section of the water filters for UC1. Number 2 is the few-layer graphene in the composites that go in the battery management system. That is a completely different thing. You need to treat it very differently when it is in a plastic matrix and an epoxy matrix. Number 3, our alleged spray that you use for waxing your car and in order to polish it really well was advertised to contain graphene. We couldn't find any graphene. That is a problem when you buy a product off the shelf. And then number 4 is the carbon nanotubes in car seats. They look like they are pink, but the car seat obviously is not pink, but this is the emulsion, the suspension that we had to create. And then the other way around. Number 4 is the black carbon nanotubes in your car seats, and number 5 is the polylactic glycolic acid. So what we first had to agree on is how to sample these things in their complex life cycles. So this is what in German we would call a Wimmelbild. Don't try to read it all in detail, but what you can see is that for everyone, pink is our characterization of the entire life cycle, ranging from the left-hand side, the pristine material, and then up to the right-hand side, the incineration or other end-of-life stages. Blue is the characterization and detection, yellow is the human toxicity, and green is the ecotoxicity, and you can find that for every one of our different use cases, we defined a sampling point to go into the life cycle and say, this is where we're now going to take a sample. And the first thing then is try to find the material you're looking for. Not always successful. And the next one then is try to figure out if in the component that it has now created, in the compound that it has, does it actually pose any danger? Has its safety profile changed? So we've done all that, and you can easily imagine that is where we come to you now. This all needs to be connected by data, because that many different points here and figuring out where did I take the sample, what happened to it by the time I've taken it out of its life cycle, has it been incinerated, has it been sitting on a landfill? I need to make sure I'm backtracking all of the data, and that is what we managed to do with our in the middle of the, I can actually go back, I have the power. In the middle of this slide, which I didn't explain, the hexagon is our data hub. That is where we connected all of our data from our original, what did we know about our use cases, to what data did we create, to what was the data we then used in order to create our output. That black hexagon in the middle is our major data hub. So going back to here, this is what our data hub looks like if you concentrate just on that thing. The little sheep explains that we had a data shepherd. He will speak to you a little bit later. And we essentially also made a point of collecting all of the metadata, because there is a strong belief that it is the metadata that is the most important when it comes to identifying a problem later with your sample and having to go back and trying to find out what the heck happened, what made it different from the rest of the samples. So very important metadata needs to be collected. And of course, all of that was done in a verification cycle, and all of the different aspects were addressed, because the Commission said so when they put the call text out, and we wanted the money, so we made sure that we did everything fully verified. But of course, we also have to say there is a reason to do so, and the idea, we fully bought into that one. Again, article at the top right. So this is a step further. This is an overview of the different test guidelines and the standards that we developed. So you can see the from the extraction of the raw material into the production of the advanced materials, we then have these 5 different macrame use cases going out towards 1 o'clock. And those are describing different cycles, and every one of those is addressing a different test guideline. These test guidelines exist already at the OECD, but they have been largely written for chemicals, soluble chemicals, and you can no longer do this sort of work on insoluble materials, and that is where we come in. What we have decided is we are going to write all of these results. That is one result here, the science-based recommendation. We're going to read all of these into 12 informed recommendations. We bounce these recommendations off our stakeholder community, so the regulatory community at the OECD, the standardization community. The most important of these 12 are the last two, because they speak about the information flow that we need to manage very well during the life cycle, and the sharing of the safety relevant information on these advanced materials in their life cycle. And I believe the other two colleagues will tell you a little bit more about that. Here is another overview. It looks a little bit prettier than the first slide, of our outputs. Again, on the top right, you have the QR code that links you directly to the 12 recommendations. This was a post that represented the OECD, and the other one is the general output. Just a quick note, project ended on Sunday. These are our follow-up projects. They have already been running for a good 2 years, and they will be running for nearly 2 years more. It is important to know what's going to happen to your legacy and your data once you're in the middle of your project, not only after your project ended. And we managed very well here because we got 3 complementary projects to use our data and to work with that one. And the final part, here is one for the coordinator of the PINK project will be, I believe, the last one in this session speaking to you, Thomas Exner. And here is one for Thomas because I know he judges the quality of projects by their PERT chart. Thomas, I hope you enjoy this. Thank you.
Thank you. Are there any questions? I think you were in time, more or less. Just 1 minute.
There's time for at least a question, yeah? No?
No question, then? Thanks, Steffi.
Okay, the next speaker is Cyril Durand. He is the lead sustainability at TMS Solutions. You can get out of there. With a background in designing circular and sustainable products and materials within an international corporate setting. He has specialized in conducting sustainability assessments throughout the innovation process to help develop products and materials that are safe and sustainable by design. Yes, okay, you need to put presentations, so please.
Okay. So what I'm going to talk about is, in this presentation is more from the innovation or the research and the innovation angle, meaning that, you know, if I... Probably best with this. Yeah, so the angle of my presentation is more on the focusing on the research and innovation approach. And basically, if I want to design or to redesign a new product that will require new materials, a new process, how can I make sure that I develop, I would say, the safest and the most sustainable product, or you know, how I can make sure that I use the right approach, the right methodology to develop this safest and most sustainable, and then how I can, if I'm successful, how can I use the metrics, especially for the DPP. Very quick snapshot about who we are at TMS Solution. We are a Swiss SME founded a few 6 years ago. Our goal is really to what we call to bridge the gap between innovative ideas and regulatory compliant product, and most of our activities is really to implement the safe and sustainable by design principle. So what are the safe and sustainable by design principle here? It is about an holistic approach. So basically, even though you are in the innovation process, so basically you still doing research and development, you still need to have a view and estimate how your product will live in the real world, in the life cycle. You know, when you're going to be produced, the type of raw materials, the real production, you know, whatever transportation, and you can see some other use and end of life cycle. So you really need to project yourself into making sure that this product will be safe and sustainable during this life cycle. And for that, you have a few, you know, few or many type of dimensions, or that each have many indicators, which is about the functionality and the process design. You have the safety, the sustainability, and the circularity. And you then can apply this SSBD along the innovation process. That's why you have a kind of a tiered approach, because at the beginning you don't have that many data, and you still want to apply at the beginning. And then as your development is progressing, you have more and more data, and then you can enrich your SSBD approach. This is a framework, this SSBD that has been issued in 2022 by the European Commission, developed by the GRC. It is a voluntary approach. And it is, you know, while you are doing this innovation process using this SSBD, it is combined with some, you know, regulation, meaning the REACH regulation that can support for all the safety analysis, the SPR that as well help you to look the eco-design aspect, because SSBD is safe and sustainable by design. So before all, you need really to start with designing the right product, which is safe and sustainable. And again, if you are successful in your innovation process, because not all the innovation process end up with you know, something in the market, but if it is the case, then you know, you have some data that are ready to feed the DPP. Now, there it's a little bit complicated, but I wanted to have a kind of an overview of how I see you know, the SSBD, the SPR, and the DPP into a kind of a try to simplify the overall approach. And then where the Elegance project, because all I'm talking about this today is within the context of an EU-funded Elegance project. I will have a slide to let you know what I'm talking about the Elegance. But if you look at the upper side of the arrow, well, this is the typical innovation process. You start with the concept, the lab scale, scale up, pilot, and then during this innovation process, you want really to design for, of course, get your functionality for your consumers, but as well design for safety and stability. If you, again, successful, your product is getting to the market. Now, underneath the arrow, you have at your availability with this framework the requirement or the criteria that this SSBD provide you. You can combine that as well with this ESPR, Eco-Design for Sustainable Product Regulation, which provide as well a number of requirements and criteria that you can use. And then you have this Eco-Design matrix that you can you know, generate during your project, and that can tell you about how well you're progressing toward the safe and sustainable aspect. And all of this, again, it's you know, you are feeding and tiering new data as you get along the projects. So you have you know, the safety, the hazard, and occupational environmental exposure and risk assessment. You have the sustainability aspect. You want to design for recycling. You want to design for circularity. You want to minimize the waste. And of course, you want to have your essential functionality to for your consumers. If you have all this right, then you get to an optimized SSBD compliance and eco-design approach compliance you know, device or product. And then again, this can be can have some several round of optimization, and then you have your metrics ready to feed your DPP for your safety documentation or instruction in terms of as well occupational safety. You have how you can dispose and recover your product, and even the product specs for the functionality, the durability, and the lifespan. So now I will give you a concrete example within the elegance. So elegance is about an electronic, flexible ink printed cards, which contains multiple features. It contains the solar models to harvest the energy that you need. You have a memory stiff crossbar, you have electrochromic structure, and then some type of sensing in case that's all for the application. If you want to sense your temperature of your body, for example, or something that you can use it for, but it has many applications. It all started in October 2024, and it's going to be for 4 years. So you can realize right now that what I'm going to present is really work in progress, because this elegance project is going from, and this is probably where I didn't mention here, but the elegance project is more at the beginning of the innovation process, going from TRL 3 and TRL 5. So we do apply the SSBD really from the beginning, because this is all about using printable ink and solvents. So obviously you want, as early as possible in your innovation process, avoid the hazardous substance or substance of very high concern. You want as well to have not too harmful processes for when you're going to go to the market for your workers that are going to do this product. So really applying the SSBD, you really start with the scoping. So first you have a little bit of your environmental strategy. You want to understand what will be your SSBD goals. So here, this is really the context of the elegance. You want, of course, to use here to avoid your substance of very high concern and the raw materials. In the manufacturing, here we have the objective to really lower the energy that is going to be used to make these flexible printing cards. So we have some threshold about the energy, about the temperature that we want to use. During the use phase, so we're going to use these cards. We want to have the lowest energy for functionality of this card, and then you want to be able to recycle some of the ink or the substrate. And then in the system boundaries, here is come the going a little bit more deeper into the material list that you will use for making these cards, and the processes that will be used. And then you will end up by combining the materials and the processes, some building blocks for your device, and you will have the design option. So here you will see that later in the slides that the innovators have multiple design options. So how can I make sure that I will going to use or I'm going to develop the right options in terms of the safest and the most suitable device? So I will go quick on this one. So you look at all the safety screening. You want to make sure your materials and processes will not harm consumers, will not harm the workers, and will not harm the environment. So you have many safety screening that you go through. You end up with, in this project, for example, 84 chemicals been assessed. So you end up with some recommendation in this table about, you can find that some solvents are very volatile. You want to lower the volatility. You have many other things. You have some powder and aerosols that can as well be very harmful. So we provide some recommendation to the innovators for them to go back to the, I would say, drawing board and provide safer product or safer materials. Now, in terms of after screening the safety, we want to look at the accessibility aspect, which is much broader. So this is here a really innovators collaboration approach. But you want to have really the experts of understanding what will be the different metrics, especially when it comes to functionality. So you take your innovation goals that I presented before. You leverage some supporting documents regarding ESPR, GRC, SSBD, and some others. And then as a collaborative approach, you end up with a series of metrics which come from different dimensions. Of course, human health, I presented that. The environment, you want really to lower the, for example, the CO2 emission. Circularity is more about the, the material use. You want to minimize your materials use. The functionality limit, and then the supply reach, which is also important. You want to avoid the use of critical raw materials that are on the European list. You want to avoid, for example, that you use only one supplier in the world, because that could be, of course, very risky, and so forth. An example of how this matrix is about, for each of the metrics, you end up with a minimum and optimal targets, and again, this comes to a very collaborative approach, because you want each of the experts who they are innovators or they are safety or sustainability experts to provide a kind of a very simple scoring, and then you end up with a way that you can separate functionality from sustainability, and I will tell you why. So you have a score for your functionality metrics, and then you have a score for your sustainability, which is the sum of supply, risk, total health, environment, and circularity. Yeah, and this is they will be my last slide, and that's where we are at the moment. So we've been able to apply the SSBD in a way that it can tell us, when it's combined to ESPR requirements, where we could have how it looked like in terms of level of functionality against the sustainability. We had a design out of the three other BCD design that is very encouraging and has a high potentiality of being, very sustainable. Of course, this is the first, the first approach in the design A, and it will require some refinement. That ultimately, when refined, an LCA, which is very much more, resource demanding, but that will be there to validate and provide the latest data for the potentially for the DPP. I wanted to give this message here in this presentation that the SSBD and the DPP is not only about feeding, about generating data, for the DPP, but as well, it can really help to make sure, or help to make sure somehow that you are really designing the most, I would say, the safest and the most sustainable design for your product. Thank you.
Thank you. Many thanks. I think full in time. We have one question. Yeah.
I did not get the metrics. Are they defined as part of the process on a case-by-case basis, or are they somehow generalized, like product category rules, where it could they could yield then comparability between different products of various vendors, like the French Repairability Index, for example?
Yeah. Yes. Well, the functionality, of course, are very, very electronics oriented, of course, because this is very linked to the device. Although they could be compared, from one device, from one electronic device to another. So I would say there's some level of comparability. Now, the sustainability indicators can really be generic because they talk about safety, they talk about the end of life, the recyclability. So these indicators can be extrapolated and used for many other applications. So basically, if I take another electronic device, I will be able to use 90% of this matrix of indicators.
Thank you. Okay, then we have the next speaker and the last one in this panel, Dr. Thomas Exner. He's a founding partner and chief scientist officer of Slovenia, Germany-based SME 7past9s. Please, if you close that one, you should find yours. Yeah. Yeah.
I know that I run around all the time, therefore you wouldn't hear me. Thanks a lot. In principle, everything is already said. The previous speaker made a very nice presentation, and therefore I hope everything about SSBD will be clear. I add a little bit to that. You will see that many of the slides are similar. But the main point which I will try to cover is why I'm here. And perhaps it is a little bit complicated to explain why I'm here. The PING project, which I represent, is in principle developing simulation and computation approaches to predict SSBD criteria. Yeah, we had a lot of them already shown in the last slide. But in principle, we are doing computer experiments. Yeah? Therefore, we are really not, we deal partly with virtual materials which are not existing. Therefore, we are very far away from products. But we still want to provide something. We are producing data. We want to guide SMEs to put this information, functionality, but then also sustainable and safety into their early research and innovation. Yeah, that these criteria really help to avoid failures at the end. Yeah, because we know that many things are very nice ideas, but then you see that they are toxic, or you cannot sustain them, or they use some starting materials which you cannot get anymore, or are very complicated and critical. Therefore, that is where we put in. There is a lot of data, there's a lot of real case studies, but in principle, that is our starting point. We go here, and this is just another version of this often shown picture. Yes, we have these different development stages. We start somewhere very early with an idea, and at the end, we hope we have a product on there. It also says, okay, we can fail here relatively cheap and early. Or if we fail early, then it's cheap, and we can learn something from that. But at the end, and this is where the passport is coming in, we need to be very certain that these results are what actually is the property of, or the safety profile of the material. We do that with multi-objective optimization, and the multi-objectives comes in here that yes, functionality is probably the primary result, but the last slide was from my previous speaker was really nice. Yeah, that you have this balancing. Yeah, you say yes, perhaps we can go a little bit down in the functionality if we then get to better sustainability of the whole thing. The next point is that we need to really look at everything, and this is the complicated part, yeah, because we want to have the full life cycle. We have all these different criteria, functionality, process design, then safety, sustainable, circularity, and if you want, you can add more than that. This is to your question in principle, are these defined, these criteria? There is the SSBD framework published by the JRC, which in principle provides a lot of these information. What are now these criteria? And I just click very quickly through them because there is a lot. Yeah, and this is the important thing. What is also important is that we are looking much more in detail into the things, yeah, because you know that the DPP needs these substances of concern. Yeah. SSBD, because we now have to understand why this is a substance concern, why we need that perhaps in the product, but also how we can then mediate these kind of problems by using different compounds, but also having some protection. We need to know more what the real problem is. And therefore, we have a lot of these safety criteria, which we need to go through. And this is just another picture of that, that you just have a lot of things, and then you test these different compounds and say, okay, are they mutagenic? And then you get yes, no answers from the computer, and you select then hopefully the ones which are actually better. And the same is here for the sustainability, which is in principle, or which is based on life cycle assessment. Yeah. You often see people talking about SSBD and life cycle assessment. If you come from the SSBD side, you say, why put a life cycle assessment additional there? It is part of SSBD. This is just because we talk to different people. And then we have a lot of more. Yeah? We can look at mechanistic knowledge, and this is mechanistic knowledge inside of biological systems, yeah? Because we are looking at safety. Then the whole characterization, which is also related to functionality, but also to the hazard and so on. Yeah? Process optimization, then end of life, what happens, all that is part in there. And this is for a chemical, and there, Adrian, I think, is not here anymore, but in principle, that is for us the easy case. You have a substance, you can look at all these different things, you can try to get from the chemical structure to a model, and then try to optimize that. If you go to a little bit of a more complex system, and this is a copolymer, yeah, and if I look here in the around, your products are much more complicated. Yeah? Therefore, yes, but if you look at the demand on data which you have already here, this is becoming extremely complicated, and therefore you have to separate these things into different stages where you say, okay, what can I actually predict at that point of time? Yeah? Raw materials are often chemicals, therefore they might be easier. Material production might be something we can extrapolate from somewhere else. But then, especially here at the later stages, it becomes very, very complicated to really make good predictions. And this is my slide to now show you why I think that I'm happy to be here, but perhaps somebody might think, why am I here? Because this is where the DPP is, very late. In principle, I have a material, I have a product, we have all, or we hopefully have all the information which needs to come in here. In pink, we are here, perhaps a little bit here. Yeah? Because we are looking at computational methods. But the problem we still have is that we have to communicate knowledge data, yeah? Or knowledge based on data. Therefore, this is for me a continuous process from here, where we have early predictions, to then something here which we can actually use in regulations. And this is then going into this information. We need the knowledge exchange between material designers, product designers, process designers, and so on and so on. We need the knowledge exchange between different partners here in the value chain. Yeah, when you look, and this is just a little bit of a thing from this SSBD framework, you don't have to read it. It's a nice read, but it's also, ask me if you have questions to that. But they, in principle, have that in here as well. Yeah, that you start with what they call the simple approach, where they just more or less look at one specific player somewhere in this value chain, and then they do something, and at the end you have all of them. I disagree with that, because I think we should start always with the full picture. We don't have the information for this whole picture, but we should still include everything we know. And bringing recyclers in there at the very, very early stage and use their knowledge helps to design better materials. At least that is my point of view. To do that, and now we get to a couple of pictures. We saw that before from Simon and others, that we have these. And to really cover this huge amount of information, we have to structure that. We make it very simple, that we have more all the things, these blobs Simon had, are in principle, in my view here, just represented by one very simple thing. But I still can associate data now with it. And I can look at the mixture, have characterizations of the mixtures. I go then down and get more and more information. And this looks in principle then like that, that you go here, have a view on your value chain in principle, starting with the raw material production, and so on and so on. And you fill in data on the functionality, but also on then the SSBD criteria. And even if that is, you are not physically here, because you still have a virtual material you design, you can still put information in here. This needs a data structure. Sorry. For some reason, I jumped somewhere completely different. So, we need a data structure, and this is where we now come together. Because in principle, you have all this data, they are distributed, federated, somewhere lying in the world, but we need to get together. This is something I ask for help. It's not that we have the solution, but I think what you presented the 2 days is exactly going into the direction. We need this federated system. That is just the pink version of this picture. We have to find everything here. This is a little bit, Jesper gave the presentation on the ontologies. We also now have to include the SSBD in there that we find for a material the correct data. We hope that we can use here data from the DPP. And there was a question yesterday if we need all or that we assume that there will be DPPs. That should be DPP. Anyway, if we have also for all the intermediates and pods and so on, if there are all DPPs at the end, I hope they are, because then we can use the information. And we then also produce the same typo here. Good. And now I came to my wish list, because there is something which, as Steffi said, we hope that we can use DPPs also somewhere else. But it also means that we have a little bit of a wish list which we have to implement. They are not directly part of the now established DPPs, but I hope we can go there over time, not now, but in the next years. Governance was already very often mentioned, and I think cross-domain, cross-sectoral is really important, that we can transfer data from one to the other. I think having a clear idea how we can transfer data which is confidential to only the people we want to share it with is extremely important. And then there is these links, material commons, absolutely important that we work on the same framework. We hope that we can get more of these finer-grained information in there. We also hope, because we are at these early stages of innovation, we also hope that there is something like a preliminary or intermediate passport where we can use data with less information or less certainty, with some kind of predictions which we know that they are not correct 100%, but they still can give you information. And this is then, I think I have to go a little bit faster. I think quality, saying giving your every piece of information in a DPP also a quality stamp is important. And for that, we just started yesterday a new project where we will look at exactly what quality documentation actually means. Yeah, and there are just a couple of buzzwords what different people think about what quality means. And I really think here we have this reproducibility, replicability, but also then relevance, yeah, for what I can use my data for. And perhaps you cannot use it for regulatory aspects, but you can use it in early design. That was everything. Thank you.
Thank you.
Thank you, Thomas.
you.
Also, best in time. as every time, just a joke. But we have time for questions.
Yeah, I have a question. You pointed at the digital material passport as an innovation going forward, and we see this in the project we are working on. We focused originally on the digital product passport, but we found out that what we are developing can as well be used for a digital material passport, and that there would be a use also for documenting secondary materials in the second, third life, etc., provenance, other chemicals of concern that may be mixed and so on. So that, because there's a lot of concern with safety of recycled materials, I think this is a key issue on the safe and sustainable by design going circular. So I agree with you there that it is quite important. And also, as you mentioned, that it's necessary to have the DPP bringing all this data from the safe and sustainable by design framework to the other actors down the value chain, so that they know where are the unsafe, where are the hazardous materials that have to be there, how are they contained, and when they're going to dismantle or do whatever they need to do at the end of life, they can then protect themselves and others in the handling. So, yeah, information, knowledge do increase safety, and it's not just the absence of substances that we sometimes cannot actually not have. So very interesting. Thank you. Other questions? Okay, then we can go for coffee.
Coffee, yeah?
Yeah.
5 minutes.
Everybody is here? Okay, perfect. We can start. So good afternoon, everyone. My name is Arnaud. I'm very pleased to be here with Marvin Ball, you already know. I'm part of the SMEA SDPP team, so it's a real pleasure for me to be here in front of you. And we will see together the section 7 concerning the industry data ecosystem. So just before introduce this topic, this session will explore how standard, digital twin, and ontology and approach for SMEs combine to build robust and interoperable industrial data ecosystem. So for the first session, for the first topic, I call Caroline Bernier, research engineer at CEA Airlist and SIRPAS Consortium coordinator. We will present the result of the activity of volunteer cross-project research group that is building interoperability between AAS and RDF data modeling framework. Caroline.
Thank you. So I'm very, very happy and proud to present not my work, but the work of a very large group of projects and individuals, and the result of what I consider to be really an incredible collaboration. And this is a volunteer cross-project working group, 17 publicly funded projects, 32 researchers and 24 organizations working together to write a paper that was published 1 month ago on this very topic. I think in my career, it's the first time I write a paper with 31 other colleagues, and I'm extremely proud of this. So why did we create a cross-project collaboration is that we understood that there are many, many, many teams in many, many EU and member state funded projects that were simultaneously trying to solve the same problem. So we decided to join forces to create solutions faster and better. And the goal of this group is to support the technological convergence between two of many other data modeling approaches and frameworks that are often cited and often used in the context of European DPP implementation and DPP implementation beyond Europe as well. So this is the AAS and the RDF approaches, and AAS, as you know, is often used in digital twin in Industry 4.0 manufacturing industries, whereas RDF is often used in web-based digital industries and knowledge engineering and management industries. So the goal was to build, or is to build, a number of open source tools in support of AAS RDF interoperability. So in the context of this talk, interoperability is only semantic and including the syntactical interoperability. We're not going beyond this level of interoperability, so we're limiting this to this scope. And of course, there are many other possible data modeling approaches. For example, in the construction industry, they typically use another data modeling framework that is not either of these, right? So we could do that work as well. But we picked two, and we followed a bridging approaches to create interoperability between these existing standards, but we don't want to create a new standard. So we have a number of motivations for doing this. The first one, of course, is to ensure compliance to the Data Act, Article 35, which defines the requirements for harmonized standards. And the first one requires that the standards achieve interoperability between different data processing services that cover the same service type. In the context of the DPP, this could be, or this might be, different DPP service providers that provide different DPPs using different data modeling frameworks. And another interesting one is the last one, Article 35 LE, which requires that the standards be designed in such a way as to allow for technical advances and the inclusion of new functions and innovation in data processing services. So this is exactly the point of this collaboration. A second set of motivations is that, of course, in a circular economy, we can imagine that we're going to be receiving products with passports that are modeled according to different data modeling approaches. And whatever the DPP I'm receiving, I want to use the data in it, right? So we want to build solutions to reuse data from whatever DPP we may be receiving. And a third set of motivations is to explore the complementarity between these two modeling frameworks, so the simplicity of the AS approach and the formal knowledge engineering capabilities offered by RDF. So we structured the approaches and the motivations in 3 sections. So the first one is to consume. So basically we're going to consume RDF data as input to AAS data. And inversely, we want to produce RDF data as the output of AAS data. And then, of course, we want to be able to do the round trip. And we want to exploit RDF data management capabilities within AAS ecosystems. And we want to do this, and we want to demonstrate this with concrete software. So we wrote this white paper. I will have the QR code with the link later if you want. So the white paper contains 2 or 3 pages of motivations, why we want to do this, going a little bit further than what I said. And then it describes the ongoing work of 13 different organizations and teams and projects that are currently exploring one approach to achieving this. And the paper ends with a set of recommendations. So building on the fact that AES and RDF have strengths that can be leveraged, so this is like a starting point for the paper. And in particular, AES provides structured, simple, modular, and use case-different frameworks, whereas RDF and JSON-LD offer efficient expression of explicit semantics, flexible data linking capabilities, and a very mature ecosystem of tools for validation, querying, reasoning, and integration. So we want to really use these 2 strengths together. Amongst the main recommendation is that we recommend that dereferenceable identifiers be used to link semantic references rather than IRDIs, which are commonly used in the IEC Common Data Dictionary. And then we also recommend that an additional JSON-LD serialization be added to the AES specification to make it easier to integrate AES data into linked data environments. So this is a kind of visual representation of the entire paper with the motivations on the top, the recommendations on the bottom, and the bubbles in the middle represent the teams doing specific work and exploring specific approaches to achieving this, and they're organized according to produce, consume, and manage. So I promised to give you the QR code to the paper. So it's also on the Surpass 2 Zenodo, so it's easy to find. We published this 1 month ago, and we already have more than 1,000 views, so that's quite exciting to see that there's interest for this work. And so this paper is really the beginning of a collaboration, I hope, that will continue. The goal is to continue building on this cooperative work to make these tools more mature, because for the moment they're results of projects, and of course bringing such tools to standardization activity would help this approach mature. And we also have many other ideas for structuring for exploration of the complementarity of these different approaches. I thank you for your attention.
Thank you, Caroline. Any question for Caroline? We can maybe 1 or 2 questions.
thank you for your interesting work. Actually, my main question is about, I mean, from AAS, as far as I understood, you generated DPP based on AAS, I mean, but to what extent this is domain specific, this process, the whole framework?
I don't understand your question.
I mean, is it, for example, this is working for any DPP from different domains, or?
AS is a meta-modeling approach, so it could be applied to any it's a way to model data. It's approach. So there are many industries that use it. So I don't know, I couldn't list you all the industries that do, but it's a fact that it is used today.
Okay, thank you.
Maybe.
So I have a question, probably reviewing the last 6 presentations, so that were all about semantics and ontologies and mapping, which is obviously a challenge across the supply chain. What's your perspective on what AI will change on that topic in general? I mean, do we really need to solve the topic in let's say, only mapping, or we will have strong interpretation layers that can actually work with different ontologies and different semantics?
Vast question. So when you refer to AI, we have to know if we're talking about
interpretation at runtime.
You mean reasoning?
No, mapping at runtime, basically without semantic mapping.
So it depends on how, so you could use, of course, an LLM to do mappings, but then you have to check the result. So if you don't mind having errors introduced into your mappings, you can use an LLM, and I think it's a good first attempt, right? But if you need your mappings to be correct, then you can't afford to use LLMs, right? Or you can't spend the time checking every single thing, then you want to do explicit mappings, right? So I think there's value in both approaches. And then, of course, LLMs could be useful to generate ontologies, or at least a first version of one, right? But an ontology is a conceptualization of a domain. So that means you need domain experts to validate what the LLM spit out. So again, human verification to what? So, but the LLMs, they're useful for speeding up the work.
My question was mainly, I mean, as more and more industries are now adopting, let's say, passport-like concepts, we're looking at a massive amount of data modeling work, plus the mapping. So is that a feasible scenario?
Microphone to this.
Is it a feasible scenario?
Let's say the approach that we have, like we have the ontologies, we have the semantics, we try to map it with.
Again, it depends on how much error you can tolerate. If you can tolerate error, use LLMs. But if you can't tolerate error because it's that data and not something that looks a lot like that data, which is what the LLM will produce.
Yeah. I understand. I'm just questioning if it's scalable enough. Because obviously it needs like huge teams, efforts, resources to do that job. And if we also look at the timelines, is this the approach to go forward, or are there any other technologies that could speed up that process? That was my question.
That's why I believe that LLMs can be used to speed up the process to develop explicit vocabularies. But if I'm going to express my data according to some explicit semantics, that at one point I have to say that data means that. That's what semantic interoperability is about. I'm expressing my data with explicit meaning. This is what this data means, and I define what my data means. And I want everybody else to understand that because I'm responsible for my data. I can't have anybody else interpret my data in some way that I don't control and then blaming me for that, right? So explicit semantics is my legal certainty that when I'm sending data out to whoever is going to use my DPP data, the meaning is very clear, and because I'm going to be responsible, I'm accountable for the data I'm producing for others, right? It's my legal responsibility for this, right? I could be sued if my data is wrong or could be interpreted in an ambiguous way. Right? So it's in my personal interest as a responsible economic operator creating DPPs to make sure that my DPPs are issued with explicit semantics.
I'm sorry, we have to close this topic. Thank you very much, Caroline, for this really clear presentation. And for people who have other questions, can welcome you to discuss directly with Caroline. So for the next topic, I will introduce Christophe Attilakun, manager from Digital Data Chain Consortium. So the subject is Factor X. I will let him explain you what Factor X is. He will do better than I will. Okay. So Christophe.
Thank you very much. Yeah, so Caroline, thank you for your energy, as always.
Close to the microphone.
Good. Where's the hand microphone? Perfect. Thank you very much. So I'm representing today the Factory X project, and what I would like to show you is what actually was the idea behind it. So this was funded by the European Union and also by the German Federal Ministry for Economics and Energy, and some of the projects already have been managed or mentioned, like for example Catena X. So this was to automate the information flow within the automotive industry. And then it was decided that we need the same for factory equipment, because production facilities in Europe are extremely important, and to automate the information flow from the manufacturers of equipments to the factory owner-operators was very important. Good, so the Factory X project was entitled to develop for multiple different industries a technical foundation and shared services. And why is this so important? So many of the products that were produced in one industry are components for other industries and used there. So the one thing that you have to do is within one supply chain, you have to agree on a data space to be able to scale this. But it also has to be interoperable with other data spaces in different industries. So just think of a semiconductor, it will be used in the robotic industry, in the aerospace industry. So this was the basic idea behind it. And the main goal is really to make it scalable on industry level and to automate the information exchange. So many of the examples that we have seen regarding DPP and digital twin is focused on the end consumer. And there it is feasible to just scan a data carrier and then access the information on a web server. If you want to use this in the B2B industry, you have to be able to automate this. Good. So, as already said, this was the setup, and within the Factory X project, there were many use cases that were actually tackled, because they all have a component where you exchange information. And I was co-product owner of the collaborative information logistics use case, and what I would like to present you is now the outcome that we have here. Good, so as already mentioned, we are focusing on the topic of the supply chain for factory outfitting. So not the supply chain in regards of the product itself, but the equipment that you need to produce it. Good, so what is the basic setup that we find in industry? So typically, there are three approaches to enter the data space. So the first one is the Hercules approach, that is basically the same what you have in the Industrial Data Space Association specifications. The second one is the Leo approach, where you use the asset administration shell. That is what I will show you today. And there is the Orion approach, where you use OPC UA to exchange this data. Good, so this is the basic setup that you typically find in the factory outfitting industry. You have a product supplier, in this case it's a component supplier, you have a machine supplier, and you have a factory owner-operator who is then later like the customer. And he also uses services, like, for example, an industrial service provider who provides, for example, maintenance services. So what they all have are a kind of content management system. So that means the first one provides the content, creates the content, has it in his content management system, and it has to find its way to the content management system of the machine builder. So what we define in the project is there must be a kind of information provisioning service on the side of the first one that creates a component. Typically, we use here as format to deliver the digital twin the asset administration shell. And this is then provided to the machine supplier. So in this case, he is serving with an information receiving service and also an information provisioning service that he will use to provide the information to his customer. And from the IPS, the asset administration shell is then provided via the APIs that are defined, and in this case, the Leo port to the information receiving service. So this is the basic pattern that you always have. And this is now repeated. So the machine supplier has maybe from the production also information that he receives in kind of IT/OT services. And this will be merged with the information that he received from the component supplier. So then he creates an asset administration shell that represents the complete machine. And on the side of the factory owner operator, you have the same pattern. You have an information receiving system or service and an information provisioning service. And again, it is passed as asset administration shell via the Leo port to the owner operator. So, and this can be repeated as many times as necessary. So you can have a supply chain that is very deep, or you just can have 1 or 2 or 3 levels. Good. So what you typically also do is you provide information to your service providers. Just think of a maintenance service provider. He needs the manual instructions to be able to perform his service. So he also receives the information via the same approach with a Leo port. And he can receive the asset administration shell, but he also can add information to the AAS and send it back to the owner-operator. So this is bidirectional, and you see it here that all the arrows are pointing in both directions. Good. So in the life cycle of the equipment, what often can occur is that I would like to exchange a component, and maybe I don't want to involve the machine supplier, maybe the machine supplier is no more on the market, then I have to be able to access the information directly at the component manufacturer. And this is also covered with the same system. You can use an asset administration shell and an information provisioning service to directly provide information to your final customer, the owner operator. And this is also very important in kind of, for example, software updates, any kind of change notification. Good. So this is the basic pattern. And for the digital handover, there we have an example. This is a short movie from Codewerk. They're a medium-sized software supplier. And they made here a very nice video together with Siemens. So Siemens is providing this component here. This is within the Siemens system. And it is identified by an identification link, so the QR code with the frame and the black triangle. So this was actually the ID link. And now we are scanning the code on the equipment and accessing the information on their platform. And this is actually an asset administration shell server. So this is the basic principle that you can use for any kind of B2B information exchange within the industry. You also can access this and test it yourself. The slides will be provided, then you can open the Codewerk app here. You can scan the sample ID link from the product, and then you can review the information. Good, we said machine building. So typically machines are quite complex. So what you see here is a packaging machine from Ullmann, and it has, what do you think, how many components? 100? 1,000? Quite a lot. So all this information has to be provided. For example, you have to calculate the product carbon footprint for the complete machine and provide this. So, and they did the same with an asset administration shell, and I would ask you to scan the QR code now, and then you can access for a complex industry machine the digital twin. Good. So what I also brought with me as example, typically such a machine needs electricity, and this is an industrial plug that you see here. And this is a component out of the shelf that already comes with an asset administration shell. It has the ID link on it, and this is one of the components that, for example, could be reflected in this kind of complex machine. And I would just give it through the rounds and just scan the QR code with the frame and the black triangle. Good. This is not limited to one software provider, so especially for large corporations, they typically have an ERP system. Here we have an example from SAP, and we're on the owner-operator side. So when we receive, for example, equipment, the first thing that we do is, if the information has not already been provided to us, we create a request within the platform system and send this to the platform of the manufacturer. So this is the same principle that you have when you scan the QR code and access the web page of the manufacturer, but this is completely automated in the background. And just think of the machine with thousands of components. Imagine you would have to do this manually by scanning the QR codes of the components. This would simply not be possible. And that is the reason why we have to completely automate it for the B2B sector. The system on the manufacturer side receives the request, they review the request, and then they search the digital twin. And this here, for example, is a server at the manufacturer that could also access the information at the component manufacturer. Then when the AAS is found, it will be sent back to the platform system on the manufacturer side, and this will automatically send the information to the owner-operator. And he can then replicate the equipment information into his ERP system. And this is the important thing. So if we would like to scale this, it has to be completely automated. And that is actually what we proved within the Factory X project, to completely automate that process. Good. So what you have seen is factory owner-operator creates a request. The machine supplier receives it with a purchase order. He creates the digital twin as asset administration shell that can be pulled by the ID link, so the QR code with the frame and black triangle. But what he does, he pushes the asset administration shell and uploads the information with a delivery on the platform. So this is typically in the B2B industry what we would like to see, because this is very quick and completely automated. But of course, there are always cases where there is no direct relation between the purchase order and the manufacturer. In that case, you have to be able to also access the information, and therefore you also can use the identification link provided on the product. And that is actually what you now can experience yourself. When you scan the code, then it's actually this path that you're going through. And this is exactly the same what is foreseen with the DPP. No? So that means the approach from the DPP and the completely automated approach for B2B business can work together. They're using the same infrastructure. And this one here can be completely automated, but you still have the semi-automated approach. Good. And that's it from my side. Thank you very much. So, any questions? Paul.
Yeah, we have time for one question.
It could
would be a very quick question. You have talked about Leo. It's really interesting. I'm just wondering about Orion. It's a cloud platform, or I'm not clear. Orion.
Which one do you mean, the IEP or the SAP BNSC?
You mentioned about Leo, the slide. Do you remember? After that, they are Orion also.
Leo and Orion.
Too much animation. Yeah. You mean this one?
Yes, here.
Yeah, so this is actually just how you access the data space. So Leo is the approach when you're using the asset administration shell. Hercules is the one when you go via IDSA, EDC. And Orion is the one when you use OPC UA.
Okay, it's not the cloud platform.
It's not the cloud platform. The cloud platform was this one here.
Okay,
so this is the information exchange platform. That's the cloud platform.
Good, thank you.
Okay, perfect.
Thank you very much, Christophe Tilla. So for the next topic, I'm calling Cyrine Sophie. So just, I have to go. Oh, yeah, Cyrine Sophie, so PhD student at INSA Strasbourg. So she will introduce a semantic architecture for traceable interoperable battery digital passport with AI, automatic LCA, and data sovereignty. Cyrine.
Hello, everyone. Thank you for having me here. So today I'm going to present to you a semantic architecture for the digital battery passport. As we all know, nowadays there is an increase in the number of batteries as any other technology, and the problem is that the battery data is not following. So we have a data-centric challenge. And as we all know as well, the battery passport would be mandatory starting February 2027. Today we're actually facing three major challenges in in developing the battery passport. The first one is the data management. We all know that the data is actually heterogeneous and actually scattered along the whole life cycle of the battery. The second is traceability. So the provenance is actually hard to assign because there is a lot of intermediary actors in the value chain of the battery life cycle. And also the environmental impact assessment. So there is a lot of inconsistency when we try to apply the LCA methods, and the inventories are actually quite opaque, which makes it quite hard to have auditable and comparable carbon footprints. We know that the information actually exists, but it is scattered across the chain and fragmented. And the role of the battery passport is actually to close this gap. So why semantics and not just schemas? We all know that asset administration shell and JSON LD are actually quite good technologies for structuring the data and exchanging the data, but it still is the data is still siloed if we only use AAS and JSON, and it doesn't give us the capability to query or reason over them. But if we use semantic technologies as RDF, OL, and SHAC, it gives us meaning and proof, which enables us to query the data across several actors, and it gives us also the logical consistency and the reasoning. So I wanted to mention, as it was mentioned before, that these two technologies are actually complementary and not competing. The semantic actually adds the layer that the schemas don't reach. In our contribution, we, as it was mentioned also before, the digital product passports are usually life cycle knowledge graphs. So that's why our main architecture follows the life cycle of the battery. We have the beginning of life, which is modeled by the battery production ontology. We have the battery. We have the end of life, which is modeled by the battery reuse ontology, and then we have the battery life cycle ontology, which actually put together both ontologies. And in our future work, we would love to also model the middle of life by the battery use ontology. So to go into more details, this is the whole architecture of the battery lifecycle ontology. We have the different data sources coming, and then we have the ingestion and population into the ontologies by different methods. We use LLM-assisted population pipeline, especially for lifecycle inventories. Especially for life cycle inventories from published literature studies, for example. We also do manual entry, CSV imports, and we also want to do the BMS to RDF once we implement the battery use ontology. So we have our hub, which is the BLCO, or the DBP hub, and then in addition to this, we have the shackle validation to validate our data and to validate our data. We have the provenance, so each value in the ontology, in the DBP ontology, can be traced, and we also have the SWRR reasoning. And then as outputs, we will have the digital battery passport, we will have querying and analytics, traceability and provenance, as I said, and also second life decision support. So I wanted to say that each of our ontologies actually follows a modeling strategy. So for the BPO, we use mostly the GS1 traceability and ISO lifecycle assessment as standards, and the advantage is to have auditable provenance and footprints. In the DBP hub ontology, we use a type token passport identity separation, and the advantage is to have scalability, reusability, and precise traceability. And at the end of life, the battery life, we use actually a reuse potential index and a rule-based approach, and the advantage is to have an automated and explainable second life decision. So I'm going to explain in more details in each of the ontologies. So I'm going to start with the DBP hub, the DBP ontology. As I said, we use the type token modelization in the DBP system. So the type actually represents the shared design, the recipe of the battery model. So here it captures the battery design, the materials that should be used, the specifications, for example, the voltage, the capacity, the resistance, etc. And then we have the physical battery. So this represents the actual instance, the actual battery that is produced. And here we will have like more specification, like the identity, the production history, the usage, the condition, location. And then we have the battery passport, which is the authoritative record that describes the battery. And here we will have everything concerning the compliance of the battery. Moving on, this is just to show the overall architecture of the battery production ontology. So I just wanted to show that also the battery production ontology follows a modular architecture. So we use different modules that will help us in the traceability and also in the life cycle assessment. We have the flow module, the activity module, which is the process module, the location, time, the actors, and also the energy module. If like to go into more details, we have actually a published article about this ontology. So as I said, the modeling choice here is quite specific. Each BPO, the BPO ontology links each process to an LCE or bill of material flow. So we have we do track all the materials in and the products out, but also the energy used and also the contextual emission factors. So we know the site, the grid mix, and the time period. So in that case, the carbon footprint is not a fixed static value. It is computed from a trace production value chain, and it changes with the location, the time, and the data sources. This is just a detailed framework of how the carbon footprint calculation works, but I think I don't have time to go over that. Here I want to talk about the battery life and the reuse potential index. So to be simple, we actually use the battery operational history to calculate the reuse potential index that is an actual a normalized score that actually combine 3 independent stress dimensions. We have the electrical stress, thermal stress, and mechanical stress. This is done actually upstreams, and then we ingest this this indicator into an ontology, and we use SWR reasoning to fire rules over this ontology and get the index. We also have a safety veto, so this is actually very specific to the lithium plating of a battery. Depending on the RPI score, we can say if the battery can be reused in a specific application, if it can be refurbished or recycled. To finalize my presentation, I just wanted to give like an end-to-end demonstration. So for example, we have a battery pack arriving at an end-of-life facility. We do actually start by having by querying the history of the battery. So we can use one Sparkle queries to actually retrieve the full history of the battery from the manufacturer, production date, etc. We run the diagnostics that I talked about, like we can get the state of health, the resistance, but also the several stress indicators that I talked about. We infer the RPI, and then based on the RPI, we see if it's actually a second life candidate or not. If it is, we do a match application, so we have a taxonomy of like several second life applications, and based on that, because we have like for example, the power, the energy, and the round-trip efficiency of each application stored in our ontology. And so it does the matching between the end-of-life battery and the application, and we recommend a specific application to reuse it in. If the RPI is not above a certain threshold, or the safety veto doesn't get the if it's not good, for example, we actually recommend the recycling. And in that case, when we have the recycling, we can actually use the history, the query history, to know the material used and other parameters that would be helpful for the recycling. This is actually out of scope of our research, but it's actually quite possible to do. So key takeaways, I wanted to say that the battery ecosystem actually generates critical data that is actually currently lost. Semantic technologies gives this data shared meaning and interoperability. The DBP is both a regulatory requirement and circular economy enabler. And ontology-driven DPPs can actually automate compliance, second life, and recycling decisions at the same time. So this is it. Thank you.
Thank you. Thank you, Cyrine. We have unfortunately we have time only for one question.
Don't be so shy.
It was very interesting work, actually. Thanks. And my question is that about semantic matching. Suppose that we have a battery out there, and you have the tokens and everything that you mentioned. Is there any way to find the best match in your ontology or knowledge graph that which part of this or which ontology in your system match to an existing physical battery that we have?
Are you talking about the second life?
Yeah.
It's actually the last ontology, so it's the battery life. It's called like the last one that I showed.
Mm-hmm.
It's like the ontology where we actually specify. We have a lot of battery application, let's say, stationary batteries, light vehicle batteries, etc., with a lot of specifications that are actually stored, and then we do the matching.
How do you do the matching?
With the rules.
Oh, with the rules.
Yeah,
okay.
So we have a lot of rules, and these rules actually fire the decision, the final decision. Yeah.
Thank you, Cyrine, for this complete and very interesting presentation. So applause, please, for Cyrine. So for the last topic of this session 7, I call Maximilian Kuhn, a research associate at Fraunhofer. He will present how DPP revolutions consumer electronics by combining AI and data space to secure data exchange and transform compliance into circular opportunities. Maxime.
Yes. Thank you very much. Thank you for the introduction. So I want to present you some preliminary results that we have achieved in the data space for DPP project. It's a very small project. We are 3 different Fraunhofer institutes that work together, but we bring in all the knowledge that we have from different manufacturing X projects, different Horizon Europe projects. And we really have the goal to address barriers, especially from small and medium enterprises, and create practical solutions. So the challenge is that many companies, especially SMEs, currently lack feasible realization approaches for the DPP. Therefore, we want to implement a practical DPP management system that benefits mostly the manufacturers, refurbishers, and consumers. We want to minimize the manual effort in DPP creation and enable secure and role-specific data exchange. And also, we demonstrate the results for the consumer electronics sector. So we have 2 core pillars in the architecture. First is the data infrastructure. So we use data spaces based on the International Data Space Association specification for the exchange of DPPs. Security there is implemented with data space access policies and different access rights depending on the user role for manufacturers, refurbishers, and consumers. And for the DPP representation, we base it on the asset administration shell. We've heard today already quite a lot about data spaces and the asset administration shell. So I'm not going into detail here. What I want to focus on in this presentation really is to focus on the DPP creation, specifically with the approach to have it in 2 steps. First, to create DPP types for a type of a product, and second, to create DPP instances if you have thousands and thousands of DPPs that you want to create. So we have the example of a laptop. For example, this one. So there's quite a lot of these ThinkPads that we use at the Fraunhofer Institute. So we just asked our internal IT, hey, can we get one of these laptops that would go to a refurbisher and use this as a demonstration example. So the type for DPP type based on the asset administration shell could look like this, where you have these different submodel templates, and you have already filled in all the information that is specific for each of these types of products. And then for the instances, there's not that many data that you have insert anymore. It's just, for example, the date of manufacture, serial numbers, and so on. So let's take one step back before I go into more detail on this creation process. This is the CIRPAS2 reference architecture. I guess a lot of you have seen this already, and for us it is very important to closely align with existing standards and guidelines. So we base our approach mostly on this reference architecture, and for our scope we focus on the components that are related to the responsible economic operator, the independent operator, and the end user. And we implement the other components where it is needed for the data exchange. So for us, it really looks like this: a refurbisher, consumer, manufacturer, and then some central services like a DPP registry and a credential issuer that we need for the data exchange. And these are the user stories from the CIRPAS project that are related to these roles. For example, the manufacturer, they need to identify which data they need to collect for the DPP, collect it in an appropriate format, link the DPP to the data carrier, publish the information, provide access, and so on. And refurbishers and consumers, they need to request access to view the DPP data, but refurbishers also need to update DPP data once they refurbish the product and made changes to the product. Related to all of these user stories, there are building blocks from the CIRPAS2 project that you can see here up top. There's the DPP template finder. I won't read all of these. And below you can see components from the FAST ecosystem that we are developing at the Fraunhofer Institute. So it's a suite of software tools that are related for handling everything related to the asset administration shell across its life cycle. So from identifying, modeling, to development, sharing, and viewing. And they can be associated with the CIRPAS2 building blocks. And now I want to show, for example, for the creation and of the DPP type and the instances, how they relate, for example, to the template finder, data carrier creator, and so on. So for the first step, the manufacturer wants to create a DPP for a type of a product. First, they want to choose a DPP template that they can use. For example, there already exists, now we heard it yesterday, for batteries, a different submodel templates from the asset administration shell. And we made a best guess for a laptop what this could look like, also based on submodel templates. So a manufacturer could choose this as a starting point and then fill in all of the data for the laptop type. What they can do here is drop in different PDF files, for example, with maintenance instructions, carbon footprint certificates, and so on. And a large language model in the background will extract the information that is needed to fill in all of these fields of the submodel templates. So it's very easy to get a first starting point of a DPP for product type. It uses the submodel templates, and I mentioned the AI support. And then when you go to the instance creation, first there's a validate step in between, because we had this discussion before already. The LLM produces very quick first results, but they have to be validated. That's not feasible for every instance, so we really have this just at the first step of the DPP types, where it saves a lot of time and validation has to be done only once. But then for the instance creation, there's an explicit mapping between all of these data fields that are not filled in yet for all of the instances, and for two internal databases. For example, through a CSV export, you could have all the serial numbers and all the other instance-specific information. And then you can create thousands and thousands of DPPs through this mapping once you have the DPP type as an input. It also automatically creates unique IDs based on the ID link standard and makes the DPP instances available via an AES server. So we already mentioned AES servers as well. In the FAST ecosystem, we also have an implementation of the server that we use here in the project. So these are really those 2 points regarding the creation that I wanted to focus on. But I want to also briefly mention the data space concept that lies behind this. So for the data exchange between the manufacturer and the consumer and also the refurbisher, we use data spaces because some of the information in a DPP might be more sensitive, especially if the manufacturer wants to support refurbishers as much as possible, and not all of the consumers should have access to this information. They can use these data spaces and save all the information in the DPP. Then it's not necessary to have different data models for different data consumers, but just use one with different access policies. So we show this with the example of laptop refurbishment. I just want to briefly go through these different steps that we show here to kind of give you the story that lies behind this. So to summarize, in the first step, the manufacturer creates the DPP template from input files, creates the DPP instance for the physical hardware, the one that we can show, and generates a QR code that can be printed on the laptop. Then the first consumer can scan this QR code and sees a consumer view of the DPP that is exchanged through the data space that looks like this. So for example, they can see all of the different components that are inside this laptop instance. Then at the end of the usage phase, the laptop goes to the refurbisher. They scan the QR code, can easily retrieve all the information that they need for the refurbishment process. For example, which components are in there, but also more detailed information of how to remove them, what tools are needed, and so on. Run their diagnostics and update the DPP to reflect the changes. So once in the second life, another consumer scans the QR code on the laptop, they see an updated view with the new components inside there. And to wrap everything up, also part of the project is to look beyond compliance and also describe use cases where a DPP based on the asset administration shell can be used, because it's a very powerful modeling language. So we create a database where we collect different use cases to get all of these companies on board and really convince them that the DPP is not something they must do because of regulation, but also something that really benefits them. Thank you.
Thank you, Maximilian. Still again, one question. It was maybe very clear, no need. So what I can propose to you is to close the session 7. So thank you for the 4 speakers. So for them, your best and friendly applause for their subject and the presentation. So now I let Natalia continue the agenda.
Yes. Thank you very much. Okay. First, it is small changes in the agenda. Now, Salim asked me to say it on behalf of the poster session organization. Yeah. People are very tired. Yeah, after this session, first award lecture and the lecture about cost action, we invited all of you to go to take the drinks and go here for poster sessions. Yeah, it is some changes because people say it is too much to speak, and after that go to drinks and back. Yeah, it is some changes. But now it is my really great pleasure to invite here Professor Heinz Preissig. It is our great colleague, and Heinz is professor in system engineering and researcher, active in the field of digital engineering, digital data, and semantic interoperability for complex value chain. His work focusing in this formal modeling approach with practical industrial applications, and we're organizing this conference in the honor of Heinz. Now it is the lecture on view on DPP handling, and it is my great pleasure to give the floor to Heinz.
Thank you, Natalia. It's a great honor to have this privilege to give this lecture and have this honor to be here. Thank you. How does it work? Okay. So, I don't want to give you a whole lot of information. Actually, I was selecting 2 or 3 points. And the background is a little bit, when I started this DPP from some years ago, I was pretty much blank. I didn't know anything about it. And I started to, first thing, as an academic, you start to look at the status of these things and you start reading. So I started to read a couple of months to see and get an idea what this is all about. And in the project, I was responsible to look into ontologies. And I've been doing ontologies several years. In fact, I was basically the one that introduced it into the material community when we had a project with BASF, and we invited Dean to do standardization, and then we started to talk about ontologies. That stimulated the whole subject, and people picked it up, which was very nice to see. So one of the things then that came up was data technology, and the very first things is I ended up in Shackle, basically. And I've been since then doing some work in the Shackle domain, but I will not talk about that. So what was more important was to look into regulations and structures. So I'm very much a process engineer, so I'm basically mostly interested in the structures. There's a little bit on the Shackle stuff that came as well. There is the Darmstadt library, university library, has been doing software to translate Shackle into user interfaces. So you can bring a Shackle, you can generate the user interface, you can put it on the net, and you know that the data that the people put in is conform with the Shackle definition. Shackle has been introduced to check data, actually. So you know that the data that you put in is conform with your definition, and you don't need to check it anymore. Sorry, my voice always has a bit of a problem. So there are 2 major concerns that I have. There were the lowest level and the highest level. This was about 4 months ago when we had a meeting, and I was sitting there, we were talking with each other, and I was talking to one of my neighbors, and he said, you know, I thought it should work like that. So I went home and I started to write myself a little technical report. So not to me, in order to put it on paper. And some of these things is what I'll talk today. On the lowest level is the IRI, the International Resource Identification. So if I'm taking here the example of defining the IRI for an exit, I can hang on any kind of term from any language and it will be understood. So that gives me an internationalization almost for free. It's easy to do. All you have to know is a bit RDF, Research Definition Format. That was one of the things that occurred to me. So what you want, in order to talk with each other, you want to have a global language. And this offers you the opportunity to define a global language. You have to take that opportunity and work on it. And eventually people will pick it up and they will get used to it. And you will automatically get the interoperability down the road without too many problems, really. Because if you have the ontologies, you take the terms, they are linked to the IRS, and you're building your data models. So you link it automatically to this international quote language, which you can generalize. So to introduce a term with IRI very early in the process is essential. If you do experiments, at the moment the instrumentation companies don't do that yet, but Siemens is working on it. If you go into a plant, you're looking at the control scheme. I'm a control engineer also in the background. You find that each of the measurement devices, each sensor, each linking point has a tag. If you now take these tags and translate them into IRS, you are in business. You can immediately say where this particular temperature came from, where it came, what the pressure comes from. If you link it then to the term pressure and temperature in a QUDT or something like that, you know what it is. You know the location, you know what it is, you know precisely with what information you're dealing with. If you do it in simulations, you can exactly do the same things. You can use IRS or local identifiers in order to use it for variable names, for example. And you can write your equations in the variable names. You don't do that by hand, you do it automatically. But if you do that, then in my case, I found out that I can save almost 50% of the equations because I don't have to say, oh, that x is, by the way, that x. Because they do have two different names. They have two different IRIs. As a consequence, things become much simpler. You can do it for the properties by using for variables. And you have business ontologies. They do exist already. You can do that for products. You have domain-specific ontologies. And there will be more and more of those who come because you have all the standards that are defined, that are specific for product domains, which eventually will be ontologized. Well, a friend of mine has started with that 25 years ago in Aachen. It died, the project died, it hasn't been continued, but it has been recognized already at that time that that will happen. And eventually we'll have to go through the pain and actually do that ontologization of the different standards. I will come back to that actually a bit later. What I'm missing when looking into ontology, in the ontologies, is that a bit of should be more structure. What people are doing is they take natural language and translate that into an ontology. And one of the things is this introduction of combined terms. My favorite example was the coffee temperature. No, it's a temperature of the coffee. Well, thank you. So we should use the opportunity and actually restructure things. Think a little bit more, give the things more structure. Here's an example. If I take a cup, a glass, and a pot, and I have water, coffee, and tea, and I have temperature and color. If I do combined terms, I make 18 combined terms. If I have them separate, so I have the rheology from the material, from the properties separate, I will have 8 items in ontology. But I can always generate the combined ones in the application. So I should really think about the structure of the ontologies. The ones that I have seen, and also in the project that we have been doing, that were generated, use these combined words, because what happened is that people go to the industry and say, now, how do you call this? You get a term. How you call that? You get another term. You just put that into the ontology. You should take the opportunity at this point to give things a structure. And that should happen. So that was the lower level, the 2 things. And on the higher level, there's a couple of other things. So I think RDF is the way to go, or something of that kind. But RDF is kind of the assembler of the W community. It's the simplest form of representing things. It's 3-word sentences. It's subject, predicate, and object. Then you make the object again subject, another predicate, etc., and you form a graph. It's very simple. And you can basically do everything you want. And then the technology to analyze those graphs is fantastically well developed. It functions for very large systems extremely well. Sorry. So if I look at a production, so I say, well, that's a typo here, but it doesn't matter. So if I'm going to produce 2 products in a process, and I'm using some other ones in order to do so, and I need energy, take energy in, I may lose energy, I may lose some other things in the process. I get a unit in a network of production. We talked about linearity. This is not linear. Production is a network. It's at the very best case a tree. You have an awful lot of things that are being assembled into something. But it's definitely not linear. And you have recycle streams. So if I take the BASF example, and you describe the process of a production, you definitely have recycles, and you have a network of production elements. You have a flow sheet for a process flow sheet. And if you now go and simply translate for each of those streams, you make a DPP or something of that kind. It must not be a complete DP, but it must have that relevant information. Then I can also think of, I can do LCA with this, because I have the energy and I have the mass, so I can actually do analysis of the system. I will come back a little bit to that. First, the thing that is happening is that you get a linked system of DPPs, because the 2 products are going to be saying, I am depending on product A, B, and C. So if I'm going to look at product D, it will automatically tell you, well, you have to look at A, B, and C in order to follow the link. If you go to BA, it will do the same with its product that were necessary in order to produce it. So you can map the network again into a network of DPPs. Now I'm jumping. A lot of the thinking was going now, how is this going to be handled eventually? And I think what you need is some controller. I'm a control engineer on the side. And that controller here is going to have an awful lot of different tasks. One is it's going to be responsible for registration, the economical operator, the responsible economical operator. He will be responsible for registration of the product. He will be taking care of the DPP. and it will also control the user access in the system. The rest of it is going to be behind that scene. It's probably going to be distributed, and it's going to be somehow organized and maintained. So the whole complexity of linking information together is behind the controller. And it's not the task of the people that write the DPP to do that job. It will also be responsible to upload the data. My opinion, the data ought to be behind that controller and not at the industrial level, and not at the person or the group or the company that produces the DPP. It should be available up there. It's a responsibility to maintain it and have it sustainable. And that is something that should be done by the authority or by somebody that is licensed to do the job. So from the user point of view, you get some link in one or the other way, maybe through a QR code, to the DPP. That is a product that will go through the portal, that will go through the controller. It will pick up the information from the repository, and it will feed it back to the user. He will then see, oh, there's another one that I've been seeing. It's necessary to look at, one of those reactants that we had that came into the production, and I can do the same process again. And I get then the chain being built. Now, if I have an application interface, I can do this automatically. I can have a program that executes this with certain access rights. Like in this case, access right, and it could, for example, do the footprint, the carbon footprint, because it can go backwards over the network for this particular product and get the information about the energy, the material, etc. Another thing which you can do with this picture is you can also describe the transport. So you can say something comes in, the process is the transport, it needs energy, it needs, for example, packing material, it needs a product, you pack it, you put it there, that takes energy, you have energy to transport it, on the other side you unpack it, you take it out, and it becomes rubbish, or has to be recycled, has to be done something with. It's part of the footprint. If you talk with people from the chemical industry, then that part is a very significant cost. Okay, I have to speed up a bit. So, local sequences and knowledge graph, terminology taken from ontologies, the required authority relations and application domain delegated acts. So we have to ontologize all these things. And the other point I wanted to make is that all the regulations, they're basically laws. You have to follow them. As a consequence, they should be publicly accessible, and they should be for free. They should be not sold by Dean and other organizations. Doesn't make sense. And actually, no, I've read recently that there are court cases on that. So people have been opposing this. Okay, the rest we can leave. The dynamics. How do you handle dynamics? And we'll go quickly over this. The point being that if somebody is doing a change, he has to report it. And it's the responsible economical operator that reports it. He's the owner. He has to report it to the system. He goes to the portal. The change is being registered, and it's going to be propagated upwards. So the DPP is changing on here, and the information is processing upstream. And each one that is going to use the modified version will have to update its DPP. And to some extent, one could also talk about, can one do this automatically? So if I have an application interface, that may be possible. So having just one slide on the middle, I'll have probably going to have licensed, authorized DPP businesses that are producing the DPPs. They are going to use information from the ontologies that are coming from the regulations and from the standards of the product domain. So the DPPs that are being generated, we can use Shackle to form applications. I think somebody actually mentioned that we may have these things on mobile phones. Yes, why not? So we can generate the framework of the DPP in terms of an application. I can give it to the epistemol that has to deal with it and go through the registration operation. And I can also think about giving this same kind of, or similar kind of program to the process itself, that if it changes something, that it automatically updates the DPP. Some final words: small is beautiful, be modular, don't mirror the natural language, and everything needs to be ontologized. Don't bother the user with regulations. I'm very grateful to this group of people with whom I had the pleasure to work over the last couple of years. Another group, a bit from the top down. And the 5 people with whom I interact mostly: Natalia, Peter, Salim, Franz and Martin. Many thanks for the last years. It was wonderful.
Any questions? Yeah, to speak. Today is 75 years jubileum of Heinz. Exactly today, his birthday. Heinz. Thanks a lot from the home community to all your work you did. It is from DigiPass and from DPP for EU. Yeah, thank you very much. And it is from the whole consortium and from all this audience. Thank you.
Thank you very much.
Okay, let's do it. And we have one small present from Sophie as well. Yeah, to you. Thank you, and maybe some words to you as well.
Happens to me about my daughter.
Yeah, yeah. So this is my father. Yeah. So my dad's had quite an international career, which means that us as a family have ended up quite international. I'm in London. He's in Norway. My sister's down in Sydney. So we're all kind of spread out. So it's quite unique to be able to be together, like on his actual 75th birthday. Just a little couple of words, Dad. You've come from far from Switzerland all the way through the whole world, all the way to Norway.
You got 5 passports.
And I got 5 passports in the process, I did. But this is probably the first time I think that I've worked with you, like where professionally we've kind of overlapped. Yeah. So it's been really nice, and yeah, it's been great to see the group, and just also how you've taught and like kind of gently pushed the groups to kind of think more positively and freely and in different ways, and you do it very, very well. But yeah, here's a little something from everybody actually to say thank you for being an amazing professor.
Thanks.
And yeah,
Thanks.
Thank you. And by the way,
Sorry, once more.
Oh, once more. And at the back here, you've got a little bit of a slideshow of all the little projects you've done.
That's the microphone for you, Heinz, if you want. Just,
Oh.
Yeah.
No, I'm humble. That was the last trial for me to go skiing, and it wasn't successful. I had to learn that one loses the balance with age. And that's not very healthy with skiing. Yeah, thanks. Super, thank you much. Thank you very much.
Thank you very much.
Wonderful.
So, and now it's the last presentation for today, Francesco. Yeah, it is from you, and we are going to cocktails and poster session all together.
We invite you for a drink, from 6:30 to 20. Enjoy yourself, actually connect with your friends and discuss.
But first
you listen to Francesco. Okay.
Yeah, I don't know how to stop this.
Okay. And, your presentation is this one?
No, this one.
This one?
Yes. Yeah. Here we go. Okay, thank you very much. Do you hear me? Yeah. For the introduction, for the opportunity to present our cost action here. So in this presentation, I will try to make it shorter as planned, so we can go for the drinks. I will tell you about what we do in the European Materials Informatics Cost Action, which I'm actually chairing. And I'll try to outline some links with DPP activities. So I think, can I use this one? No. Okay, never mind. No, is it working? Yes, it's working, sorry. So I think I don't have to talk too much about DPPs in general, the role of data, but what I would like to stress is the role of networking, collaboration, and in data sharing, which is actually one of the most relevant aspects in developing DPPs. So international cooperation actually can facilitate this kind of activity, and cost action are actually one of the tools from the European Commission that facilitate international cooperation on projects. So just a question, who of you is not familiar with cost action? Just raise your hand. Yes, just a few. So I think I have to say a few words about cost action. I think you got some contacts because you have to sign the attendance list all the day. So this is one of the aspects of cost action. So anyway, cost action are essentially networking initiatives funded by the European Commission for research and innovation on a given topic. So interdisciplinarity and inclusivity are key aspects of cost actions in terms especially of gender, age, and geographical distribution of participants, targeting especially the inclusiveness target countries that are the one here in green here in the map. So what do cost action fund? So cost action actually can fund a quite broad range of tools for networking, for growing a community, including support for the organization of meetings, workshops and conferences. They fund research visit for visiting foreign labs, other networking and communication, dissemination tools, and other tools. So the European Materials Informatics Network in particular, it focuses, of course, on materials informatics. So actually it is at the convergence of several fields in digitalization applied to advanced materials. So including, for example, artificial intelligence, advanced multi-scale modeling, high-performance computing, and so on and so forth. So actually, this action emerged as the cooperative effort of a quite broad network of proposals and participants with experience in digitalization applied to advanced materials and sustainability. with the idea of boosting synergies in the context and also creating opportunities in materials informatics. So what we are seeing is a steadily expanding community in the field, and this is also an indicator of a growing interest in materials informatics in general. These are some of our objectives, so I will not go through all of them to be quicker, but actually the general objectives are about collaboration in materials informatics, so in enabling collaboration in the application of digital technologies to materials development and applications of materials and advanced materials, for example, in industrial applications. At the moment, we have more than 300 participants across 42 countries. The action started in October 2023 and will end in October 2027, so we have still 1 year and a half to go. These are our 5 working groups, so especially the first 2 working groups deal with the more technical aspects of materials informatics, so data sharing essentially, and cooperative development of methods and approaches. So as you can see here, our action is linked pretty much with the DPP context, as materials informatics can support several activities of interest in DPP development, for example, life cycle development, the development of prediction models, for example, multi-scale modeling or data-driven modeling for performance and durability. We have seen several talks about that. Sustainability assessment, support to circular design, and in general, integration with data-driven infrastructure. So these are the technical building blocks of the action, actually enabling this interaction that are in the 2 main working groups. Working group 1 dealing with data sharing, so ontologies, metadata, and API. And working group 2 with the more technical aspects of materials informatics, so artificial intelligence, machine learning, and deep learning applied to materials. And this can have direct impact on several activities related to DPP and in general to development of interoperable infrastructure. So as I said before, collaboration and sharing are key aspects of cost action. So what do? What can we do together? We can organize together, for example, training school. We can implement short-term scientific mission. We can organize in general joint events related to materials informatics, as this one, for example. We can collaborate with other projects on standardization, share workflows, and well, the added value in general is the consolidation of a coordinated European ecosystem, so essentially joining forces. How to get involved? So this is quite easy, as our action is very bottom-up initiative. It's open to all interested participants, so you are welcome to join and to apply to join. We can offer funding, as I said before, funding opportunities to grants, especially for early careers investigators, for exchange, for visiting labs, for dissemination opportunities. We can offer also institutions the possibilities of hosting researchers fully funded by the cost action, and we also offer support for participation in external meetings, workshops, and school with full economic support by the action. These are some of the initiatives for the current year. So we will have our 3rd general meeting in Cluj, in Romania, in July. This will be our main event for this year. This will also host the finals for the Data Bridge Hackathon, so which is an hackathon about data sharing in materials informatics. That's why I think it's also relevant to DPP. So if you would like to accept the challenge, application is still open, so you can apply and try to win some prizes, including invitation to the in-person finals in Cluj in July. So this is one challenge for you, actually. We will have the 2nd edition of our training school on materials informatics, so hands-on on machine learning for research in materials science in Sarajevo next week, organized mainly by Amila, who should be around, yes, over there, yes. So if you, well, registration is closed, unfortunately, but you can still visit Sarajevo for the school. And so we will also organize the symposium at the Material Science and Engineering conference in Darmstadt in October, and we also have open calls for several grants, including short-term scientific missions. And this is a very basic concept for a potential case study design. I mean, it's not technically detailed, but just to show the potential interaction between a typical workflow for materials informatics and DPP developments. For example, we can think about the development of physical and data-driven modeling for predicting materials properties impacting on products. We have seen several examples of this approach. This is a typical materials informatics workflow, and we can also think about mapping the data produced by this workflow onto DPP requirements. At the same time, we can also make data fair, develop API accordingly, and in principle enable these DPP data feeds. So this is a very general approach. It's maybe very much abstract, but this is just to tell you that what we are doing, what our community is doing within the action is very much aligned with the potential, is potentially very much aligned with the requirements of DPPs. So if you have any ideas or you would like to test any proposal or any pilot, just contact us because we are happy to cooperate. How to participate and get in touch? So as I said before, the action is open for applications, so you are welcome to apply, also to get information. I think you can find also some information, some posters on flyers outside, and you are also welcome to contact me directly for any further information. Okay, thank you very much. You, no, it's still me. No, okay, no, it's your turn.
Now it's time for the poster session. The original plan was to have a 1-2 minutes presentation by each one of the poster presenters, given the time and that there are drinks starting at 6:30. Apologize that we are skipping that, and we will just wander around talking with the people in front of the posters, and then people can just repeat that 1 minute pitch, but in front of people talking in front of the posters.
With a drink.
With the drink that...
We keep the door open so people can flow out.
Now we have 10 minutes until like 6:30, so I invite you all to just go to the posters and start a conversation, and at 6:30 the doors will be, well, they're open already, but you can go to the cocktail.
Before you are going to cocktail, thanks a lot for a very hard today, productive day, for effective discussion, for all your contributions, for all chairs and your really good job done. Tomorrow we will start at 9 o'clock with the very nice agenda, and I hope without delay we will finalize at 4:30. Yeah? Thank you. Enjoy.
I wanted just to thank, our colleagues from CRIs and the people actually from the Martin and Arno. I don't know which is the name of your project. SPDD? It's complex for me. Okay. And Francesco by Omini, because it's with their financial support actually that we were able essentially to make this happen. Yeah, I want to applaud them. And Miguel. Thank you, guys. Thank you.